Today we are going to discuss just a orientation session, right? So today we are going to discuss just about what should be the syllabus, how we are going to study these subjects, and from where you will get the notes, right? All the things which is required to understand this particular subject, we are going to deal with that only. So we can say that syllabus discussion, right? Okay. Now everyone try to understand. First of all, a student who are new in this particular batch, I'm just saying that कि you have to attend the class in the regular manner. The first of all, you have to understand this thing. I will provide you for the after the every chapter, or not after the every chapter. Let me provide before the session only, right? So before starting to the new chapter, I will provide you the practice sheet. Every practice sheet consists of 40 to 80 questions. In some of the practice sheet, if the chapter is smaller, then there will be the around 40 or 50 questions are basically there. In some of the practice sheet, there will be around, you can say that 80 questions are basically there, right? So after the completion of chapter or during the chapter also, you have to solve those particular classes. You have to solve those particular things, right? After that, I will take a extra session for the question practice. How or which type of question practice? जो मैंने आपको sheet दिया, whatever the sheet I have provided ना, I will take this extra session on the weekend to solve those particular sheet. And that is going to be happen into the live format only, right? So let's start first. Let me discuss about the syllabus of this. You can feel in the digital logic, the first chapter is logic gate. First, we are going to discuss about the logic gate. In the all of the books, if you follow other institute, I'm fine, Dishant, how are you? So in the other books, if you'll follow now, then you can feel the always the first chapter is the number system. But I'm not taking the number system in the initial phase. I will take the number system into the last. But yes, I know that the sum of the portion of the number system is required to understand the digital logic. So whatever the topics required to understand the digital logic, I will discuss those number system topics, right, before the starting of the logic gate only. So before this, I will discuss about the basic part of the number system, and then we'll proceed with the logic gate. So in the logic gate, we are going to discuss about the NOT gate, AND gate, OR gate, NAND gate, NOR gate, inhibitor, like that. Inhibitor or inhibition. NOT gate, AND gate, OR gate, NAND gate, NOR gate, inhibition, XOR gate, XNOR gate. Like these type of logic gate we are going to discuss into the initial phase. So whether we can expect the question from this particular topic? Yes. In the last year also, from the last 5 years, if you'll observe, one of the questions are basically coming from the logic gates. And the beauty is the easiest question they're asking, right? So this type of chapter will increase your confidence, right? After the logic gate, we are going to start the minimization. After that, we are going to start the minimization. Now the question arises, so why minimization we are going to study? So everyone try to understand. Whenever we are writing any expression, right? And if expression is very lengthy, then to represent that expression into the hardware, more number of hardwares are basically required. If more hardwares are basically required, the circuit will be costly. And we want to design a circuit which is cost effective. So first of all, we do not, if any expressions are there, we are not able to directly make into the hardware. First, we have to minimize those expressions to the minimal extent. For the minimizing, there are several tools by which we are going to minimize the expression. Maybe the one of the tools are like Boolean algebra. Boolean algebra, which is developed by George Boole. Boolean algebra. And the second tool which we have to design, which we have to study, that is Karnaugh map, K-map. Apart from this, there will be the several other tools are also there, like Quinn-Mesklitsky method, that is also called tabulation method, but this is not in our syllabus. So we have to study these two things only, right? After the minimization, we'll start the third, that is called combinational circuit. Combinational circuit. Name itself says combination. So the combinational circuit means what? The output will depends upon the input. It will not depends upon the previous state. If anything does not have the previous dependency on the previous state, it means does not have the memory. So what should be the meaning of previous state or memory? Everyone try to understand. Suppose one of your friends asking you and demanding you to please give me 500 bucks, right? 500 rupees. What you will do? You will give him to, right? Give him 500 rupees. That don't make any difference in your life. And he promised you that he will return that particular amount into the one of the week, right? Within the one of the week. Now what happened? Suppose after the 1 week, you have called those particular friend, and now he's not picking up your call. You have tried for the one more week, but he is not picking up your call. Now, after the 1 or 2 or 3 week, he again right come with you, right? Come with you and demanding, okay, give me 500 rupees. Now it's time. I will definitely give you within the 1 week. Now you will take the decision according to your memory. Okay, I have already given the 500 rupees. He didn't return, even though he didn't received my call. Now again demanding the 500 rupees. So whether I will do it or not. So your action will depends upon the previous, the response or previous outputs also, which they have basically given, right? As well as the initial or as well as for the input also. उसने आपसे क्वेश्चन भी तो पूछा है कि 500 रुपए दे दो. So this is your present state. Now again they are demanding the 500 rupees. And the previous state's the output of this particular person. What happened? So by the combination of this, you are able to take the decision. It means the combination circuit means what? You does not have the memory, suppose. Whatever the people are basically doing, you are not going to remember it. That is called combination circuit. Again, the people are asking and demanding 500 rupees, you are giving. After the 1 week again is coming, again you are giving. It means your response does not depends upon the memory. You does not have the memory. That type of the circuit is called combinational circuit. But if you have a memory, you are taking the decision with respect to the previous output also. That is called sequential circuit, right? So in the combinational circuit, a circuit without feedback or memory are called combinational circuit. In the combinational circuit, I will discuss about the multiplier. Sorry, first comparator. First, we'll discuss the comparator. After the comparator, we'll discuss half adder. 2-bit adder are basically known as half adder. Then we'll discuss full adder. Then we'll discuss half subtractor. And then we'll discuss full subtractor. Everyone try to understand. Half adder or half subtractor means 2-bit adder or 2-bit subtractor. And whenever we are using the word full means 3 bits. So if you are dealing with the 3-bit, it will call full. If you are dealing with the 2-bit, it is called half. After that, we are going to discuss about the mux. Then demux. Then encoder. Right? So mux, demux, encoder, decoder. After that, code converter. code converter. After the code converter, we are going to discuss about serial ladder. Then we are going to discuss about the parallel ladder. Serial ladder, parallel ladder. Then we are going to discuss about look ahead carry ladder, LACA. Then we are going to discuss about the multiplier. Multiplier, which is going to multiply, right? Multiplier. After the multiplier, we are going to discuss about designing. CKT means circuit. After that, we are going to discuss about the designing of the combination circuit. Suppose new type of the combination circuit, if they will ask how you are going to design it. That's what we are going to discuss, right? Okay. Now, so comparator, half adder, full adder, half subtractor, full subtractor, mux, demux, encoder, decoder, code converter, serial adder, parallel adder, look ahead, carry adder. This is the fastest adder, we can say that, right? Look ahead, carry adder. Multiplier, designing of the combination circuit. So any type of the combination circuit, if they will ask how you guys are going to design, that portion we are going to cover here. Now, after the combination circuit, we are going to discuss about the sequential circuit, right? After the combination circuit, we are going to discuss about the sequential circuit. And one thing more, you have to make the notes during my class only, right? Do not try to attend the first class. Okay, so first I will attend the class. In the sequential circuit, we know that the sequential circuit means what? A circuit which having the memory. So circuit with the memory are called sequence. Whenever anything is going to be sequence, it means you know that who is in your right in front of you, right? So what should be your position? You have to understand. So we know that the sequential circuit is a circuit which having the memory, whereas the combinational circuit does not have the memory. So in the sequential circuit, we have to study the four parts only. The one is called latches. This is the smallest part of the sequential circuit by which we are going to design the memory actually. Memory are basically designed by the latches only, right? So latches. After the latches, we are going to discuss about the flip-flops. Latches. After the latches, we are going to discuss about the flip-flop. After the flip-flop, we have to discuss about the registers. And after the registers, we have to discuss about the counters. Only four things you have to study. Latches, flip-flops, registers, and counters. These four parts, right, are come into the sequential circuit. After the sequential circuit, we'll start finite state machine. Or right. One thing more I want to say. The finite state machine having the two parts. One is called Mealy FSM, and the second one is called Muri FSM. If you have studied, right, Mealy and Muri FSM. But we are not going to discuss these things in very much of detail because you guys are going to discuss the FSM in TOC, theory of competition, right? So in the TOC, you are going to study this topic. So right now, I'm just giving you the brief part that is called sequence detector only. How the sequence is basically going to detect it, like this topic we are going to cover here, the finite state machine, right? And how the hardware is going to be designed with the help of the flip-flops. That portion we are going to cover here. After the FSM, we are going to discuss some memory-based question, right? So we can say that delay. if the delay is basically associated into the any of the hardware, how we have to solve those questions. Even though this delay portion we are going to cover the before also, right? In this part also, in this combinational circuit, the delay portion we are going to cover into the sequential circuit. But apart from this, I will take this separately also. Right. After the delay, 7th portion, we are going to discuss about the number system. Number system consists of two parts, right? Number system consists of two parts. That is called, first one is called base conversion. First one is called base conversion. Suppose base 2 is there, how we are going to write into the base 5. Suppose base 5 is there, how we are going to write in the base 13. Like that, that is called base conversion. And the second part is called magnitude representation. Magnitude representation means if any numbers, I'm just giving you any number, how you are going to write that particular number. So magnitude means the value of that number, and representation, how we are going to write it, right? So this portion also consists of the two parts. One is called fixed point and second one is called floating point. Fixed point means what? The fixed point will come under, you can say that the that is called signed representation, unsigned representation, one's complement, two's complement, all are come under the fixed point representation. Floating point representation means this is the IEEE rule, right? So the floating point representation will consist of 32-bit or 64 bits, like that. Two types, single precision or double precision. One thing more, this topic we are going to note, we are going to cover in digital logic. This will going to be covered on COA, computer organization and architecture subject. So this part will come in detail into COA. So I will leave this particular part for the COA, whether the Vijay sir is going to be covered, whether Vijay sir is going to be covered this particular topic. I will cover the fixed point representation. So this is our syllabus, which we are going to deal in the digital logic. Sir, how much marks we are going to expect and which topic is important? One thing more, we already know that gate is unpredictable. So we are not going to predict it, from which topic is important, which topic they are not going to ask the question. But if we'll analyze the 30 years paper, then we can say that definitely the one question we can expect from the XOR, XNOR, like this topic, or NAND NOR topic. This is a little bit important. From here, mostly they ask the question, right? In the minimization, generally they are asking the question based on the K-map. In the combinational circuit, either they will ask the question on the comparator, mux, decoder, parallel adder. These are the topic. From there, frequently they are asking the question, right? On the comparator, you can see mux is very important, very, very important, right? Mux, you can write 100%. Every year they are asking the question on the mux. I don't know क्या है उनको गेट का कोई विशेष प्यार है mux से. Every year they are asking the question from the mux, right? In the sequential circuit, the flip-flops important, counters important. Registers also, if you know the counters, you know the registers also. Does not make any difference. From this topic, we can expect, right? In the base conversion, now everyone try to understand. Suppose two sets are basically there. So in the one set, they will ask the question based on the base conversion. In the second set, they will ask the question in the magnitude representation. So both topic in the number systems are important. So entire number system itself is important, right? We can expect the question from the number system itself. So here we cannot say that from which topic we can, which is important, right? Both are equally important, right? Now, sir, this is a theoretical, how you are going to study, sir, how will you study the theory portion? So everyone try to understand. every subject consists of the two parts. One is called theory, second one is called question. So from here, where you will get the theory and from where you will get the questions. That is the important thing. So ab samjho. So for the theory, if you want to discuss, you have a two choice. The first, follow Morris Mano. Double R आता है, but no issues. Tossy, Floyd. These are a very excellent book, right? So you can follow the Morris Mano, Tossy or Floyd. और एक हिंदी राइटर का भी है आरपी जैन, if you have understood one RP. This is also a very good book actually. So either you can follow these particular four books to understand the theory portion, or you can follow the classroom notes. Because I have made all the notes with the help of this book only. So if you follow the classroom notes, no need to follow this particular book. That is more than sufficient. तो या तो आपके पास दो choices हैं कि सर leave it the class, follow this particular book, you will understand all the concept. Or the one choice is leave this particular book, follow the classroom notes, because this notes already consist of this particular books. Right? Yes, Disha. Now, so classroom notes you can follow. So this is a theory, but how we are going to discuss about the questions? So everyone try to understand what is the question. So for the questions, what you have to do? For the questions, my dear friend, the first you have to solve last 30-year PYQ. Last 30 years PYQs. Last 30, you can feel this digital logics are basically, this subject is in other branches also, right? Other branches also. From which branch you can feel? This is in three branches, four branches actually. In CS, ये आपको चार ब्रांच में आपको दिखेगा. First, CS, EC. In the EC, the name of the subject is digital electronics. Third, electrical. Fourth, instrumentation. So what you have to do? You have to solve all the last 30 years problem. Or first, you have to start with the ECS. This is your first priority. After the completion of this, try to solve with the EC. One thing more you have to understand, in the EC, some extra portions are also there, which is not in your syllabus. Because in the EC, the name of the subject is digital electronics. So they will majorly focus on the electronics part also, how the logic gates are basically designed. Suppose node gates are there. What should be the internal circuit diagram of the node gate? This type of topic will never come into your syllabus, but still try it at least, right? नहीं होगा ज्यादा क्या फर्क पड़ेगा? So first CS, second EC, or at least whatever the topics are basically common, try to solve those questions from the EC. After that, it's electrical, and then in the last you have to solve the instrumentation. So if you solve these four PYQ, 30 years PYQ, try to understand this is more than sufficient for you. Because EC इलेक्ट्रिकल इंस्ट्रूमेंटेशन के बहुत ही ब्यूटीफुल क्वेश्चन होते हैं, नॉट इलेक्ट्रिकल, EC और इंस्ट्रूमेंटेशन के बहुत ही ब्यूटीफुल क्वेश्चन होते हैं. इफ यू आर एबल टू सॉल्व इट मींस CS विल बिकम वेरी, यू कैन से दैट पीनट्स फॉर यू. बहुत ही आसान हो जाएगा आपके लिए. नाउ आफ्टर दैट कंप्लीशन ऑफ दिस you have to solve. I will provide you the CS. If you guys require EC and electrical, then also do let me know. I will share it. Don't worry. After the solution, after this, you have to solve the practice sheet. You have to solve the practice sheet. How many practice sheet I will provide you? I will provide you the practice sheet, logic gate, लॉजिक गेट का एक प्रैक्टिस शीट आई विल गिव यू, मिनिमाइजेशन around 40 questions consist of, right, logic gate. So for the minimization, one practice sheet I will give you around 50 or 60 questions, right? After the minimization, combinational circuit. CKT means circuit only, right? So combinational circuit, I will give you one practice sheet, consist of around 100 questions. Equational circuit, I will give you two practice sheet, two of around 60 or 60 questions. So 120 question I will give you. For the number system, I will give you one practice sheet. So 3, 2, 5 or 6, 6 practice sheet you will get right from this, from my side. So around 300, 400 question you will get from my side to solve it. And that is a new question. It's not a PYQ. Sir, how we'll solve the PYQ? Okay, one thing more. Now, let me discuss about the weightage. What should be the weightage for this particular subject? Sir, क्या weightage है इस subject का? So everyone try to understand weightage analysis. If you'll follow in 2023, 2024, 2025, right? In the 2023, if you'll follow, approximately हर साल अगर मैं इसकी बात करता हूँ 5 to 6 marks. Same thing in 5 to 6 marks. But in 2025, 7 to 8 marks, around 8 marks का आया था. Right? So you can feel every year they are asking the question approximately 6, 7, 8 marks के आसपास का question पूछा जाता है. In 2024, right? इधर I think 6 to 7 marks का था. So and in this year, you can expect the 8 marks question they ask in 2025. And paper level was not that much of difficult. The paper level was very easy, you can say that, right? इसका जो questions होता है. So this is a weightage analysis. So in 2026 also we can expect at least 7 marks के question तो हम expect कर सकते हैं. Important topic already we have discussed, right? How we are going to study this particular subject. So some of the things I will provide you in a very detailed manner. And some of the things after the detailed manner, I will give you the short trick also to remember. अब होता क्या मेरे साथ, जब भी कभी मैं डिस्कशन करता हूँ और मैं शॉर्ट ट्रिक, whenever I will discuss and I will provide you the short trick, then the people will think, okay, ये तो मुझे रटने के लिए बोल रहा है. The short trick always required some memory. Are you getting my point? Otherwise, how can I say that okay, after the every class you are going to understand each and every concept, and not only you can understand, you are going to remember those subjects, those concepts also, right? So like that you have to do. Okay. Everyone write down yes or no, please. Everything is clear now. Let me, ये सब पढ़ाने वाला मैं कौन हूं, तो let me introduce myself also. मेरा नाम चंदन झा है. इज्जत से नाम नोट करेंगे आप लोग, right? And whatever the exam you guys are basically preparing now, I've also cleared those particular exam multiple times with the best rank is 23, right? After that, I have cracked the ISRO exam also and work over there as a scientist for 1.5 years. After that, I left the job and came into the teaching. Okay. One thing more, already I have given the idea, right? There are no such official groups. कोई official group नहीं है हमारा. So what you have, yes. So you can call me CSE, right? Now everyone try to understand there are no official group. Still, if you want to join and if you want to interact with me, You can join the Telegram channel. This is you can say that interaction, right? Okay, now how we are going to get this study, right? So today we are going. This is an introduction, right? Now where you will get the PDF, all the things. Let me discuss into the app, right? Okay, now everyone try to understand. GFG app is also there. All the things you will get here, right? Suppose जो भी एक batch लोगे, suppose this is your batch. So everyone try to understand. In the chapter, you will get here the Gate CS practice and previous year question. So whenever you want to solve the question, PYQ question, this is available here, right? Subject wise programming. देखो ये digital logic है. You will go into the digital logic. Logic gate and Boolean algebra combined कर रखा है. You have to solve like this. 30 questions are there, right? Gate CSE 2019 का question. Will add more questions also, right? Like that.
Sir, can you please tell me what is mean by the self-placement in the frame?
Okay, what should be self-paced? You are asking about the Gate CSIT self-paced course?
Yes, sir. Yes, sir.
Okay. What happened the last year? The GFG launched a recorded content course also last year. That is also available here. So this Gate self-paced means the last year, whatever the content taught by the teachers or mentors into the GFG, that are also available in the form of self-paced course. But again, this all videos are not available, or it is not for, you can say that, taught by the our teachers, right? ये सतीश सर खलील सर के द्वारा नहीं होंगे. जो भी कोई फ्रीलांसिंग कोई टीचर्स थे उन सब ने पढ़ाया था that. And in very short, now you are going to get a very comprehensive way, right? Like this you can understand. कैसे है देखो मैं दिखा भी देता हूँ. Digital logic. Suppose logic gates and minimizations are basically there. So you will get the video. इसमें तो हाँ 1 2 3 only 3 lectures are there in the logic gate and KMAP and minimization. I will take around 5 lectures for the logic gate only. So this is not that much of comprehensive way. This is very simple. You can say that, right? Very short when they are asking the question, right? Okay, so hope you guys understood. Okay. So PYQ will get there also. Now, what should be the meaning of XVN notes का तो हट ही गया ठीक है. Now all the classes you will get into the live. अब मैं क्या करूंगा today suppose अब ये तो मेरा बैच नहीं है. This is the something else batch. So you will get Gate 2026 Digital Logic Lecture 1 like this you will get. And you will find my name Chandan Jha. Timing also. So what we have to do? We have to do in one thing. In the today's class, I will upload the practice sheet also. And for the every class, first class of the chapter will provide you the practice sheet. Okay. So you will get the practice sheet. Where you will get the practice sheet? Like suppose this is the first class, right? Is there. So if you'll go into the resources, you will get the one classroom PDF. And after that, in the second PDF is also there, which is called DPP or practice sheet. Like that you will get. So both you will get like this. Okay. ये आपको क्लास के अंदर मिल जाएगा. And whenever the class is or whatever the timing and anything is going to be changed, all is happened or all is basically mentioned into this notice board only. In notice board पे आपको सारी information मिलती रहेगी. Right. Like this it is going to happen. तो ये मैंने आपको थोड़ा बहुत ब्रीफ कर दिया. Theory, you know that. So we are able to download those PDF. Yes, you are, Rohini, you are able to download like this. Look at here. Look at here. Suppose this is resources. Now we have downloaded here, right? You will get the PDF. So sometime the class is going fast, suppose. कुछ समय ऐसा होता है कि सब्जेक्ट बहुत फास्ट जाता है और नोट्स बनाने का आपको टाइम नहीं मिलता है. यू हैव टू अंडरस्टैंड द कंसेप्ट, सो यू विल गेट इट लाइक दिस ऑल, राइट? Understand. Right now, every subject, live subject, you will get here. Upcoming. So this is a live course you will get here. All the live classes you will get into the upcoming. And whatever the class happened, right? That the class happened will be available into the recorded format. And that will come into the archive like this. So here you will get the recorded content. Here you will get the live content. Live class recorded content you will get into the archive. In the chapter, self-paced means the previous year lecture you are getting. In live means in this year the fresh lecture you are getting. This is a live. Suppose data structure lecture 1 completed at 6 p.m. Now after the completed, it will come into the archive. Now what is going to be happen? Now all the lectures of the archive you will get like this. एक साथ मिलता है. So a little bit in the one subject, two subject, you guys are going to manage. But when the 4 or 5 subject happen, it's very difficult to find out, isn't it? हर बार आपको scroll करना पड़ेगा. So what we are doing, right, later on, already the tech team is basically working on it. They are taking the tab, right? Subject wise आपको यहाँ पर tab मिल जाएगा. So you have to choose the subject name, and those subject name, all the lectures you will get into the sequence manner. So Vaishnavi, are you getting my point? Very soon it is going to be happen, right? जैसे subject आप करोगे, already they have picked up and they are basically working on it. So you will get it. Dhanwant Singh. So I don't have no notes and contest section in the put. It does not require, even though I have given the idea कि remove the notes, right? Notes or context का क्या मतलब होता है? People who have taken, you can say that the placement batch, they will get the contest. Because whenever in the placement batch, lots of contests are going to be happen, right? And what is your rank on those particular contests, how you are going to attempt those contests. So वहां पर आपको यहाँ पे देखने को मिलेगा contest. And that's why I think you have taken the only one batch, right? Single. That's why no contest is going to be happen. Contest is corresponding to in the chapter you will feel here, right? Placement preparation. So placement preparation के साथ वो contest होता है. Suppose you have studied about the Python, right? Python आपने कर लिया practice, and now lecture you have shown, and after the lecture if you want to solve the questions, right? Like that you have to do. So everything you will get here only, right? I think everything we have covered in the today's class, right? This is just an introductory class, how it is going to be happen. So our order is like this only, right? Logic gate, minimization, combinational circuit, sequential circuit, finite state machine. In very brief, we are going to discuss mainly the sequence detector, after that delay, and after that number system. Anyone? Okay, so hope you guys understood. So we'll start the subject from the tomorrow at 6:30, sharp 6:30. So I'm leaving this session here only, guys. Still, if you guys having any doubt, any questions, you can connect me on this, right? So first lecture we have discussed about the basic part of the, or you can say that the syllabus discussion, and where you will get all the PDFs, right? Those portion we have covered. Entire things regarding to the app, web, all the not app actually, all the things related to web we have covered into the last lectures. Now in the today lecture, actually the subject is going to be, right? So this is a lecture number 2. This is a lecture number 2 of digital logic. This is lecture number 2 of digital logic. And in which we are going to discuss about the logic gates, right? So this is a logic gate. part 1, right? So first of all, in this particular class, I'm just going to tell you the what type of the mathematical tool, or we can say that the number system we are going to utilize in this particular session, right? Or in the digital logic. Of course, the number system will be the last chapter of our digital logic, but still some of the portion of the number system we are going to utilize into the entire digital logic. So the basic part we are going to cover in the try to understand. First, let me discuss the basic part of the number system. It's not a topic, right? It's not a chapter name. It's just a basic part we are going to cover, right? Number system, right? Okay, so everyone try to understand. The first, if you want to discuss about on the number system, if I want to discuss the basic part, how we are going to convert any number into the decimal, that is important, right? So everyone try to understand. In the number system, first you have to understand, if I'm just asking the one question, okay, this is a 1, 2 and C. What is the base of this number system? Can anybody tell me? Hexadecimal, what should be the base? Okay, now everyone try to understand. By observation of this particular number, right, we can comment what should be the minimum. We are not able to comment whether the base is 16 or not for this particular thing. It means if you are directly commenting, okay, base of the number system is 16, it's not true. So how we can say that? Always we have heard about the, if the C or C is there, D is there, alphabets are basically there, then the hexadecimal, the base will be there. No, it's not like that. So how? So everyone try to. I'm writing the one thing. Everyone try to understand. If I'm writing, this is called base. Either we can use the word base or radix, right? Radix also represent the same thing. So if I will write the base, and if I will write how many digits are basically, what type of the digit are basically present in those particular base. So we'll start first with the binary, right? So if the binary means base is called 2, and if any number system is binary, let me write binary, base 3, base 4, base 5, base 6, base 7, base 8, base 9, and base 10. Suppose any number system having the base 2, that is called binary. Then in the binary number system, only 2 digits are basically present, either 0 or 1. In the binary number system, only the 2 digits are basically present, that is called 0 or 1. Suppose any base number system is called 3. So in the 3, 2 base are present, 0, 1 and 2. Right, automatically getting disconnected. Please rectify the issue. Dishant, I'm not able to rectify it because its issue is going to be happen from your side actually. It must be your internet is slow. Dishant, are you getting my point? So if the base is 4, then total 4 digits are basically present, and that digit will be 0, 1, 2 and 3. Base 5, so it is called 0, 1, 2, 3 and 4. It base 6, 0, 1, 2, 3, 4, 5, 7, 0, 1, 2, 3, 4, 5 and 6. So total 7 digits are present. So you can observe whatever the base is basically there, base minus 1, right, till that the number will be present in those particular base. Suppose the base 8 is there, that is called octal. In the octal, up to 7 digits are present. Suppose if I'm writing base 9, So base 9 means up to 8 digit we can write. If I will write base 10, means up to 10 the numbers are basically present. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can fit. So total 10 digits are present. So everyone try to understand. If I will write 101 and if I will say what should be the base of this. So we cannot directly comment okay, the base is 2 because 1 and 0 are basically present into the every number system. Observe here, right? 0 and 1 will be present in the every number system. So we are not, if the base is x, we are not able to comment what should be the base of this particular system. But if I will ask what is the minimum base of the number system, then we can say that this minimum base will be 2. Because 0 and 1 will be there. So if the 1 is there, so minimum base is called nothing, it is just 2. Are you getting my point, everyone? Suppose I am writing 2, 3, if I will writing 2, 3 and 5. If I will ask what should be the base of this particular number system. Now directly we are not able to comment what should be the base of this number system, isn't it? 2, 3, 5 is there. We are not able to comment exactly the base of this particular number system. But yes, we can say that if the 2, 3, 5 is basically there, then we can say that 2, 3, 5 is there. Sir, maximum number is basically 5. So here the base must be minimum 6. And after you can feel if the 5 is there, 5 will be present into the base 6 also, base 7 also, sorry, base 7 also, base 8 also, base 9 and so on. Minimum base 6 is required, but base 7, 8, 9 and so on. If anybody will ask what should base up to 6, it's not base up to 6. Base will start from the 6, Sandeep. It's not up to 6. So if they will ask about what should be the minimum base, we can, yes, we can comment on the minimum base is basically 6. But we cannot comment the exact what should be the base, right, in this particular number system. Hope you guys understood, right? Now, suppose I'm writing the next one that is called suppose if I will write the base 11. Base 11 means what? Up to the 10, the digits are basically present. And the 1, because we have to write up to 10, isn't it? If the base is 11, means up to 10, the digit will be present. So, but 10 will be represented by the alphabet A. So, we can say that here, the digits will be present from 0 to because 10 we are writing like A. 11 we can write like B. 12 we can write like C, D. Right? Like that it is going to be happen. So, now 10 will be represented as A, right? If I will write the base 12, then the digit will be present. Oh, रुक जा भाई. थोड़ा लिख ही लेता हूँ. Then it is called 0 to 9. 10 will be A and 11 will be B. So 12, total 12 digits are basically present, isn't it, everyone? Suppose if I will write 13, 13 means 0 to 9. So now can anybody give comment? if I will write base 16, then the digit will be nothing, it is just a 0 to 9. A, B, C, D, E, F. So can anybody give me the answer? Okay, now I have already given the one question, that is 1 to C. What should be the base of this particular number system? So direct what is the base, we are not able to comment. But yes, if we'll ask what should be the minimum base of the number system, can anybody give an answer? What should be the minimum base of this number system?
13, I guess.
Huh?
13.
13, yes. Because C will come into 13, 14, 15. So C means what? A means 10, B means 11, and C means 12. So this is a 12. So whatever the maximum digit will be there, plus 1 is the maximum base. So this is 13, 14, like that it is going to be. Minimum base, if I will ask, then minimum base will be 13. Like that we have to say, right? Okay, very good. Now everyone try to understand. This is a very basic part, we can say that, right? Okay, now. If you understood this point, if we have understood this basic part, then we can say that. Now, everyone try to understand. Now the question arises, sir, because sometime we have to require to convert the any base into the decimal. Of course, this portion we are going to, what if the 70 something? Of course, we are going to discuss this part into the some, you can say that number system. But at this particular moment, if I will ask the one question, अगर मान लीजिए मैंने पूछ लिया आपसे क्वेश्चन कि सर, if any number systems are basically there into the sum of the base, how we are going to convert into corresponding decimal? Sometime before starting the number system, it is essential to understand into the sum of the other topics. So everyone try to understand. Any base to decimal conversion. Any base to decimal conversion. Right now. But before going to that, let me discuss the one thing. Everyone try to understand. Suppose you have given the 501 into base 10, this is in base 10, to the any of the person. आपने 501 रुपए अपने किसी दोस्त को उधारी दिया है. Suppose you have given. I know that आप लोग बहुत कंजूस हो, आप लोग दोगे नहीं. But still I am saying that suppose 501 rupees you have given to one of your friend. Now it's time to return back, right? If you required again the 501 rupees, what you will say to your friend? Ki give me 500, forget about the 1 rupees, or you will say give me the 1 rupees or forget about the 500. What you will say? I know that you are not going to forget even the 1 rupees. You required all the amounts, but still, क्या बोलोगे आप? Can anybody give an answer? Yes, Vansh. He said, give me the 500 rupees, forget about the 1 rupees. Why you are saying that? You give me the 500, forget about the 1 rupees. Because in this is a decimal number system, right? I'm writing into the means decimal number system. What we are doing, right? We are dealing with. So in the decimal number system, every position having the some particular weight. If I will discuss about this is called 10 raised to power 0. It is called 10 raised to power 1. This is called 10 raised to power 2. So actually, if you want to make it 5 into 100s are basically required, 0 into 10s are basically required, and 1 into 1 is basically required, isn't it? So the total, it will become nothing, it is just a 501. So what should be the meaning of this? Every number system having the some weight, right? Every number system having a some particular weight. If it is a 10, then the base will be, or weight will be 10 raised to power 0, 10 raised to power 1, 10 raised to power 2, like that. If it is a R, then R raised to power 0, R raised to power 1, R raised to power 2, like this. This is the weight. One thing more you have to understand. A coefficient, and this is called 501, is called nothing, it is just a coefficient, right? So one thing you have to understand, okay, whenever every coefficient corresponding to the sum of the particular weights. And apart from this, one thing more you can understand, this 5 having the highest weight and this 1 having the lowest weight. A coefficient which having the highest weight is basically called as most significant digit or bit. If it is a binary, so we can use a bit. If it is in the other number system, we can use the digit. So this is called most significant digit. Digit MSD. And the number system, I will use the word, in the binary, I will use the word MSB, most significant bit. And this is called least significant bit. डिजिट ही लिख देता हूँ अभी, LSD. In the binary, we are going to use the LSB. So MSB and LSB, most significant bit and least significant bit. Now everyone try to understand one thing more. Any base to decimal, how we are going to convert it? Suppose I am writing any base is basically given, that is called A2, A1, A0 point, A minus 1, A minus 2. And the base of the number system is R. Now if I will say, okay, convert this number system into the decimal. How we are going to convert? Always you have to remember the only one step, that is very important. And what is that step? Sir, what is that step? Sir, if it is a R, so definitely R is a base. So what should be the weight of this particular coefficient? That is A2, A1, A0, A minus 1, A minus 2, and so on. This is called nothing, it is just a coefficient. So this coefficient having the weight before the decimal, that is called R raised to power 0. This one having R raised to power 1. This one having R raised to power 2. And after the decimal, the weight will be into the minus power. Minus 1 and minus 2. And now if you want to convert into the decimal, do one thing only. Very simple, it's not a complicated topic. You have to multiply the weight with the coefficient. So A2 into R raised to power 2 plus A1 into R raised to power 1 plus A0 into R raised to power. What actually I told you earlier, we are going to start from the very scratch, right, from the basic thing. And then only we'll go into the detailed, right? So this is a very basic part, right, we are going to deal. Plus A minus 1 into R raised to power minus 1 plus A minus 2 into R raised to power minus 2. This is the answer you will get. Whether this is applicable in the any base? Yes, this is applicable into the any base, right? Sir, how? So let me take the one example, right? Let me explain with the example. And that is the example is, suppose if I will take, suppose I'm just giving you the one example, I'm asking the question. If it is given 1, 0, 1, 1, and this is in base 2, can anybody convert into the base 10? This is essentially required to understand. If 1, 0, 1, 1 is basically there, can anybody give an answer? What should be the base? What should be the, right? Yes, it's very simple. Sir, how? If it is a base 2, so definitely it is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. So if you want to convert it, always you have to multiply the coefficient with the weight. That's it. So 1 into 2 raised to power 3 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 1 plus 1 into 2 raised to power 2. So if you want to write it, it is called 8 plus 0 plus 2 plus 1. So this is called 11 into base 10. This is the answer. Very simple. 2. Why 2, 3, 4 in base 5? Can you convert into the decimal? Can you convert into the decimal? Yes, sir, definitely. How you are going to convert? It's very simple, sir. So we know that if the base is 5, 5 raised to power 0, 5 raised to power 1, 5 raised to power 2. बहुत ही बढ़िया. So 2 into 5 raised to power 2 plus 3 into 5 raised to power 1 plus 4 into 5 raised to power 0. Like that it is going to happen, right? Yes. So 25 into 2, that is called 50. 15 plus 4. So this is called 69 in base 10. That is answer. Very simple. It's not complicated, right? Isn't it? So now suppose one more question I'm giving you, right? Suppose I'm giving you one more question, and that is the question is like 2AC in base 16. And I'm asking convert into the base 10. Can anybody give me the answer? Now you have to remember A means called nothing but just a 10, B means 12, and C means called nothing but just a 30. So if you want to write it, it is called 16 raised to power 0. Always first you have to find out the what should be the coefficient and what is their weight. So 16 raised to power 0, 16 raised to power minus, 5 minus 1 plus 1, and 16 raised to power 2. So this is called 2 into 16 raised to power 2 plus A into 16 raised to power 1, C into 16 raised to power 0. Still, yes, very good. Tulika, Urnisha, मैकाल, बहुत ही बढ़िया. रोहन, अर्चिता, अद्भुत प्रदर्शन है आप लोगों का, बहुत ही शानदार. So if you write, this is called, अब सॉल्व कर लेना आप, ये 2 into 16 raised to power 2 plus A means 10 into 16 raised to power 1 plus C means 12 into 16 raised to power 0 means 1 only. If you'll add it, you will get into the answer, right? And answer will be nothing, it is just a 684 into the base 10. You will get. Very simple, right, Ramya? Isn't it? बहुत ही simple. अब इतनी चीजें clear है? And okay, hope you have joined, all of you have joined the Telegram channel, right? Isn't it? So I will ask the some of the question to the Telegram channel also. So you should be active into the Telegram channel, right? That is Chandan Jha or CJ sir, digital, right? Or gate. Now, suppose if I will ask the one question, one more question I'm asking. Can you convert into the decimal? Ki sir, 8 raised to power 0, 8 raised to power 1, 8 raised to power 2, 6 into 8 raised to power 2, plus 4 into 8 raised to power 1, plus 8 into 8 raised to power 0. If you are solving, this is a wrong. How we can say that this is a wrong? Because how could be the base and the internal digit will be same? It's not possible. Na? If the internal digit is 8, then base must be greater than 8. The minimum base will be 9. Here the written the base 8. So definitely it is wrong, isn't it? This itself is written in the wrong format. This format itself is wrong, isn't it, everyone? Understood it? This is an invalid question, yes. Now, if you have understood this point, let's move into the next one thing more. Suppose any number system is there and that will be into the binary. So now how many of you are able to understand ki yes sir? Now you will give me the any of the base I'm going to convert into the corresponding decimal. How many of you are able to do it? कि सर दुनिया में कोई भी बेस दे दो सर, ऐसे कन्वर्ट कर लूंगा सर. Very good. That's great. That's great. That's great. Very good. Now everyone try to understand. Very good. Now if I will ask the one question, right, or before going to that, कि sir, in the binary, if 2 digits are basically there, 2 bits are basically there. In the binary, 2 bits are basically there. Then how many combination of the 2 bits are basically possible? How many numbers we can write? Four combination we can write, isn't it? That is 0, 0, 0, 1, 1, 0, and 1. And if you want to write the 4 combination is, right? Sandeep, Nalugu. Nalugu. In the Telugu, I know the only one word. That is Arda Mainda or not. Right. So this is a binary. And if you want to write into the corresponding decimal, if you want to write into the decimal, 0, 0 means 0, 0, 1 means 1. If you convert into the 1, 0, it is a binary. So 2 raised to power 0, 2 raised to power 1. So this is a 2 and this is called 3. So if I will give you the 2 digit of the binary, always you are able to write the 4 combination. That is 0, 0, 0, 1, 1, 0 or 1, 1. Corresponding the decimal will be 0, 0, 1, 2. Now, suppose if I will give you the 3 digit. Sir, this is the digital logic? No, no, no. Now we have not started the digital logic till now. Right? 5 or 6 classes will take and we're going to discuss the basic part which is required to understand the digital logic, right? So अभी तो शुरू भी नहीं हुआ. If the 3 bits are basically there, then 2 raised to power 3. Total combination will be how many? 16. I think anybody having to open the mic? किसी का mic on है, I think. You can feel if the binary numbers are basically there for the 3 bit, the total combination will be 8, right? That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1. 0, 0 to 1, 1 we can write. कोई बात नहीं. Dishan, Dheeraj bhai. Now the decimal will be, it is 0, it is 1, 2, 3, 4, 5, 6, or this is 7. So you can write in the binary, if the 3 bits are basically there, from 0 to 7 we can write. And the corresponding binary will be 0, 0, 0. You can write like also 4 times 0, 4 times 1. Then 2 times 0, 2 times 1, 2 times 0, 2 times 1, 0, 1, 0, 1, 0, 1, 0. And the conversion will be 0 to 7. If not 3 bit, if I will write into the 4 bit, how it is going to happen? The 4 bits are basically there. How many combination will be there? For the 16 combination, right? From 0 to 15, that is the total 16 combination will be happen, right? So let me write it also. On the binary, if you want to write, total 16 combination will be there, right? और we can write 8 बार 0 होगा, 8 times 0 0 0 3 4 5 6 7 8 and 8 times 1. Then 4 times 0, 4 times 1. Two times 0, 2 times 1. Right. And then we can say that 0 1. This is a binary combination, right? Now, if you want to convert into the corresponding decimal, if you want to write, right? So this is 0, this is 1, this is corresponding to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, up to 15 we can write. So what actually required? Whenever in the digital logic, right, till number system will start, if I will write, okay, we have a 4 digit, you should know, the total 16 combination will be there like this. If I will say that, okay, I have a 3 bits only, so you should know, okay, 8 combination will be there. If I will say n bits are basically there, then total number of combination will be 2 raised to power n. So we can say that if n bits are basically there, total combination two raised to power n, right? In the binary, you have to remember like this, right? Okay, now if you understood this point, let's move into the next, right? Okay. सर ये तो बड़ा सिंपल सा टॉपिक था, तो मैंने कब कहा भाई टफ है? इट्स वेरी सिंपल. Okay, now nothing more you can understand. Whenever I will write 2 raised to power 0, maybe in the calculation, maybe some of the people do not require to. 0 to n minus 1 will be the decimal. Absolutely correct. बहुत बढ़िया. 2 raised to power 0 means called nothing, it is just a 1. 2 raised to power 1 means 2. 2 raised to power 3, so we can write 4. Sorry, 2 raised to power 2 आएगा पहले. So we can write like a 4. 2 raised to power 3, we can write like a 8. 2 raised to, मैंने क्या बताया? I'm just going to start with the scratch, right? So don't think अरे ये सब क्या पढ़ा रहे हो, ये सब तो मुझे आता है. So I'm going to deal the some of the things which you are not going to remember, right? Or you do not know actually. So basic part also you should understand. और एक चीज और बताता हूँ everyone. पानी में डूबता वही है जो सबसे अच्छा तैराक हो, ध्यान रखना. जो तैरता आता है जिसको, वही पानी में डूबता है. So the people who are thinking that they have a good knowledge, most of the time they are not going to qualify the GATE exam. I know that, not few, n number of the students. In the initial phase, they are thinking, okay, I know everything, and they are going to judge the teacher, right? They are basically sitting, writing the copy and sitting like this. Okay, tell me, अरे मुझे तो आता है. And those type of people, I know that, right? N number of people, they have not qualified the GATE exam because you are learning only the approach, the theoretical portion. You have to think all the number, all the digital logic from my angle actually. You have to learn this subject not from your perspective. You have to learn the subject from my perspective. Sir, what happened after that? After that, without using the pen also, you are able to solve the question. Are you getting my point? So like that, you have to understand all the things, right? So 2 raised to power 5, so this is called 32. 2 raised to power 6, 64. 2 raised to power 7, understand?
2 raised to power 10 is called 1024, and this is also referred as a kilo. K. 2 raised to power 10 is also referred as a kilo. 2 raised to power, after that, if I will write 2 raised to power 20 is referred as a mega. 2 raised to power 30 is referred as a giga. 2 raised to power 40 will be referred as a tera, like that. Now again the people will confuse, right? क्या confuse होगा कि sir kilo तो 1000 is referred as a kilo, so everyone try to understand. That will be happened into the some other units. Whenever the data will be there, then kilo is called 2 raised to power 10. But whenever the length, weight, like that type of the time, frequency, then the kilo is called nothing, it is just a 10 raised to power 3. I will write it also, don't worry. So kilo. Now everyone try to understand one thing more. Sometime I will refer as a bit, right? So bit, if I will write a bit, bits means nothing, it is just a 0. These 2 digits we are going to utilize for the bits, right? I will write bits. The group of 2 bits. Group of 2 bits are basically considered as a dates. If I will use the word nibble, group of 4 bits. 4 bits together considered as a nibble. Bits, dist, nibble, and now if I will discuss about the next one, nibble के बाद, if I will use byte, 8 bit together, after that word और ये सब होता है, but till byte you have to remember. Group of the 8 bits are basically considered as a nothing, it is just a byte. Now everyone try to understand one thing more. If I will use KB, this type of notation means this is called kilobit. If I will use KB, consider as a kilobyte. So whenever I will use the capital B means that corresponding to byte. Small b corresponding to bits. Like that you have to manage. Okay. Now everyone try to understand one thing more. Yes, true, Sandeep. One thing more you can understand if you understood this point. Ki sir, whenever the unit is length, weight, time, frequency, right? Like that of the units are basically there. Yes. Can you repeat about the kilobyte once again, please? Right? Yes. This is just a notation. Kilobytes. KB means kilobyte means what? Whenever I will use the K and capital B, generally we are going to refer, right? That K and capital B means K means kilo and capital B is corresponding to byte. Small b corresponding to bits. Suppose I will write 2 KB. So means this is called 2 into 2 raised to power 10 into 8 bits. If I will write 2 KB means 2 into 1 bits. Like that's the meaning of this. Understood? Hello? Yes, sir. Okay, that's great. Now everyone try to understand the next one. If I will use the length, weight, time, frequency, like that type of units we are going to utilize, then the kilo means 10 raised to power 3. If I will use mega, 10 raised to power 6. If I will use giga, 10 raised to power 9. Like that it is going to be happen. But whenever we are using the data, means we are dealing with the bits. bits or byte or like that, it is going to be happen, right? Then kilo means 2 raised to power 10. Mega means 2 raised to power 20. Giga means 2 raised to power 30. Like that, it is going to happen. So always you have to understand, because in the digital, we are going to deal with this also, or we are going to deal with this also, right? Right. Okay. If you understood this point, let's move into the next point. Okay, one thing more I want to tell you. Any expression today is the very basic, right? Fundamental class, you can say that. So everyone try to understand. Whenever any expression, suppose we are speaking, right? I'm just giving you the idea about the digital logic, and we are using the English word right here. In the same manner, in the digital logic, whenever you want to express the any logic, then you have a Boolean function. Boolean function is a language of digital logic, you can say that. So whenever you want to write any of the things or logic, then the Boolean functions are basically required, right? So if I will write the any of the function, दुनिया में कोई भी बात बोलने के लिए in the digital logic, the language is Boolean function. Sir, what should be the meaning of the function? Means suppose if I'm writing a comma b, like a bar b plus a b bar, like this is called nothing, it is just a function. So this is nothing, it is just a combination of the variables, right? Okay. Whenever the any functions are basically there, we can write this function in two ways. Suppose we are speaking, right? So whenever I want to say any of this statement now, there are two ways to write the any of this statement. One is called active voice, second one is called passive voice. In the two way, I will say the same thing. In the same manner, whenever you want to write the any of the expression or any of the functions, there will be the two way to represent, right? दो वे होगा उसका रिप्रेजेंट करने का. The first one is called, either you can represent this function into the sum of product, that is called SOP. One thing more, everyone try to understand. This topic in very much of detail, I am going to discuss into the Boolean algebra. So at this particular moment, I am not going to discuss in very much of detail, only the very basic brief part, right? I am just telling, because we are going to discuss these things into the logic gate also, so that you can understand. So whenever the any functions are basically there, we can write the any function into the two way. One is called sum of product, we can write SOP, and the another one is called product of sum. That is called POS. So same expression can be represented in the two way, either into the SOP, into the POS, or in the POS. Both are looking like different, but both will represent the same function. दोनों दिखने में अलग अलग होते हैं, राइट? वो सुना होगा ना आपने, same but different. So same but looking like different, right? अरे गाना सुनते हो, सॉन्ग same but different, नहीं क्या था? हाँ यही था शायद कुछ. Okay, now everyone try to understand. Now whenever you write the any of the expression, right, in the SOP, if you want to write, देखो कैसे होता है, everyone try to understand. Suppose I am writing any function like AB plus AB bar. Suppose A bar B bar. Suppose I am writing like this, A bar B bar. So this is called sum of product. Why we can write the sum of product? Because first we are doing the product and then we are summing up. So whenever you want to implement it, first we have to product and then we have to sum. And that's why it is called sum of products. So lots of products are there and then we are summing up. That's why it is called sum of product. If you want to write in the POS form, suppose this is called A plus B, या A bar plus B बोल देता हूँ, A plus B bar. If this type of expression is there, this is called product of sum. Because first we are doing the sum and then we are doing the product. So product of sum, POS, product of sum, it's going to happen. Are you getting my point? When this type of expression we are writing, this is called, sir, how we know that? Whether it is a, I will discuss, right, how we are going to write it later on. But मैं बता रहा हूं अभी कि दुनिया के हर एक फंक्शन को लिखने के दो तरीके हैं. And both will represent the same thing. Either we can write into the SOP or we can write into the POS. It's your choice. Whether you want to go with the POS and if you go into the SOP. Most of the time I will deal with the SOP because it's easier. Because everything is very, you can say that I'm just going to deal with the SOP in such a manner. You are going to learn the first SOP. That's why it will become very simple. But believe me, POS is also very simple, right? Okay. अब देखो. Now, if you write into the SOP, then this is called one term. This is called one term. If there will be the another things is also there, this is also called term. So, in SOP, this is called term. So, in the SOP, all terms are referred as mean term. In the SOP, each terms are referred as same but different. Okay. वो था. SOP, some of the probably you can say that mean terms in this SOP, every terms are referred as mean term in the similar manner. In the POS, all the terms are known as max term. No, Sandeep. By the De Morgans, we cannot convert the SOP into the POS. SOP we have to deal with the separately. POS we have to deal the separately, right? So by the De Morgans, we are not able to convert it. But yes, by the De Morgans, we can convert the mean term into the max term. Their individual terms we can change, but it's not SOP POS. So everyone try to understand. SOP is not a complement of POS. Even though POS is not a complement of SOP, both are basically different things, but represent, way is different, but representation of the same function. Their terms are called mean term, their terms are called max term. These individual terms are complement of each other. So we can say that max term complement of this, right? Like this it is going to be happen. Try to understand. Max term and mean term are complement of each other. Now, how we are going to write in the SOP or the POS form? So I'm just giving you the one thing, right? Everyone try to understand. Or don't write into the notebook. First, focus on the screen. Suppose 2-bit combination I'm taking, right? Suppose if I will write into the decimal, suppose I'm writing into the decimal, and now if I will write into the binary. So in the binary, 2 bits are basically the combination will be there, right? A and B. Suppose I'm writing, if you want to write into the binary, then I'm choosing the 2 variables in which the binary bits are basically stored, right? And these are basically either 0, 0, 1, we can write 0, 1, 1, 0, and 1, 1. We can write like this. Now, anything we can write into the 2-way. One is called mean term. So if I will write into the mean term, how it is going to be happen? If 0 in the mean terms, means, everyone try to understand, minterm means 0 we can write as a complement of variable, and 1 we can maintain, or we can think like as it is variable, and between the variable we have to use dot. Or even though if the dot is there, if you do not write the dot, it does not make any difference, because writing the dot or do not write dot, both will say that the variables are going to be in the product form, right? So we can write a bar, 0 means a bar, 0 means this is b bar. So either we can write dot or you can does not make any difference. For this one, if you want to write in the mean terms, 0 means complement of the variable, 1 means as it is variable. 1 means variable, 0 means complement of variable. 1 means as it is variable, complement as it is variable. Right? Like that it is going to be happen, right? Okay. If you understood this point, let's move into the next, right? Now, if instead of mean term, so in the mean term, you have to understand the one thing only. Ki 0 means complement of variable, 1 means as it is variable, we have to write. So everyone understood how we are going to write the mean term? Everyone write down yes or no? Are you there? Yes. Okay, that's great. Now, if you want to write very good class, right? Believe me, I'm enjoying your class just because of your response. बहुत ही बढ़िया. And that's what you have to do throughout the journey, right? Okay. Max term. How we are going to write into the max term? Max term is just a reverse of min. SOP and POS is not a reverse, but min term and max terms are basically reverse. So how we can say that? In the max term, 0 means as it is variable, and 1 means complement of variable. So in the min term, 0 means complement of variable, 1 means as it is variable, yes. But in the max term, the reverse order we have to think. Because min term and max term are complement of each other. So in the max term, 0 means as it is variable, 1 means the complement of variable, and between the variable we have to use plus sign. So suppose for the 0, 0, if you want to write into the max term, this is called 0 means as it is variable. So A, 0 means as it is variable, and between the variable we have to use plus sign. So 0, 0 in the min term it is A bar B bar, in the max term A plus B. 0, 1 means in the min term A bar B, but in the max term 0 means as it is variable, 1 means complement of variable, and between the variable we have to write plus. अब बहुत सारे बच्चे ऐसे भी बोलते हैं. Everyone try to understand. Some of the genius scientist people who will think like, oh, सर तो बोल रहे रटने के लिए, ये तो लॉजिक नहीं बता रहे हैं. अरे वो रटा रहे हमको, लॉजिक तो बता ही नहीं रहे. They are not discussing the logics. They thinking, okay, you have to remember like this. So everyone try to understand one thing. When you were in LKG or UKG, then the madam will tell you ki 0, after that 1, 2, 3, 4. Have you asked the question कि after the 1 why the 2 is basically coming? क्या आपने उस समय पूछा एक के बाद 2 ही क्यों आता है? Have you asked the question कि why you are writing the 2 after the 1? Why not you are writing this type of symbol before? Because this is a basic part, you have to remember it, right? If you know this part, then on the application you can utilize the addition, subtraction, like that type of the things in the similar manner. Whenever the digital logic will start, first we have to learn some basic concept of the digital logic, some terminology of the digital logic. When you learn those things, then we are going to apply those things into the application. From there the question will ask, right? 101 means complement of variable, 0 means as it is variable, between plus we have to write. 1 means that type we can write. Now everyone try to understand one thing more. Everyone try to understand. Now, I'm writing the function. There will be no function, or we can say that as a f, right? So I'm writing this function by my own. There will be no logic for it. इसका कोई logic नहीं है. That will be always given in the problem. I'm writing it like 1 0 0 or 1. So this is just an example, right? Let me write. Even though in the last class people are basically asking the question like, sir, how you are writing like 1 0 0? This is just an example I'm writing right now. Now, if you want to write the function into the SOP form, so I can say that suppose I'm writing in sum of product. Suppose the expression I'm writing into the sum of product. If I will write the sum of product, right, f. So this function will be what? For the sum of product, we have to choose the minterm, because in the SOP, every term is called minterm. So we have to choose the minterm for the function of 1. Whatever the position the function ones are, basically, I will discuss the logic also. Why for the 1 only we are selecting. But we are going to discuss those things into the number system. At this particular moment, we can say that whenever the sum of the product SOP is basically there, for the SOP, we have to choose the minterms, but we have to select the minterms only on those positions which having the 1 into the function. So here the 1, so we can select it. Minterm A bar B bar. Now it is 0, so do not select. This is 0, do not select. It is 1, so we have to select AB. And between all the minterms, we have to use plus sign. This is called sum of product. Same thing if you want to write the product of sum. Product of sum. Everyone try to understand. Now, if I will write into the product of sum in the post form, how it is going to be happen? Everyone try to understand. In the reverse order, you have to think for the POS. It's not complement. Reverse order, you have to think. For the SOP, we are choosing the minterms for the function of 1. In the POS form, we have to choose the max term for the function of 0. So whatever the 0 is there, we have to choose max term. Whatever the 0 is there, we have to choose max term. So everyone try to understand if you want to choose it. The first max term will be A plus B bar. Second max term will be, and we have to use the dot between A bar plus B. So this one will also represent the same logic, same function. And this will also represent the same function. Only the expression looking like different, but they will represent the same function. So same thing will be represented by the two ways. One is in the SOP, second one in the POS, right? Now, if you understood this point, everyone, just move into the next, right? If you have understood this point. Now, let's start the subject, right? Not subject, actually, the logic gate we are going to start, right? So what we have learned till now, the basic part we have discussed, right? Okay. Now, everyone try to understand. Let me discuss about the logic gate. Let me discuss about the logic gate, right? In the logic gate, the first logic gate I'm going to discuss, that is called NOT gate or inverter, right? NOT gate. Either we can use the word NOT gate, or you can use the word inverter, or we can use the word negation, inverter, negation, or you can use what the complement logic, everything having the same meaning, right? NOT gate, inverter, negation, right? All having the same meaning. Now everyone try to understand one thing more, right? What is the symbol of this NOT gate? So either we can use like either we can use like this, or you can use the bubble before the triangle, does not make any difference. Or we can use only the bubble, that is also does not make, all are basically the same. So three types of the symbol we are going to utilize for the inverters, NOT gate or negation, right? And what happened to the NOT gate? If you'll apply the 0, you will get 1. If you'll apply the 1, you will get 0. In short, we can say that if we'll apply the A, the output will be A bar. Either we can write A bar or A complement, both are basically same. A bar or A dash, whatever you can write. A bar. Now, everyone just give me the answer. Is it possible that whenever you will apply the 0, immediately you will get 1? No, sir. Every circuit having the some delay. If we'll apply the 0, after the some time you will get 1. If you'll apply the 0, after the some time you will get 1. Immediately we are not able to get 1. Because every practical circuit having the some propagation delay. Right? So let me discuss about the propagation delay also. So this is called propagation delay. Everyone try to understand what should be the meaning of this. Whenever we'll apply the input, then time required by the circuit to produce the output is called propagation delay. It means to get the output of the any logic or any of the expression, when the inputs are basically connected, are called propagation delay. Input को propagate होकर output बनने में जितना time लगता है, this is called propagation delay. So we can say that time required by the circuit, time required by the logic to produce output when inputs are connected. When inputs are basically connected. So how much time is basically required to get into the output when the inputs are basically connected is called nothing, it is just a propagation delay. Maybe it will be the decade, ECE, centi, nano, pico, femto, jepto, in the any of this scale, micro, but definitely every practical circuit having the sum of the delay. And this is called nothing, it is just a propagation delay. I'm just representing the propagation delay with tau PD. It is just a notation. Tau and this is PD. PD means propagation delay. This is just a notation, right? Okay. Maybe some of the people will write TPD, it's fine. Some of the people may write T, TD, any notation you can use, but I'm just using the tau PD, that's it. The meaning of this one is called propagation delay, that's it. Now the question arises how the propagation delay will happen. So before going to that, everyone just to give me the answer. If I will use the one circuit is there, right? In the input, this is the input and this is the output. And this is called output. Now can anybody give an answer? If I'm applying the input at t equal to 0 and output will get at t equal to 2 microseconds. So can anybody give an answer? What should be the propagation delay of this circuit? If we'll apply the input at t equal to 0, the output we are getting at t equal to 2 microseconds. What should be the output? How much the delay associated with this particular circuit? Propagation delay of the circuit we can write 2 microseconds. Suppose if I'm asking the one question, if I apply the t equal to 5 microsecond, at t equal to 5 microsecond, we are applying the inputs. And output will get at 12 microsecond. Can anybody give an answer? How much delay is associated with this particular circuit? 7. Very good. So this is a 7. So top ED is called nothing, it is just a 7. Right, okay. So everyone try to understand, it means whatever the inputs are basically there, suppose this is a time frame, right? In this particular circuit. So if I apply the t equal to 0, the input is there, right? Input. So output you will get at t equal to 2 microseconds. Output you will get. So if you apply the input here, the output will start from this particular point. Isn't it? तो आपने यहाँ input लगाया तो output आपको यहाँ से मिलना शुरू होगा. Similar manner. In this case, if we'll apply the input at t equal to 5 microsecond, input we are applying. So output will get at t equal to 12 microsecond output will get. So here we can say that the delay, right? This much is a delay. यही delay होगा, that is 7 you have calculated. What are the unit? If a special unit exists for the type of the measurement, no Harshit. Delay is just a time. Delay is called nothing, it is just a time. And what is the unit of the time is second. So always you will get into the second only. Now before the second, maybe micro, nano, that is the value actually. Right? 2 second means we cannot say that the 2 is just a unit, right? Unit is the second. 2 is just a value actually. Right? So always the delay you will calculate it into the second only, right? Okay. Now, everyone try to understand. Suppose I am giving you, this is a NOT gate, right? एक क्वेश्चन आपसे पूछता हूं, suppose this is a NOT gate. Now everyone try to understand. Suppose I'm writing the input is X and output is per Y. I'm just giving you the one question. What the input will do, right? What output you will get? Output will be complement of the input, right? And what is the complement? 0 having the complement 1 and 1 having the complement 0. If you want to represent it into the, you can say that into the signal waveform or signal, then 1 means high voltage, 0 means low voltage. 1 means high voltage, 0 means low voltage. Like that you have to do, right? So suppose if I will ask in this question, Suppose I'm giving you, this is called X. Right, okay. Suppose I'm giving you, this is X. On no voltage. No, 0 means low voltage, 1 means high voltage, right, Sandeep? At this particular moment, don't think it is a no voltage or high. 0 will be the high, 1 will be the high voltage, 0 will be the low voltage with respect to each other, right? Maybe 0 will also represent as a negative voltage also, maybe the 0 volt also, maybe the 10 volt also, and then 1 will be represented as a 12 volt. It's also possible. It's not like that. Forget about this. This is a part of electronics, right? At this particular moment, we can understand, everyone. Suppose the X we have applied here, and the delay of the node gate is delay of node gate is 0. Can anybody give an answer? What the output you will get? What type of the waveform you will get into the output? Sir, we have to complement it, nothing more than that, right? आप इसको complement करोगे, so it will be the looking like this only. Zero means we can write, जब low है तो high बनेगा, if high then low. No delay is associated, so directly we can design. Like that it is going to be happening. This is called your Y. Just flip the graph. Yes, correct. Sandeep, just to flip the graph. How many of you have designed in the same manner? How many of you have designed into the same manner? Okay, Rohini, what we have to do now? Suppose this is the input is applied and delay is 0. So do not do anything. Just flip the graph. 0, low means you have to make high, and high, so you make low. Like this you have to understand. Everyone try to understand. If you want to discuss this graph, this is called 0. So this is 0, this is 0, this is 0. This is a 1, so in the duration 1, 1, 1. This is 0, this is 0. This is called 1, this is 0, this is 0, this is 1. Like that it is going to be happening. So you have to flip the value after the node gate. So 0 will become 1, so 1, 0 so 1, 0 so 1, 1 so 0, 1 to 0, 1 so 0, 0 to 1, 0 to 1, 1 means 0, 0 means 1, 1, like that you have to do. Now 1 means high voltage, 0 means low voltage, we have made it. Rohini, understood? Right. Everyone write down yes or no? Okay, understood. That's great. So only we have to flip the graph right now. Now everyone try to understand. If I will ask the question, now if I will say the second part of this. Delay of this is called nothing, it is just a 1 second, suppose I'm saying. Delay of the node gate is 1 second, and each block will represent 1 second. Each block will represent 1 second, right? Can you sketch the output waveform? Can you sketch the output waveform now? If the delay is 0, then pink one is correct. But if the delay is there, then from where you have to start this graph? So if the delay is 1 second, so entire this pink graph is going to be shifted by the 1 unit to the right hand side. So we have to shift this graph. This is the reverse of this, right? But we will not get the reverse of this at immediately. If the delay is 0, then immediately we are getting. But if delay is 1 second, then we have to shift this graph to the 1 second to the right hand side. We have to start the graph not from t equal to 0. We have to, because the output will get from t equal to 1. So entire graph is basically shifted. This pink one is shifted by t equal to 1. So actually the answer will be, this is the answer, right? You will get 1 block we have to shift. Everything we have to shift 1 block. Now do not think whether it is a reverse is happening or not. One block we have to shift, right? Like that is it going to happen. And this is your output Y. This is not your output Y. This is just a reverse. But if the delay is associated, then we have to shift this output waveform by the one unit. Because output you will get after the 1 microsecond. So everything is basically shifted. You can feel this will appear here, this will appear here, this will appear here, this will go to this. So everything is shifted by the 1 unit. One unit is shifted, right? Like that it is going to happen. Understood, everyone? So whatever the start will t equal to 0, it will start for t equal to 1. So this part will come here, this part will come here, this part will come here, this part will goes here, like this. First step, because every shift in a t equal to 0 will not get, right? Hope you guys understood. Everyone write down yes or no if you understood this point. Suppose instead of 1 second, if the delay is associated with the 2 second, what should be the output you will get? Instead of 1, the same question if I will ask, and delay is related to NOT gate. Two seconds, suppose. And this entire is called, this is called 1 second. This is 1 second. All blocks are basically represented in 1 second. And you have to solve this question as a homework, right? Just take this question as a homework. You have to sketch the waveform of Y, right? And shifted by 2 blocks. Yes, correct, Sandeep. But aapko try karna. Now I'm just giving you the 2 minutes, everyone. Now I'm just binding this session. I'm just giving you 2 minutes, right? Whatever we have learned. Okay, sir, NOT gate completed. No, NOT gate started. We cannot expect the question into the gate. Okay, in the NOT gate, if you will apply the 0, what should be the output you will get? Okay, till 10. It's not like that. There's something else that we can expect, right? So what type of the question we can expect from the NOT gate into the gate examination, we'll discuss in the tomorrow, right? But at this particular moment, whatever I have just discussed, just to go through once. जो भी मैंने पढ़ा है, so that we'll get the summary of it, right? जो भी मैंने पढ़ा है, just to go through once, right? What we have learned, everyone. So first we have discussed the basic part of the number system, which is required to understand our subject actually. So first we have discussed whenever the any base is basically there, then the digit present in those particular base less than 1 value will be present. Total number of digit will be same as the base, but the exact value will be 1 less, right? Now, if the alphabets is there, if I will ask 2A, what is the base of this? We are not able to comment the base. Minimum base we are able to comment because A is called, in the 11 is also there. So we can say that 11 is the minimum base. But 12 is also possible for this 13 because A is present here also, here also, here also. Minimum base, if we will ask, that is 11. Then we have discussed whenever we are writing any number system, then there will be the some weight and the coefficient is there. Suppose the decimal number system is there, then coefficient will be from 0 to 9. This is coefficient. And weight will be 10 raised to power. So if we'll go into the MSB side, the weight is going to be increased. And that's why it is called most significant bit or digit. And this is called least significant of bit and digit. After that, we have discussed how we are going to convert the any base into the corresponding decimal. So we have to multiply their coefficient with their weight. So whatever the base is there, so you have to write before the decimal power 0, 1, 2, after decimal power -1, -2, -3, and multiply the coefficient with the weight, coefficient with the weight, coefficient with the weight, coefficient with the weight, and add it. This is called the decimal conversion. Then we have discussed the few questions based on this, right? Like this. Like this. Few questions we have discussed. Already, whatever we have mentioned the coefficient, already given, we have converted into the what we have written the weight and after that we have multiplied with the coefficient. That's it. One thing more, always whenever the problem is given, you have to think कि weight and the coefficient, base or radix, both are basically same. Either we can use the word base or we can use the word radix. Both are basically same. Internal, the maximum digit or digit will never same as the base. That is most important. Then we have discussed the 2 bits systems are basically there. Then 4 combination will be possible. 0, 0, 0, 1, 1, 0, and 1, 1. And the decimal corresponding value 0, 1, 2, 3. If the 3 digits are basically there, then 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. We have happened. And from 0 to 7. If 4 bits are basically there, then 4 times 0 to 4 times 1, the digits are basically present. And the number will be from 0 to 15. Then we have discussed 2 raised to power 0 means once like that only. 2 raised to power 10 means 1024, that is kilo. 2 raised to power 20 means mega. 2 raised to power 30 means nothing, it is just a giga. Whenever I will use bits corresponding to the 2 digit only, 0 or 1. Whenever I will use the word dits means combination of 2 bits are called dits. Nibble, combination of 4 bits are called nibble. Combination of 8 bits are called nothing, it is just a byte. Small b corresponding to bit, capital B corresponding to byte. That's what we have discussed. Whenever the length, weight, time, frequency is mentioned, apart from the data, anything is mentioned, then the kilo means 10 raised to power 3. Mega means 10 raised to power 6. Giga means 10 raised to power 9. But whenever the data are basically present, then kilo means 2 raised to power. Mega means kilo means 2 raised to power 10. Mega means 2 raised to power 20. Giga means 2 raised to power 30. Like that it is going to be happening. After that, we have discussed that whenever any functions are basically there, then we can write those functions into the 2 possible way. One is called sum of product, SOP. Second one is called product of sum, POS. The terms in the SOP are called min terms. Terms in the POS are called max term. Min term and max term are complement of each other. But I have never mentioned the SOP and POS are complement of each other, right? Both will, it's not a complement. Both will represent the same logic. Writing in the different way, but will represent the same logic. Then we have discussed how it is going to be happened. Suppose that 2 bits are taken 0, 0, 0, 1, 1, 0, and 1, 1. In the min terms, 0 means complement of variable, 1 means as it is variable. So 0, 0 means A bar, B bar, A bar, B, A, B bar, A, B. Max term means 0 means as it is variable, 1 means complement of variable. We have to use the plus sign between that. So A plus B bar, A bar plus B, A bar plus B bar. Whenever any function is there, so for the SOP, we have to select the min terms whenever in the function ones are present. In the product of sum, we have to choose max term whenever the zeros are basically present. Like that we have to do. Then we have discussed the NOT gate inverter negation. So if you apply the 0, you will get 1. If you apply the 1, you will get the 0. 3 symbols we have discussed. There will be the one terminology that is called propagation delay. Propagation delay means what? The time required by the circuit to get the output when the inputs are basically connected. Whenever we'll apply the input to any of the logic, then how much time it will take to produce the output. And every practical circuit having the delay. Generally, we are going to measure the delay into millisecond, microsecond, or nanosecond. In the digital logic, generally into milli, micro, and nano we are going to discuss. Milli means 10 raised to power minus 3. Micro means 10 raised to power minus, it's not a data, it's a time delay. So 10 raised to power we are discussing. So milli means 10 raised to power minus 3. Micro means 10 raised to power minus 6. And nano means 10 raised to power minus 9. That type we are going to discuss, right? Then delay we have discussed, this is very simple, right? After that we have discussed whenever the NOT gates are there or whenever any waveform is given. So complement means 0 means 1, 1 means 0. Low logic will be converted into the high logic will be converted to 0, right? So voltage different we have to write. And if the delay is there, then we have to shift the graph. So we have shifted it. And one homework question I have done, right? Not only this, few homework question more I just want to share. 236.37 in base 8. You have to convert into the decimal. 126.5 base 7. You have to convert into the decimal. You know that how we are going to do it. 2357 in base 8 और base 10 कर base 11 कर दे और base 8 कर देता हूँ. So you have to convert into the decimal. So some questions also based on the base conversion I have just given, right? And this is also a homework question. Homework question means after the class you have to solve it, right? Before coming to the next class, I will ask the solution or answer of this homework question, right? And you can send me directly also, verify करने के लिए, right? 3 है, subject है digital logic. कल मैंने homework question दिया था. How many of you have solved those homework question? आप में से कितने ऐसे लोग हैं जिन्होंने उस homework question को solve किया है? After that, we have started what we have learned right into the previous class. Let me give you the brief idea about those things. हमने क्या पढ़ा है? So we have learned the basic part. First of all, we have started the syllabus discussion we have done, right? No issues for that. सबसे पहले हमने syllabus की बात करी. Only 5 things we have to study. The first one is called logic gate, then minimization. Now everyone try to understand. After that, logic minimization. After that, we have started the logic gate. Combinational circuit. In the combinational circuit, we are going to discuss about the comparator, half adder, full adder, half subtractor, full subtractor, serial adder, parallel adder, look ahead, carry adder, multiplier, right? Mux, demux, encoder, decoder, like that topic we have discussed, right? We are going to discuss. After that, sequential circuit, latches, flip-flop, registers, and counter. After that, we have started. We have discussed in the syllabus. We are going to discuss about FSM, finite state machine, delay related problem, and then in the last, the number system. After that, we have started the NOT gate, the first. Either you can use the word NOT gate, or you can use word negation or complement logic, all having inverter, all having the same meaning. I have discussed the 3 symbols also, right? Bubble, right? Triangular type shape था, bubble आगे लगा हुआ था, bubble पीछे लगा हुआ था. Only bubble itself represent the NOT gate. So in the NOT gate, whenever you will apply the whatever you will apply, na, the complement value you will get into the output. If you will apply the 0, the 1 you will get into the output. If you will apply the 1, then 0 you will get into the output. That's the meaning of this, right? Okay. Hope you guys understood. This portion we have covered, right? Okay, now. After that, we have started the one NOT gate is basically there. Okay, in the every NOT gate or in the every practical circuit, there will be there must be the delay, right? There must be the delay. What is the delay? Delay means whenever you will apply the input to produce the output, it will take some time, and that time itself is called basically the delay. So in the NOT gate, we have discussed if the input graph is basically given, how we are going to find out the output graph. That portion we have covered into the yesterday session. Apart from this is the basic part of the number system also we have covered. In apart from number system, basic part of the number system means we have discussed what type of the digit, how many digits are basically present if the base is x. कोई भी base होगा, उसके अंदर क्या digit present होगा. Suppose the base is 4. So in those particular number system, the 0, 1, 2, and 3, n minus 1, whatever the base r is there, r minus 1 till that the number will present. After that, we have discussed, suppose if I'm writing 1 to c, what should be the base? So we can say that a means 10, b means 12, c means 13. So minimum base will be 14 here. Hope you guys understood. नहीं, a का मतलब 10, b का मतलब 11, c का मतलब 12. Minimum base will be 13 actually, not 14, because c is called 12. So whatever the maximum digit will be there, more than that must be present into the output, must be present into the as a base, right? Okay. After that, we have discussed इतनी चीजें हो गई, तो उसके बाद we have covered, we have started how we are going to convert the any number into corresponding decimal. If any base is basically given, some systems are basically given, some numbers are basically given into the sum of the specific, you can say that the base. then how we are going to convert into the corresponding decimal. And in those process is very simple. Why? Because the coefficient should multiply with their weight. That's it, nothing more than that. आप base को उस coefficient को उसके weight से multiply करिए and add it. You will get the answer. We have done lots of question also. Just after that, right? यहाँ पे शुरू हुआ. Then basic part we have discussed it. How any numbers, if 2 raised to power 10 means kilo, 2 raised to power 20 means mega, 2 raised to power 30 means giga, like that we have discussed, right? Apart from this, आगे अगर बढ़ते हैं, then what we have learned? Whenever the time, frequency, that type of the things are basically given, length, weight, then kilo means 10 raised to power 3, mega means 10 raised to power 6, giga means 10 raised to power 9. But whenever the data is basically given, the kilo means 2 raised to power. Here we have to deal with the 2 raised to power 10, right? Okay. That portion we have covered, right? Isn't it? After that, whenever any expressions are basically there, any expression, then we can write that expression in the two way. One in the SOP, second one in the POS. SOP means sum of product. POS means product of sum. The terms in the SOP are called mean term, and terms in the POS are called max term. Mean term and max term are complement of each other. SOP and POS are not complement of each other. Mean term and max term are called complement of each other. That's what we have discussed. यहाँ तक मेरे ख्याल से चीजें क्लियर ही होगी आपको. Now let's move into the next part, right? Suppose now I'm taking this NOT gate. After that, I have given the few questions also, but suppose I'm connecting, this is the 2 NOT gate, right? Can anybody, sir, all concept crystal clear with enjoyment? Arey Sandeep, बहुत ही बढ़िया. Great. Now everyone try to understand. I have connected the 2 NOT gate. Now what is going to be happen if the 2 NOT gates are basically there? If you'll apply the 0 here, you will get 1. How many time it will take? 1 top ED. So if you'll apply the 0, you will get 1 after the 1 top ED. And due to this one again will become 0 after the 1 top ED. Yes, Rohini. So whatever will apply the input, the same thing you will get into the output. Of course, the delay is something else, right? 2 top EDs basically. Instead of 0, if you'll apply the 1, then if you'll apply here you will get 0, and here you are getting 1. So my dear friend, in this type of circuit, what has happened? Just like what the Rohini said, whatever will apply the input, the same thing you will get into the output. And if whatever the input is there and the output will be the same, then that type of circuit is referred as or known as buffer. This type of the circuit is known as called buffer. Buffer means what? Any type of the circuit in which whatever the inputs will be there, the same you will get into the output. And one thing more, if I remove the input, the output is also going to be removed, isn't it? Because you will observe the input till you will output till you will apply the input. If I will remove it, this is also going to be removed. And this is called nothing, it is just a buffer. So can anybody give an answer? What should be the use of buffer? If it is the input and then you are getting into the output the same thing, why should I use the 2 NOT gate? By the wire also we can keep it into the output. Why we are using this, right? Yes, Rohini, absolutely correct. Everyone, just for the delay. Yes, sir, sometimes the delay is basically required. Now my question is, because the buffer will introduce the delay into the circuit. Now my question is, whether the delay is an advantage or drawback. Whenever in the interviews this type of question will ask, do not respond directly. It will depend upon the application. Sometimes we required the delay. and at the time it will become advantage. Sometime we do not require delay, then it is called nothing, it is just a disadvantage. When the delay is basically advantage, in which situation? Like traffic light. In the traffic light, how we are maintaining? Suppose I am maintaining the situation in such a way, the green light will open for till 60 seconds, then for the 3-second yellow light, and then again for the 60-second red light. So what we have to do? We have to use the delay. If the light is going to be turned on, the period we have to maintain for the 60 seconds. So other lights should be off for the 60 seconds. So we are using the delay कि अगली लाइट चालू ना हो जाए 60 सेकंड से पहले, तो हम वहां पर डिले लगा रहे हैं. So there it will become advantage. Yes, advantage. And disadvantage in the practical circuit, everywhere, right? We'll apply the input, we require the output as soon as possible. So at the time, it will become disadvantage. Right? Okay. Buffer also represented like this also. Instead of this, I can also use the symbol like this. This is also called buffer. So if you'll apply the input, this is called output. Either you can make like this or you can make like this. Does not make any difference. One thing you have to remember, guys, if I will remove the input, output is also going to be removed. अगर आप यहाँ से input को remove करोगे ना, तो यहाँ से ये खटाक से ये भी remove हो जाएगा. ये सबसे important चीज है. If I will remove the input, the output is also going to be removed. That's the important, right? Now, आगे बढ़ते हैं. One thing more I want to ask you, everyone try to understand. Suppose I am taking this to NOT gate. Oh, this is the 2 NOT gate, and I'm using the feedback. To NOT gate, I'm using the feedback. Feedback means what? We are taking the output, and output again we are connecting into the input. Whenever we are taking the output and output we are connecting into the input, then that circuit is called nothing. It is just a circuit, whatever the given. This part is called nothing. It is just a feedback, right? Feedback or loop. Yes. Now my question is, everyone try to understand what happened in this particular circuit. Try to understand. In this particular circuit, if we'll apply 0 here, suppose we have applied the 0. Now what value you will get? After the 1 top PD, we are getting 1. Right? And after the 1 again, 1 top PD, we are getting 0. Now, even though if I'll remove the input, this output again here, due to the feedback, this output will appear into the input. Are you getting my point? Again, due to this 0, here we are getting. After that, this one will become 0 here. Remove it. Again, this 0 will come into the feedback. Again, this 0 will come into the feedback. So 0 will become 1, 1 will become 0. Again, you can feel that 0 will come into the feedback. Like that, it is going to be happening. So everyone try to understand what should be the, you can say that what should be the difference between this circuit and this circuit. In this circuit, output will never come into the input. That's why if you remove the input, the output is also going to be removed. But in this particular circuit, even though if I will remove the input, the output is going to be maintain the same thing. Isn't it? If 0, after the 1 top PD, you will get 1 here. After the 1 top PD, you will get 0 here. Again, due to the feedback, you will get the 0, then 1, then 0. Again 0, 1, 0. Again 0, 1, 0. So due to the loop, what you will get? Okay, sir, even though if the input is removed, once it is applied, and then it is going to be removed. Even though we are getting, always will get 0 here in this particular position. एक बार आपने 0 देकर छोड़ दिया, उसके बाद आप यहाँ पे हटा भी दोगे, तब भी यहाँ पर वो मेंटेन रहेगा. कैसे? तो एक बार फिर से समझिएगा. Everyone try to understand one more time. मैंने यहाँ 0 दिया, and now this 0 will become 1. Right? ये 0 1 बनकर इधर आ चुका है. Right? Now, if the 0 will become 1, now this 1 will become 0. After how many top ED? So whatever we have applied, after the 2 top ED, it will appear here. Again, due to the feedback, it will come. Then again 0 का इधर 1 होगा और उधर 0 होगा. So again this 0 will appear here after the 2 top ED. Again this 0 will come. Oh. Again this 0 will come into this particular position. Then after 2 top ED again appear. Then again this 0 will come up. After 2 top ED again appear. So you will feel always you will get the 0 in this particular position. It means once you have applied this 0, this circuit is going to be stored the 0 permanently. Now the people will think, sir, why you are applying the 0? Okay, no issues. Apply 1. अगर मैं apply 1 कर देता हूँ, then also after the 1, it will become 0. It will become 1. All right. So you will get always, now if you'll remove it, this 1 is going to be stored, right? If you'll remove it, this 1 again will come here. Then after the 2 top ED, it will become this. After will come here. Then 2 top ED, it will appear here. So always you will get 1 in this particular position. Try to understand. So in this circuit, whatever we have applied, that is going to be stored, right? Now everyone try to understand. Whenever we are applying the anything and that is going to be stored, so which thing is going to store the data? कौन डेटा को स्टोर करता है? स्टोर करने का क्या, आप लोग मोबाइल में ऐसे सेल्फी लेते हो, टिंग, कहाँ स्टोर होता है? Which one is going to store? Nobody responding. In the gallery or memory, definitely memory. The storing part is going to be happened into the Google Photo. Or in the memory, it is going to be stored. Now, whatever this is your UI, but in the behind that, always the memory is there, right? And the memory. So later on, I will design the memory also with the help of this NOT gate, right? So this is not only NOT gate. This is a memory we have designed. So we can say that this is also called basic memory element. This is called basic memory element. Okay, in this particular circuit, what happened now? If we have applied the 0 is going to be stored. If we have applied the 1 is going to be stored, right? So whatever we are applying, the same data is going to be stored, right? If you apply the 0 is going to be stored. If apply the 1 is going to be stored. So this one having the 2 stable condition. If you apply the 0 is going to be stable into the output. If you apply the 1 is going to be stable into the output. So how many stable condition are there? The 2, either 0 or 1. 2 is called bi. Stable means stable. And a circuit which is used to generate the signals in such a way that is going to be stable, or that is going to be vibrate into the 2 different level or 3 different level or n different level. That is called multi-vibrator. So this circuit is actually the multi-vibrator, which having the 2 stable conditions. So we can say that this is also known as bi-stable multi-vibrator. Do not think much regarding to the multi-vibrator. Multi-vibrator is just a circuit which is used to generate a signal which will vibrate between the different levels. That is called multi-vibrator. So this is called bi-stable multi-vibrator. Okay, one thing more. If you want to form the waveform output signal, so if you will apply the 0, you will get the 0. Or after the every 2 top ED, the 0 is going to be replaced. So if we are getting 0, after 2 top ED again 0, after 2 top ED again 0, after 2 top ED again 0. So every 2 top ED you are getting 0 only. Every 2 top ED it is going to, it's not 0 1 0 1 Sandeep. Always 0, and then again 0 will come into the feedback, 0 ka 1 1 ka 0. Again we are getting to after 2 top ED 0. again 2 top PD 0. So every time you will get 0 only. If the people will think, sir, I'm not applying 0, I'm applying the 1. So after the 2 top PD, again we are getting 1. After the 2 top PD, again we are getting 1. So actually the value is not going to be changed. This is the value you will get always. Everyone understood? Write down yes or no, please. कि सर 0 आया, फिर 0 यहाँ गया, फिर 1 top PD, 2 top PD. So this 0 will come here after the 2 top PD. Now, if you want to make into the waveform, into the signal form, one will be represented by a high voltage. So one high voltage is there, and 2 top PD, for 2 top PD it's a high, then 2 top PD high, then 2 top PD high, high you will get. Suppose if you are applying the 0, then in the signal form, in the signal form, you will get low, after 2 top PD again low, after 2 top PD again low, after 2 top PD again. Same time of waveform you will get. This is not going to be changed. Either you will get like this straight line or this straight line. So can anybody give me an answer? Whether this circuit will generate this or this will generate this, right? Any of the two things they will going to generate. So this is a AC or DC? Can anybody give an answer? ये एक AC signal है या DC signal है? DC. And who generated the DC? This circuit generated DC. So sometimes this is also called DC generator, right? Okay. And what is the frequency of this DC? Can anybody give an answer? What is the frequency of the DC? So DC having the frequency 0 only. So sometime they will ask, okay, this type of circuit is going to generate a signal. What is the frequency of that signal? So you have to understand, okay, 0 Hz signal generator. Right, that is DC is going to be generated by this particular circuit. So you can understand like these 3 points. One thing more I want to tell you. Divya, I'm sure. Bistable means, because if you'll apply the 0 is going to be stable. If you'll apply the 1, if you'll apply the 0, here you will get the stable state is 0. If you'll apply the 1, here the stable state is going to be 1. So, or we are dealing with a binary number system. So it has the 2 stable condition, right? 0 or 1, both. And that's why we can say that this is a bistable. Multi-vibrator means a circuit which is going to be generate a signal in such a way that are going to be vibrate between the different levels. That is called multi-vibrator. Multi-vibrator is a name only, you can say that. आपको ज़्यादा नहीं पढ़ना है, बस नाम याद रखना, multi-vibrator. That's it. So this circuit having the 2 stable condition, that's why it is called bistable. If any circuit having the 1 stable condition, it will become monostable. If any circuit having none of the stable condition, or stable multivibrator, like that. Right? Okay. Now can anybody give an answer? Ki sir, in this loop, 2 NOT gate are basically there. That's why it is maintaining the 0 to 0 or 1 to 1. Instead of 2, if I will use the 4 NOT gate in the loop, if I will use a 4 NOT gate, entire operation is going to be changed or same? Of course, the delay is changed, but operation is going to be same. Right? Yes. Okay. Instead of 4, if I will use 6 NOT gate, then operation is going to be changed or same? Same रहेगा कि change हो जाएगा भैया? Sir, same. Or if I will use 8, then also the same. It means, can I use the one statement कि whenever even number of NOT gates are basically used in the loop, that will be work like whatever the input is there, they are going to maintain into the output. Even though if you remove the input, then also it is going to be maintained. That's why it is called memory. ऐसा थोड़ी फोटो खाली खींच के रखते हो तभी मेमोरी में दिखता है. Once you have stored it, it is going to be stored. And then it is called basic memory element, bistable multivibrator, or 0 Hz signal generator. So we can use a statement. जब भी कभी इवन नंबर ऑफ नोट गेट कनेक्टेड लूप में होगा उसका यही 3 नाम होंगे. Third point 0. Samyak, I will not explain the third point because the third point is visible to you. Either you will get this straight line high voltage or you will get the lowest voltage. This is called DC actually, and DC having the 0 frequency. This DC having the 0 frequency, that's why we can say that this signal is generated by this, and this one having the 0 hertz DC, and DC having the frequency 0, and that's why I can say that this circuit will generate a signal which having the 0 frequency. So this 0 frequency generator, we can see that. They are generating this type of signal. Yes. Hope understood. Dekho, if you understood this point, let's move into the next. Suppose if I'm asking the one question, and that question is called like this. Now I'm connected node 3. I'm connected like this, right? I have taken the one node gate and I have connected into the right feedback, only one node gate. Now can anybody give me the answer? If one node gate is basically there and it will connected into the output, then what happened in this particular circuit? Sir, either if you'll apply the 0 or will apply the 1. If we'll apply the 0, you will get 1 in this particular point, isn't it? If you'll apply the 0, you will get 1. Yes. And now if I will remove it, so we are getting 1. Now the 1 will come into the feedback. So what value you will get? This 1 after the 1 top ED, it will become 0. Now here the 0 will come, this 0 will come. Now after the 1 top ED, it will become 1. Now here the 1 is basically coming. So after the 1 top ED, this 1 will become 0. So what you can feel here, right? Can anybody give me the answer? After the 1 top ED, all the value is going to be changed. 1 0, then 1 0, 1 0 1. For the every top ED, it is going to be changed, isn't it? Everyone. और ऐसा नहीं हो रहा है क्या? हर एक top ED के बाद value change हो रही है. Now maybe the people will think why you have applied 0. No issues. Apply 1. Suppose if I have applied 1, so here we are getting 0. After the how many times you will get 0? So after the 1 top ED will get 0, right? Now again this 0 will come into the feedback, right? So after the 1 top ED, this 0 will become 1. So here it must be is going to be after the 1 top ED. Now again here we are getting 1. This 1 will come into this. So after the 1 top ED again, this 1 is going to be 0. So now here we are getting 0. So again 1 top ED, this 0 is going to be 1. So you can feel in this particular point, after the every top ED, the output is going to be changed. Whether there will be any stable condition in this circuit, can anybody give an answer? Can we say that any stable condition is there? No. So in the previous condition, there are 2 stable conditions. That's why we can say that bistable multivibrator. Here, nothing is stable. So what we can say that? यहाँ पर कोई भी stable नहीं है. So what we'll say? There are the 2 stable condition bistable multivibrator. Here the nothing is basically stable. So we can say that a stable multivibrator, isn't it, everyone? हम इसको astable बोल सकते हैं. Yes, definitely. So we can say that this is called unstable multivibrator. Here we have discussed 0, 1, 0, 1, 0, 1, like that it is going to be happen. After the every top PD, after the every top PD, it is going to be changed. So this 0 is hold up to 1 top PD. After the 1 top PD, it will become 1. Then this 1 is going to be stored up to 1 top PD, and after the 1 top PD, again it is going to be changed. So like that it is going to be happen, right? So if you will make the waveform, suppose I am writing this is the duration of 1 top PD. Like that it is going to be happen, right? Now, so or every value will be going to be stored up to 1 top PD. So this is called top PD. This is called top PD. This is called top PD. After the every top PD, it is going to be changed. 1 will become 0, 0 will become 1. 1 means high voltage, 0 means low voltage. So like that it is going to be happen. Now, can anybody give me an answer? Always you have to remember one thing, my dear friend. कि one positive and one negative cycle always. एक negative और एक positive cycle को मिलाकर. This is called time period. Whenever any type of signal is basically given in the sine wave also it's like that, na? To peak value, one positive cycle, one negative cycle combined itself is called time period, like that, right? So one positive, one negative itself, and after that it is repeating. So this is called time period because this part is going to be repeated every time, right? So this is called time period. So can anybody give an answer? What is the time period of this particular circuit? What is the time period of this particular circuit? A particular signal to top PD, right? Delay is called 1, but time period is called 2 top PD for this circuit, right? And as we know, the frequency and time period are inversely related to each other. So if they will ask about a signal which is going to be generated by this particular circuit, what is the frequency of that? So we can say that 1 upon 2 top PD. 1 upon 2 top PD. Hope you guys understood. Now, let me discuss the one thing more. Now, everyone try to understand. अगर मैंने 3 नोड गेट ले लिया and every node gate having the delay top PD, top PD, top PD. Then can anybody give an answer? After the how many top PD the value is going to be changed? The operation is going to be same or different? 0 will become 1, 1 will become 0, 0 will become 1, 1 will become 0. So 0, 1, 0, 1 is going to be happen. So it is different or same? Urnisha, it's not like that. If we'll apply the 0 here, after the 1 top PD, or if you'll apply the 1 here, after the 1 top PD, it will become 0. One more top PD, it will become 1. And one more top PD, it will become 0. So this 1 will take 3 top PD to become 0 here. Yes. Now this 0 will come into the feedback. So 0 ka 1, 1 ka 0. So this 0 will come as a 1 after the 3 top ED. So you can feel in this case, after the 3 top ED, because whatever the value is there, now it will take 3 top ED to appear into the output. So after the 3 top ED, everything is going to be changed. In this case, after the 1 top ED, it is going to be changed. Here, after the 3 top ED, it is going to be changed. So we can say that the same thing. Till that 3 top ED will hold, then 3 top ED will become this. 3 top ED, 3 top ED, 3 top ED. Like that it is going to be happen, isn't it? Now, can anybody give an answer? What should be the time period for this? If I will ask about time period, whatever the total delay now, the twice of that delay is the time period, because for the positive also, for the negative also. So we can say that 3 plus 3, that is called 6 top ED. And if I will ask about the F, that is called 1 upon T. That is 1 upon. That is called 1 upon 6 top ED. That's the meaning of this. Okay. Now, if I will ask one thing more. Suppose I have used like this, right? 6 top ED, once more explain. 1 positive and 1 negative. So everything is going to be hold for the 3 top ED. Time period is called 1 positive plus 1 negative is called time period. So how many time period? Why I should explain something? Because this is visible. 3 top ED plus 3 top ED. So total duration for this one is called 6 top ED. And this is called the IQ level is required. Are you getting my point? GID exam में से छोटी-छोटी चीजें आपको पकड़नी पड़ेगी. Right? Now if I will ask like this. So can anybody give an answer? After the how many top ED it is going to be changed? After 5 top ED it is going to be changed. Right, Archita, after the 5 top ED it is going to be changed, right? Ajay, isn't it? इसका मतलब this will come. This is of 5 top ED. After the every 5 top ED, the 0 will become 1 and 1 will become 0. So now what is the time period? So what is the time period now? Time period is called 10 top ED. And F is called 1 upon T, 1 upon 10 top ED. So whenever all the node gates are identical, identical means having the same delay. Can I make a statement like this? If node gate, one node gate is there, 2 into 1 into top ED. Can I make 2 top ED, 2 into 1 into 1 top ED? This one is called node gate in loop. 3 is there, we can write 2 into 3 into top ED. Can I use this statement? Yes, sir, it is a 6. 3 is the node gate in the loop. Here, if I want to write, it is called 2 into 5 into top ED. 5 is the number of node gate in the loop. So can I make a statement? Can I make a statement and suppose n node gate are basically there, and n is called odd number. Because this 0 will become 1 and 1 will become 0, only it is going to be happen when odd number of property is basically there, right? So n is called 1. And all the node gates are basically identical. So can I use this statement? For the n top ED, it is going to be changed. N top ED, 0 will become 1 and 1 will become 0. 0 will become 1 and 1 will become 0. After the every n top ED, this is going to be changed. So here the time period, we can say that 2 into n into top ED. Because you can n top ED plus n top ED, 2n top ED. And frequency is called 1 upon 2 into n into top ED. ठीक है, 2 into n into top ED. Okay, this is the important you have to understand, right? We already discussed how this formula is going to be derived, isn't it? Now, if you understood this point, and here I'm saying that all the node gates are identical to each other, right? Then only this formula is applicable, right? If it is not identical, means what? Then you have to add, you have to sum the delay of all the node gates. So 2 into, instead of n top ED, we can use the sum of the delay of all node gates. So 2 into sum of the delay of all node gates. Like that, the formula is going to be happen. क्योंकि यार किसी भी चीज को n times जोड़ते हो तो n into top ED को n times जोड़ते हो. If you are adding the top ED n times, it will become n top ED. So it's a n top ED is called nothing. It is just a addition of the top ED n times. But if all are basically different, top ED 1, top ED 2, top ED 3, top ED, then you have to add all the top ED. So sum of all the node gates. And here the n is called number of node gate in loop. Number of node gate only, Sandeep. Number of node gate in loop. So odd, and here we can say that n is called and that must be odd. Then only we can see that, right? So everyone try to understand what the statement I can make. One thing more I want to share. Everyone try to understand. Okay, whenever the odd number of node gates are in loop, whenever odd number of node gate, whenever the odd number of node gate in loop, when odd number of node gate in loop, the circuit will be known as a stable multivibrator. A stable multivibrator. After that, the signal will be generated like this, right? So this is a triangle or square? Can anybody give an answer? This is a triangle or square? This is a triangle or square? Sir, of course, the square. So we can say that, and the square signal is generated by this circuit only. So this is also called square wave generator. So this is called square wave generator. Square wave, later on, I will say that this is a clock only. So I will use this is the clock only, right? So this is either we can use the word square wave or we can use the word clock. In the sequential circuit I will discuss, right? So we can also say that this is a clock generator. Because in this circuit what happened? 0, then 1, then 0, then 1. Like that it is going to happen, isn't it? Clock generator. Fourth, we have applied the either 0 or 1. Anything you can apply. The output is automatically going to be changed. 0, then 1, then 0, then 1. So here the anything is stable? No, sir. Nothing is stable. And circuit automatically it is running. So it is also known as free running circuit. Because automatically the output, once we have applied anything, triggered the circuit, after that automatically it will be going to be changed. 0, 1, 0, 1, 0, 1. Automatically happen. And that's why it is called free running circuit. Now fifth one. Suppose we are playing the one game, right? हम एक गेम खेलते हैं. So मान लो गेम में सयान है, सयान से ऊपर अर्चिता है, अर्चित है, अर्चिता, अर्चिता, यस, संदीप है, और सपोज मैं हूं सीरीज, राइट? सो वी आर प्लेइंग 4 people, सयान, अर्चिता, CJ. We both playing the game, and the name of the game is called passing ball game. So there will be the one people who has the ball, and we are basically passing the ball, who has basically the music, controlling the music, and we are passing the ball. So suppose Sayan having the ball, Sayan is passing the ball to the Archita, Archita is passing the ball to the Sandeep, Sandeep is passing the ball to the CJ sir, CJ sir is passing the ball to the again Sayan. So like that it is going to happen. So what it formed a ring. This is called a ring. And how many states are there for this particular ring? Can anybody give an answer? How many states are basically there in this ring? How many? 4, right? Isn't it? 4 states. 1, 2, 3, 4. Right? Okay. Suppose what actually I feel is suppose Sayan cheating कर रहा है. ये Sayan out हो गया मान लो. Right? So again I have a ball. I'm just passing the ball to the Archita. Archita is passing the ball to the Sandeep. Sandeep is passing ball to the me. Again we are playing the game. How many states are there now? This is also a ring. But in this ring, the 3 states are there. Suppose मैं बाहर आ गया गेम से. Now Sandeep and Archita is basically playing the game. Archita is passing the ball to the Sandeep. Sandeep is passing the ball to the Archita. अब संदीप ज्यादा खुश मत हो जाना. ये सिर्फ गेम चल रहा है, मैं एग्जांपल ले रहा हूँ. भावुक हो गए पता चला. So Archita is passing ball to the Sandeep. Sandeep is passing the ball to the Archita. Now again, the both formed the ring. How many states are basically there? 2 states. So it's not possible that we are going to reduce the one of the state or Archita को बोलो कि तुम अकेले गेम खेलो. It's not possible. So to form the ring, minimum 2 states are basically required, right? Isn't it? So this is also ring, na? You can feel 0 or 1. So we are applying the 0, then it will become 1, then 0. So we are forming the ring. And either we can use multivibrator or we can use oscillator. Oscillator means also oscillating the value, right? 0, oscillate, then it will become 1. Oscillate to 0, like that. So this is also called ring oscillator. Oscillator means also signal generator actually. So everyone try to understand. Whenever the odd number of node gates are basically connected in the loop, the circuit is known as unstable multivibrator, square wave generator, clock generator, free running circuit, and ring oscillator. And the signal generated by this particular circuit having the frequency 1 upon 2n top ED. 2n top ED. That's the meaning of it. Understood everyone? Write on yes or no. If you have understood this point, let me discuss the one example, right? I'm just giving you the one question. And the question is, find the frequency Find the frequency of generated waveform at y when all the node gates are identical and having delay two nanosecond. This is got like this, right? So everyone just, and this is called y. What is the delay at y? And solve and give me the answer. Whether we can apply the formula or not, that is the question first. Because that formula is applicable only when the when the odd number of node gates are basically there. Whenever the even number of node gates are there and they will ask the question, the answer will be 0 only. So 1, 2, 3, 4, 5. Sir, 5 node gate. Yes, odd number of node gate given in the loop. So directly we can apply. Always you have to count in the loop, not outside the loop, right? Okay. So n, we know that number of node gate is 5. Propagation delay is given 2 nanosecond. You need 2 nanosecond. Means 2 into nano means 10 raised to power minus 9. Now, formula for the frequency is called F equal to, if all are identical, 2 into n into top PD. Yes. So we can say that 1 upon 2 into n, 5 into top PD. Top PD is called propagation delay, is already mentioned. 2 into 10 raised to power minus 9 and 1 upon second. 1 upon second itself is called hertz. This is a frequency. Unit of frequency is called hertz. So it will become 1 upon 10 into 20 into 10 raised to power minus 9 hertz. Now, everyone try to understand. 10 raised to power minus 9 will go into the upper side, so it will become 10 raised to power 9. And this is called 20 hertz. Now, everyone try to understand. We can also split into the 1000 into 10 raised to power 6 hertz upon 20. 10 raised to power 9 is called what? 10 raised to power 3 into 10 raised to power 6. Or 10 raised to power 6 is called mega, if you remember, right? So it equals 50 megahertz is the answer for this. I think none of the people has given the correct answer, isn't it? आप में से एक ने भी सही आंसर नहीं दिया. So in the node gate, we cannot expect the question like they will give you the one node gate, they will ask, okay, if I will apply the 0, बताओ output क्या आएगा? It's not like that. Even the node gate, they will ask the numerical also like this. Understood, everyone? Can you sketch the waveform of Y if top PD is the delay of the node gate? Sketch the waveform at Y. y. This case the waveform at y. Everyone, just give me the answer. If I will ask like this, if I will ask like this, you are able to make the waveform just give me 1 minute, right? कोई आया है? Like that it is going to be happen, right? And this is called top PD. Top PD. This is called top PD. Like this it is going to be happen, right? Okay. Now, suppose if I will give you the one question, if this signal is applied between this node, we know that this is generated at this particular point, right? Now I'm asking if this signal is generated applied to this, what is the output? Suppose सबको एक एक नोट गेट मान लिया है. One top ID is called the delay of this, right? So suppose we have applied, this is called X and I'm talking about Y. Suppose X is called like this. Everyone try to understand and give me the answer. Already in the yesterday class, we have discussed this thing, right? Okay, sir, if X is there, this, how the X bar is going to be happen? So 0 will become 1, 1 will become 2. And every block I am considering as in top PD. So what should be the output Y? We have to shift this graph by the one top PD. So, we have made same, okay. This is called, right? I have flipped it right now. Now we have to shift this graph to the one top PD, right? So we have to shift, if you want to find out the waveform, we have to shift it by one top PD. This is your answer, you will get. Actually, I have directly made the answer in here. This is your flipped graph, X bar. But we have to shift the X bar by one top PD. So we have to shift it one top PD. So we'll get Y like this, right? And we have shifted by one top PD, so it's looking like this. Like that it is going to be. Understood everyone? Write down yes or no. अरे ये तो कल ही बताया था ना, whatever the graph is there, we have to flip it and shift by those particular things, right? Right, okay. Now if you understood it, everyone, अब सोचो अगर इतनी चीजें क्लियर हो गई तो same question we have asked here ना. You know the waveform at here, so you are able to make it also. यही तो question था. We have differentiated, but now we are making it, right? So what you will get? सर इस क्वेश्चंस के अंदर आपने यही तो आपको मिलेगा. So if you want to sketch the waveform at x, suppose this is called x. So it is looking like this. X is basically looking like this. This is called x. But they are talking about that y. So we have to split the graph. This no, we know that how we are going to form it, right? So first we have to flip the graph. Right. And output, we have to now shift this yellow graph by the one top ED. So this will come to this place. So like this it is going to be happening. Like that it is going to be happen. Hope you guys understood, right? This will come to this place. This will come to this place like this, right? One top ED we have shifted. Understood everyone? Write down yes or no, please. Now you have to give the answer. All node gates are basically identical and sketch the waveform at y. We already know that how this x is sketched, right? If all are identical means one top ED, right? Each block having the one top ED delay, right? So if I will sketch the x first, x we already know that we have formed, right? We are not forming the first time. We have already done. How the x is going to be sketched? Look at here. मत पूछना सर कैसे आया. Already we have sketched, right? So we know that. Yes, sir, if you want to sketch the x value, suppose this is not given. Suppose if this is not given. And now you are talking about how it is going to be looking like. So 3 times 0, 3 times 1. Now maybe you can start with the 1 also. It will depends how the circuit is ignited. I'm always considering as a 0, right? But most important, after the 3 top ED, the value is going to be changed. Everyone write down yes or no. Understood X graph. How many of you have understood the X graph? Anyone having the doubt for the X, do let me know. X you already, yes, Sandeep, right? Anybody having that doubt in the X graph, how it is going to be happen, right? Do let me know, right? Okay, no doubt. Oh, sure. Now, suppose if I will ask this X is applied to this node gate, then what is the output Y? In this node gate does not have any Y. You can say the loop, right? This is something else. So now for this thing, you have to complement the value of x. So I'm just complementing it. It's like that. And now we have to shift the graph for the y. We have to shift this yellow graph by the one unit. So by the one block. So one block we have shifted. Everything we have shifted for the one block. Like that it is going to be happening. So I think you have understood this point, right? It's very simple. Now, can anybody give an answer? The frequency of x at this particular point, time period if you will talk about tx, and time period if you will ask about for this one, this is called ty. So whether the time period is going to be changed or same? Same. So everyone try to understand. Time period same means frequency same or changed? Frequency same or changed? Same. If time period is same, the frequency is also same. Means frequency is decided by the number of node gate in the loop. That is not decided by the outside the loop. That's why I have always mentioned, look at here, number of node gate in loop. Always you have to focus on the loop, then only we can apply the formula, right? Node gate in loop, always. That's why we can understand one thing. Is sir, whatever the frequency is at this particular moment, the same frequency you will get like this. So time period at tx and ty both are same. So frequency of tx and frequency at ty is also same. So outside the loop is only shifting the graph. They are not going. If they will shift the 0, they will shift the 1 also. So time period is not going to be changed. Time period means 0 और 1 का मिला के जो duration बनता है. If 0 is shifted, 1 is also shifted, but the duration is same. That only the shifting is happening. Understood everyone? Write down yes or no please. अरे समझ में आया भैया? That's great. Great. Very good. Now or one thing more, in the everywhere, if you talk about 3x, right? Everyone try to understand. After the 3 top PD value, it's not changing here only. It's changing also here only. Here also. In the every point, whenever the odd number of node gate is there, in the every point, after the 3 top PD, the value is going to be changed. So either they will ask about this graph, this here, everywhere. You will get the similar type of graph. No issues. कोई ज़्यादा फर्क नहीं पड़ेगा. Okay. Now, if you understood this point, let's move into the next. Okay. Now everyone try to, let's move into the next. After the node gate, so hope you guys understood about the node gate, right? So after the node gate, let me discuss about the AND gate. And a little bit detailed version of the AND gate or node gate also we'll discuss, right? We'll club together also. But abhi maine bade basic part discussion kiya. Everyone try to understand. Whenever I will deal with the node gate, it does not mean that only 0 to 1 and 1 to 0. We have discussed the node gate for the 2 hours. Are you getting my point? So the numerical also we can expect from the node gate. So, and maybe the people will think, sir, this type of the time period or frequency, they will ask into the CS. Yes, not asked. Already they have asked right into the PYQ, if you'll observe. Already पूछा जा चुका है. Right? Okay. And nowadays the question also IIT is unpredictable. For the everything you have to prepare. Sandeep, I will discuss. Don't worry. 3 node gate लगा के पूछा था. I have discussed now with the 5 node gate. Like this they have asked, right? But not 5 with the 3 node gate. Okay, now everyone just move into the next, that is called AND gate, right? I will discuss, don't worry, right? AND gate. Everyone try to understand, right? One thing more you can understand. This is not a gate, right? This is a logic. Everything what we have studied now, that's not a gate actually. This is a logic only, right? So what should be the meaning of logic? So AND logic. So everyone try to understand. AND means, if you want to discuss about the symbol, symbol of AND logic is like this. Like this. So whenever you write A and it is called B, so here the either you can write A dot B or you can write A intersection. Actually, this logic gates are basically designed by the help of the set theory only. This is a representation of set theory. So ending means intersection and ORing means the union. That's what you have to understand. Intersection on union. Now everyone try to understand. Intersection and union की अगर बात हो रही है तो एक चीज और समझिएगा. Everyone. Before that, there are two type of operation that is very famous. One is called ending operation and second one is called ORing operation. These two operations are very important, ending operation and ORing operation. For the ending operation means if I will use 0 dot 0, dot we have to use. Common निकालना intersection. 0 dot 0, so you will get 0. 0 dot 1, so you will get 0. If I will ask 1 dot 0, you will get 0. If I will ask 1 dot 1, you will get 1. If I will ask A dot 1, you will get A. If I will ask A dot 0, you will get 0. If I will ask A dot A, you will get A. If I will ask A dot A bar, you will get 0. Because A dot A bar means what? If one A is there and second one is complement of A is there, what is common between them? 0. Nothing is common. So A dot A bar itself is called 0. Now, same thing in the ORing, we can say that. ORing means union. So I will write 0 ORing 0. It's not addition, ध्यान रखना. ये addition नहीं है. Because if you add the 2 bit, you will get the answer into 2 bit only. Sum and carry. But it's a logical operation. So 0 ORing 0, 0. 0 ORing 0, 0. Right, okay. Now, 0 ORing 1, 1. 1 ORing 0, 1. 1 ORing 1, 1. Okay. A ORing 0, A. A ORing A, A. A ORing A bar, that is 1. A ORing A bar is called 1. If A is there, apart from this, A bar is there, right? So if you'll club it, you will get the entire things, right? And if I will ask A ORing 1, you will get 1 ORing. Always try to understand one thing, right? 1 ORing anything. 1 के साथ अगर कुछ भी function हो, always you will get 1. 1 ORing anything will become 1 ORing. So if I will ask 1 ORing AB, what is the value you will get? 1 only. So 1 ORing anything will become 1 and 0 dot anything will become 0. Like that you have to understand. Okay, everyone. Now, let's again come to this point. AND means A dot B means A intersection B, right? After the symbol, if I will discuss about the truth table. Truth table, right? Now, truth table is called relation between inputs and outputs. So in the input and output, whatever the relation is called nothing, it is just a truth table. So how many inputs are there? 2. So for the 2 input, how many combination possible? Can anybody give an answer? For the 2 bits, how many combination are possible? 4 combination, right? So हो गया 0 0 0 1 1 0 और 1 1. Now, if I want to write A dot B, 0.00, 0.10, 1.00, 1.1, 1. So everyone try to understand. Here we can make a very simple statement. And what is that statement? Ki AND is nothing, it is not a logic actually. It is not a gate actually. This is a logic. And what is the AND logic? Whenever the any input is low, the output is going to be low. Output is going to be high only when all the input is high, then only the output is going to be high. It's called AND logic. Suppose we have a 5 subjects. If in the any of the subject you are going to fail, overall you are going to fail. This is called AND logic, right? So AND is nothing, it is just a logic in which we can say that whenever the any input is low, the output is going to be low. It's called nothing, it is just a AND logic. Now, hope you guys understood. So if you understood, after the second, let me discuss about the third point. Right. After that, let me discuss about the third point, symbol, truth table. Enable disabled condition. Sir, what should be the meaning of enable disabled condition? So before going to that, everyone try to understand. This is called AND gate. And this terminal, which is of blank terminal, which is not connected to, suppose I'm connecting A to this particular point, right? And this is your out. So this terminal, which is hanging, this terminal, which is not connected to anything, this is a hanging, are considered as a floating terminal. That will be the considered as a floating terminal. Sometime control input. Sometime it is also considered as a strobe. So terminal which is not connected to anything, the terminal which is not connected to anything will be considered as a strobe, floating terminal or control input. So now everyone try to understand. Now, suppose we have connected 0 to this particular strobe, control input or floating terminal. And in this circuit, I am connecting 1. Now everyone try to understand. If I will ask the question, if I am applying here the 0. So can anybody give an answer? What is the output? 0.0, you will get 0. And now if you'll apply the 1, we are changing the A only, right? So A 1.0, what the value we are getting? 0 again. 0. It's not grounded, it's I'm just applying. Grounded, you can say that, right? Okay. Now everyone try to understand. If I will ask the question to you, okay, what is your name? You will say your name, right? After that, if I will ask the question, okay, what is your girlfriend name? Again, you will say your name only. Then I will ask, what is your best friend name? Again, you will say your name only. Then I will ask, what should your neighbor name? Again, you are saying the same name, right? Your name. So whether I'm asking changing the question, but you are not changing the output. If you are not changing the output corresponding to the input, means you are enabled or disabled. Definitely you are disabled, right? So if I will change the input and output is not going to be changed, means circuit is going to be disabled. So my dear friend, whenever you want to disable the AND gate, you can connect the one input to the 0. If you will connect the any input to the 0, the AND gate is going to be disabled. Because in the other terminal, whatever the value you can apply, always you will get the output 0 only. And that's why we can say that AND gate is also referred as control 0 disabled. Because in the control terminal, if I will write the 0, if I will apply the 0, the circuit is going to be disabled. So this is called control 0 disabled. Understood everyone? What value you will get? If you'll apply the 1, here we are getting 0. So 0.1, what value you will get? 0.1, we are getting 0. And if you'll apply the 1, then 1.1 will get 1. So we'll change the input, the output is also going to be changed? Yes, sir. If we are changing the input and output is also changed, it means enabled or disabled? Enabled or disabled? So we are changing the input, output is also going to be changed, definitely it's enabled. So we can say that this AND gate is also known as control 1. So AND gate is also called controlled 1 enabled. Right? Okay. So for the 0, we are disabling the AND gate. For the 1, we are enabling the AND gate. Now, fourth, there will be the one law, theorem or law that is called commutative law. Commutative law. What should be the meaning of commutative law, everyone? Commutative law means, suppose this is an AND gate. Suppose this is the AND gate, and now if I apply A, B, so it will become A dot B. Now I'm interchanging the inputs. Commutative means interchanging the value. So if I will interchange, it will become B, it will become A. Now it will become B dot A. So whether the A dot B or B dot A, both are basically same or different? So both are basically same. How we can say that both are basically same? Look at the truth table. If I will interchange the value of A and B, if A column and B column are interchanged, then the output is going to be changed or same? So same we are getting the output. इसको यहाँ ऐसा कर दो, तो भी output you will get the same only, right? So it will follow the commutative law, means AND gate will follow, as well as the OR gate is also going to be follow the commutative law. Now if I will ask about the associative, what should be the meaning of that? Everyone try to understand associative law. For the associative law, what should be the meaning of associative? Everyone try to understand. If I will make the logic gate in such a manner like this, right? Okay. Suppose if I will associate the two value first, A and B, then it will become A dot B. And now with the third, we are writing the later on. And if we are interchanging any of the variable, first we are associating. Suppose I'm associating B and C. So it will become BC. And now with the A, so it will become BC dot A. So it will become BCA. And now commutative law follows. No order we can change. Still both are basically same. Still both are basically same, right? So AND gate as well as OR gate both will follow the commutative as well as the associative law. Both will follow the commutative as well as associative law, right? Now, whatever we have learned, just to go through once. जो भी आपने पढ़ा है, एक बार just to go through once. एक बार पढ़ लीजिए. I'm just giving you 2 minutes for that. Your notebook and close your eyes. Notebook और eyes दोनों को close करना. और अगर आपने कर दिया notebook और eyes दोनों को close, तो write down yes into the comment box. If you have closed your eyes and notebook, then write down into the comment box. बहुत ही बढ़िया. Okay, संदीप कह रहा है no, can't type if the eyes closed. Once कर दिया. Yes sir, done. अरे जिन्होंने कर दिया उन्होंने टाइप कैसे कर रहे हो फिर? How could you type after the closed eyes? Okay. चलिए close करिएगा and visualize your pages, classes where the notes are basically written, right? Try to visualize it. What we have learned, I'm just speaking it with the words. You have to flow, you have to recollect the memory where you have made the notes, right? Everything you have to try to understand, right? और सब देखने की कोशिश करना. In the first class, I have discussed about in the digital logic, you have to solve the PYQs. Theory only by the question. Theory in the classroom we'll discuss. Questions also, some of the question we'll discuss. You have to solve the PYQ of CS, ECE, EE or instrumentation branch, IN. After that, we have discussed book's name also we have discussed, that is Morris Mano, Floyd, Tossi, like that type of book is good book for the digital logic. After that, we have discussed about the syllabus. In the syllabus, first logic gates, in that NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate. Inhibition. Second, we have discussed about the minimization. There will be the two parts, Boolean algebra and K-map. Then third, combinational circuit. In the combinational circuit, we will discuss comparator, mux, or comparator, half adder, full adder, half subtractor, full subtractor. Multiplexer, demultiplexer, encoder, decoder, code converter, serial adder, parallel adder, look ahead carry adder, that is LACA, and a multiplier in the last, and designing of the combinational circuit. After that, we'll start the sequential circuit. In the sequential circuit, 4 topics are there: latches, flip-flops, registers, and counters. Then FSM, that is finite state machine. After that, delay. And then in number system, the number system consists of 2 parts: base conversion and magnitude representation. Magnitude representation will split into the 2 parts. That is called fixed point and floating point. Fixed point we'll discuss in digital. Floating point, the Vijay sir is going to be discussed in COA, Computer Organization and Architecture. After that, we have started the number system, basic part of the number system, so that we can understand the subject in very good manner. So we started the basic of number system. In the number system, we have started the first thing, right? Sir, base. Base means how many digits are basically there in the system. That is called base, right? Base or radix. So we have discussed binary, the smallest base, in which the digits present 0 and 1. Then base 3, 0, 1 and 2, so on, right? Like that. Then we have discussed about the concept of the minimum base. How we are going to find out, right? Okay. Suppose 1, 5, 6 is there. And I'm asking what should be the base. So 6 is the maximum digit. So base will be 7, 8, 9, 10, so on, like that. After that, we have discussed, okay, how we are going to convert the any base into corresponding decimal. So suppose A3, A2, A1, A0, point A minus 1, A minus 2 is there, base R. So their weight will be R raised to power. When the A0 is there, the base is R raised to power 0, A1 base R raised to power 1. Coefficient and their weight must be multiplied and added so that it will be converted. Then we have discussed a few questions. In the binary, 11 I have given, right? How we are going to convert into the decimal 11011. Like that, lots of questions we have discussed, right? Okay. So we know that only coefficient and weight are multiplied and added. That is the answer in decimal. After that, we have discussed 2 raised to power 0 means 1, 2 raised to power 1 means 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8, 2 raised to power 4, 16, 2 raised to power 5, 32, 2 raised to power 6, 64, like that. 2 raised to power 10, 1024. Then we have discussed whenever the units are length, weight, height, right, time, frequency, then kilo means 10 raised to power 3, mega means 10 raised to power 6, giga means 10 raised to power 9. But whenever the units are data, means bits and bytes, then unit kilo means 2 raised to power 10. Mega means 2 raised to power 20. Giga means 2 raised to power 30. Tera means 2 raised to power 40. Like that it is going to happen. After that, we have discussed, this is in the bind, we know that, right? Okay. Now, 2-bit are called byte. 4-bit are called nibble. 8-bit are called byte. Byte B means capital B. Bit means small b. That's the meaning. Generally, they are using the notation like this. After that, we have started, if this point you understood, then we have started numbers. Okay. After that, we have started the NOT gate. Okay, usse pehle bhi. Any functions are there, we can write the function into 2 parts. One is called SOP, second one is called POS. SO means sum of product, POS means product of sum. SOP, the terms of SOP is called min term. Terms of POS is called max term, right? Max term. Min term and max term are complement of each other. But SOP and POS are not complement of each other, right? Okay. No. If you understood this point, we have discussed the table form also, how we are going to write the min term. If A, B, 0, 0, 0, 1, 1, 0, 1, 1 is there. For the min term, 0, 0 means A bar, B bar. 0, 1 means A bar, B. 1 0 means A B bar, 1 1 means A B. For the max term, 0 means as it is variable, 1 means complement of variable. So 0 0 means A plus B. 0 1 means A plus B bar. 1 0 means A bar plus B. 1 1 means A bar plus B bar. And then we have taken the function, right? 0 1 1 0 like that. And we have discussed how we are going to write into the SOP and POS form. After that, we have started the NOT gate. NOT gate means if you'll apply the 0, you will get 1. If you'll apply the 1, you will get the 0. Either I can use the word NOT gate, negation, complement logic, all having the same meaning, right? NOT gate, right? Inverter, negation, complement logic, all having the same meaning. 3 symbols also we have done. Triangle uske aage 0, triangle ke piche 0, and only the bubble is there, right? That is called. If you'll apply the 0, you will get 1. If you'll apply the 1, you will get 0. If you'll apply the A, you will get A bar. And how much time it will take? 1 top PD. That is called propagation delay. Propagation delay means time required by the circuit to give the output or to produce the output when inputs are basically connected. Okay. Then we have discussed in the NOT gate how the waveform is there. In the last class, that is yesterday, we have discussed NOT gate is there. If the graph input is there, how you are sketching the output. We have to complement and shift it according to the delay. Kitna delay utna shift karna hoga. Like that we have to. After then, the today's class, 2 NOT gates are in the series. This is called buffer. Buffer is used for the delay. Whether the delay is advantage or drawback, both. It will depend upon the application. Then 2 NOT gate into the feedback. And we have used the word, it is called bistable multivibrator, basic memory element, bistable multivibrator, or DC generator. DC having the frequency 0. Because in the circuit, whatever the value we can apply, the same thing is going to be stored. And so we can say that whenever the even number of NOT gate in loop, always it will generate the 0 Hertz signal. And called basic memory element or bistable multivibrator or DC generator. When after that we have taken the 1 NOT gate in the loop, we have sketched the waveform. After the top PD, 0 will become 1, 1 will become 0. So in the graph, 0 1 0 1 is there, waveform is there for the high low, and for high up to 1 top PD, low up to 1 top PD. So time period is called 2 top PD, frequency is called 1 upon 2 top PD. Then 3 NOT gate we have taken. So again 0 1 0 1 it is happening. For 0, 3 top PD, for the 1, 3 top PD. So one time period is called 6 top PD. So frequency is 1 upon 6 top PD. Then we have discussed the 5. So for the 5 top PD 0 and 5 top PD 1. So time period is called 5 top PD plus 5 top PD, that is called 10 top PD. And then we have discussed whenever the odd number of NOT gates are basically in the loop, then if n is the called number of NOT gate in loop, the frequency is called 1 upon 2n top PD, or time period is called 2n top PD. After that we have discussed, right, if n are basically identical, right? So these points we have covered, right? Okay. After that, when odd number of NOT gate are basically in the loop, the circuit is known as astable multivibrator, square wave generator, clock generator, free running circuit, and ring oscillator, right? Okay. After that, we have done one numerical, which having the answer 50 megahertz, right? 5 NOT gate in loop, top it is 2 nanosecond. Nano means 10 raised to power minus 9. 1 upon second is called hertz, right? Then we have given the one question, 1 NOT gate in the loop and 1 into the outside. And then we have to sketch the waveform. And here we have concluded the outside of the NOT gate is only the shifting the graph. It does not change the frequency. So first you have to waveform at X and then invert it and shift it. Then by the 3 NOT gate also we have done like this, right? Then ending and ORing operation is happening. 0.00, 0.10, 1.00, 1.11, A.1, A.0, 0, A bar, that is called 0. For the OR gate, union, 0 ORing 0, 0, 0 ORing 1, 1, 1 ORing 0, 1, 1 ORing 1, 1. And one thing is important with the OR gate, 1 ORing anything will become 1. And 1 ORing A bar is also 1. So 1 ORing anything will become 1. A ORing A bar is also called 1. Then we have started the AND gate. In the AND gate, first the symbol is there, A dot B or A intersection B. Then we have discussed about the truth table. 2 inputs, so total 4 combination. And 0.00, 0.10, 1.00, 1.11. So we can say that AND is a logic in which whenever the any input is low, output will be low irrespective of the other terminal. Or the output is going to be high only when all the inputs are basically high. Then we have discussed the enable disabled. One AND gate is there. input is A and a second terminal is floating. That second terminal, floating terminal, is called stop, floating terminal, control input. In the floating terminal, if you will apply 0, the circuit is going to be disabled. In the floating terminal, if you apply the 1, the circuit is going to be enabled. And that's why AND gate is also called control 0 disabled control, because in the control terminal, if you apply the 0, it is going to be disabled. If control terminal, if you apply the 1, it is going to be enabled. Then we have discussed it will follow the commutative as well as associative law. A dot B is always equal to B dot A, and A dot B dot C is always equal to A dot B. किसी भी दो को ऊपर नीचे कर दो, कोई फर्क नहीं पड़ता. That's what we have discussed. अब I scroll लीजिए आप लोग. And now tell me, up to everything is basically cleared or not? क्या याद है अभी तक की सारी चीजें? अगर मैं एक पेज दूं और मैं आपसे बोलूं कि okay, write down. If I'll give you the one sheet and if I will say okay, write down all the things which we have learned, how many of you are able to write? अब हमारा जो डिस्कशन होने वाला है वो what we have learned till now, we have covered the NOT gate, right? After the NOT gate, we have covered the AND gate. That AND gate also we have covered, right? Basic part of the number system also we have covered, isn't it? AND gate I think also we have covered, right? Isn't it? AND means what? Intersection. That's the most important thing. One thing more, if we have covered the AND gate, is suppose if I'm asking the one more question on the AND gate. This is AND gate, right? So if we'll provide you the A and this is called B, so definitely this is called, either you can write A dot B or you can write A intersection B. Both are basically having the same meaning, right? Sandeep, a very good morning. Now Mithun, a very good morning, beta. Magesh. अब देखो, intersection means what? The common. Have you heard about the set theory? In the set theory, intersection means whatever the common value, that common value we have to choose, right? Now, if I will observe, if I will take the one question and the question is like, if I'm giving you the one question in this part only. Oh, chalo. यहाँ लिख देता हूँ. This is called A, this is called B, and this is called output Y. If we know that if A equal to, this is just a representation in the mean terms, right? I will discuss about those. Sir, we have 1, 3, 5, and 7. If the 3 variable is there, only 5. Up to 0 to 7 we can write, right? Now. And B is called, I will discuss this thing later on, right? This is just a way of representation of the any function, the SOP form, right? Now, if I will ask what should be the value of Y, can anybody give an answer? Now, the rule is not going to be changed. This is the intersection. Sir, NOT gate duty cycle concept is pending, sir. Arre, wait, beta. I will cover those portion also. Sir, if I want to solve this question, then this is the AND gate, right? So we have to find out the Y is called A intersection B. So the common part only we have to write, right? So common part is called 1, 5, only 5. So answer will be 1 and 5. This is the answer. Hope you guys understood how we are going to do it. Isn't it? Everyone write down yes or no? If you understood this point, बहुत ही बढ़िया. Now if you understood, let's move into the next, right? थोड़ा सा next part पे चलता हूँ. मैं आपको समझाता हूँ. If you understood this point. We have to just take the common, that's it. Nothing more than that. Now, after the AND gate, let's move into the OR gate, right? Okay, one thing more I want to ask the question. Suppose asking one more question. This is A and this is B, right? And now my question is, This is given A, and this part is called B. Can you sketch the value of Y? Sketch the Y. Y. When AND gate is ideal. Ideal means no delay is there. When AND gate is ideal. Sorry, can you tell me? And if I will ask sketch, इसमें डिले कितना लिया था? 0 ना? आइडियल. Two microsecond. No. So when both are high, we can draw high or else low. Are Rohini, both are high. This is a end. This is a end logic. Yes, 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 yes. Then only we can make. Yes, true, true, true. Yes, Arjun. Now everyone try to understand. In the first case, if you want to discuss, we already know that. One means high voltage, 0 means low voltage. So if you want to sketch it, we already know that. This is called 0, and this is also 0. This is 0, this is 1. This is 1, this is 1. This is 1, this is 0. This is 1, this is 0. This is 0, this is 0. 0 and 1. 1 and 0. 1 and 0. 0, 0. 0, 0. 1, 1. Like that. So you have to sketch in such a manner. You have to sketch in such a manner. Whenever the any input is low, the output is going to be low. So if I will sketch it, low. सारा लो ही है तो yes, here we are getting like this. This is your output Y. Because in this case only the 1 1 is there, otherwise everything is 0. How many of you are getting the same answer, everyone? How many of you are getting the same answer? That's great. अब बहुत ही बढ़िया, शानदार. Now, if I will ask the question, sir, already we know that. This is looking like this, right? Now we have to sketch the Y. This is not a Y because now the 2 microsecond delay is there. So 2 block we have to shift it. So we'll shift the 2 block. It must be looking like this. If we shift the 2 block, everything will be shifted by the 2 block, right? Isn't it? Okay, बाद होगा. I have not mentioned, but no. This is your output Y. This is output Y. How many of you have one block? If you will shift, you will get here. Another block you will shift, you will get here. All are basically 0. How many got the same point? Same answer for the Y? No. Let me give you the one more question, everyone. Now, everyone, now I am asking the one question. Now I am asking the one question. Suppose all logic gates are ideal. All logic gate are ideal. Then sketch Y. Sketch Y. And if I'm asking the question, all logic gates are if I'm asking the delay of 1 microsecond and delay of AND gate is 0. Only NOT gate का delay दे रखा है. This is a 1 microsecond. Now can anybody give a sketch? First this waveform. Now everyone, we already know that if all are basically ideal, then we already know that how we are going to solve it. Y is called nothing, it is just a. Here you are getting A, here you are getting A bar. So it is called A dot A bar instantly. Both we are getting at the same instant because the delay is 0. So A dot A bar itself is clearly 0. And if you want to sketch it, we can directly think like, okay, first we have to invert it and delay is not mentioned. So directly we can invert like this. This is called A bar. And now if you'll do the Y, so Y is called nothing, it is just a low on, right? Low. Everywhere you will get right low. But if I will changes the something, right? And now I'm asking the question. Can anybody give an answer? Delay is there. Now everyone try to understand. Suppose I'm saying this is called A, but this point is called P. Because P is called nothing, it is just a bar only. Right? P is called nothing, it is just a bar, but after the 1 microsecond, isn't it? That's why I'm not mentioned the A bar only. If I will mention the A bar, you will feel that okay, at t equal to 0 only we are getting. So first let me discuss about the P value, right? P is called complement of this. So if you want to complement it, it must be looking like this, right? This is just a complemented form of A. It is not by the shifted, right? We'll shift it right later on. Later on means right now I'm shifting it. Now everyone, this is called A P. This is called A bar actually. But A bar is not P. A bar shifted by the one block is called P, isn't it? If I will give you the A curve and I will ask how you are going to sketch the P. Already we have given, right? We have solved this type of question. Okay, I have to shift this graph by 1 unit, isn't it? So complement the value, we have complemented now shifted to the 1 unit. So let me shift to the 1 unit. Like that it is going to be. and this is called P. And one thing more you can understand. Initially, this is starting from t equal to 1 microsecond. If people will think what is the value of this, initially always you can consider as a 0 only, if you require. भाई solve करने के लिए 0 चाहिए होगा. If they will asking the question from the t equal to 0. So initially you can consider as a 0 only. Otherwise, I'm not going to consider. I'm just leaving it. Okay. Now everyone try to understand how we are going to do it. Sandeep. Now, why we are directly sketching? Because they have not mentioned the delay of the AND gate. If they will mention the delay of the AND gate, then whatever the class ending operation, this one and this one, we have to operate, and then shifted by the delay of this AND gate. AND gate delay is 0 mentioned, right? So like everyone try to understand. 1, 0 or 1. So 0 you will get, right? One and 1. So we'll get 1. 0 and 0. Sorry, 1 and 0. So we'll get 0. Till that 0 only you will get. This is also 0. And you will get, right? Now 0 0, this is 0, this is 0, so you will get 0. Only at this particular point you will get AND. Like that it is going to happen. Because at this particular point you will get now, this is a 1, this is 1. The rest you will get here only. This is 1, this is 1. Rest anywhere in this particular graph, if this is 1, this is 0. So we are not going to get anything. How many of you are getting the same answer? If you understood it, let me give you one more question. Sketch the Y. This is A bar. Again, this is called A. This is called P. P is called 1 unit delay of this complement of A, right? So we have to complement this value and then shift by the 1 unit. Now shift by the 1 unit. If I will shift by the 1 unit, it must be looking like this. This is called your P actually. This is called your P. And now A dot P if you want to sketch. इसी और कलर से sketch कर देता हूँ. Let's sketch with the red color. If I will sketch A dot P. A dot P, if you sketch, you will get this line only, right? Isn't it? This is called A dot P, right? But this is not your final answer. Why? This is A dot P only, right? This is A dot P. Now, can anybody give an answer? How many we have to shift this graph? Why? How many unit? This red one. Shift by 2. But AND gate having the delay 1 microsecond, na? So why we are shift by the 2? By shift by the 1 unit only, right? भाई A और P का ऑपरेशन करने के बाद जो रिजल्ट आएगा उसको तो एक ही यूनिट शिफ्ट करना पड़ेगा ना AND gate में. So we have to shift it by using 1 unit, right? So I have shifted by 1 unit. You will get like this. This is your output Y. So let me make first. This is A dot P and Y मैं यहाँ बना देता हूँ. Y is called, we have shifted this, so this one you will get Y. So Y is, if you'll forget about this particular 2 block, Y is basically complement of the A you will get, isn't it? Why you are getting just like a complement of A. Four option also I'm giving you for this, right? A option is called if node gate is ideal, then Y is always 0. If a node gate is ideal, then it is always, Y is always 1. C option. If X moves or transit, anything we can write. Moves from 0 to 1, then Y also transit. Transit यानी move करे. Transit to 1. Then y also transit to 1, यानी 0 से 1 y भी जाएगा. If x moves from 1 to 0, then y also transit to 0. Now everyone, this is a MS2 question. What is /r? Correct for y. Do you know what should be the meaning of MSQ? Multiple select question, right? If x here C option में if then y transit to 0. इसमें ये भी लिखो एक सेकेंड. इस ऑप्शन में एक और आना चाहिए था. नोट आइडियल. सी और डी ऑप्शन. Not ideal. Ideal means no delay. No, at least you can think for this, right? Ideal x dot x bar is the y. X dot x bar is called 0. So A option is correct. It does not directly we can say that. So of course B option is wrong. A में तो कोई दिक्कत नहीं होगा. Now observe the C option, right? They are saying for the if x moves from 0 to 1. So if x move from 0 to 1, this is 0 to 1. X is moving from 0 to 1. This is called x. If x move from 0 to 1, then what is the condition of y, right? So everyone try to understand. If x move from 0 to 1, तो उसके लिए सबसे पहले x ये है, तो क्या मैं p का ग्राफ बना लूं? Can I sketch the graph of p? After the some delay, inverted form, but after the some delay. Like this. This is called p, we can say that. X bar per after the some delay. So this portion I'm just considering as a delay. Not yet. Delay of load. And now if you'll do the ending, so that is called y. If you'll sketch the y, 0, only for this you will get 1 and then delay. So definitely you can feel when x transit to t equal to 0, when x transit to 0, 1, then y is also going to be transit. दिख रहा है? Everyone, have you able to understood? If x is transit, x moves from 0 to 1, then y is also moving from 0 to 1. So of course we can say that C is also correct. Transit to 1, yes, absolutely C is correct. Explain Tulika ये वाला. देखो x क्वेश्चन में क्या था? The C option, तुलिका try to understand. C ऑप्शन में क्या है? जब x 0 से 1 जा रहा है, 0 मतलब लो वोल्टेज, 1 मतलब हाई वोल्टेज होता है. तो जब x 0 से 1 जा रहा हो, यानी 0 से 1 की तरफ मूव कर रहा है, तो मैंने 0 से 1 मूव करा दिया, छोड़ दिया. फिर तो x किया है, तो p क्या होगा? यहां पर जब x 0 से 1 मूव हो रहा हो, तो p का ग्राफ क्या बनेगा? सो p का ग्राफ बनेगा reverse order of this after the some delay. So I'm forming the reverse and then delay is there. You can feel it must be looking like this. अरे यार एक सेकंड. First we'll get the delay, right? And delay part, if you'll consider, that much delay I am considering for the NOT gate. Now we have to do the ending of these two things. If we'll do the ending of these two things, you will get the answer. Now, D part is given when x transit to 1 to 0. So for the X now I am forming from 1 to 0. Look at here, 1 to 0. If X transit from 1 to 0, then what should be the value of P? P is just a reverse of this, but after the some time. So we'll shift this graph by 1 time delay of the P, right, NOT gate. So let me discuss this in a NOT gate delay. And now if we'll consider, if we'll sketch the Y, always you will get 0, isn't it? Always you will get 0. Look. Given delay is there, Sheikh. I mentioned here, look at here. NOT gate is not ideal. Not ideal means there will be the some delays there. They have not mentioned how much delay is there, but definitely there will be the some delay. So of course, why transit to 0? It's not like that. It's not transit. It's fixed at 0. So D is wrong. Transit means they will switch from 1 to 0. Then only the transit. Transit means transition is going to be happened. If instead of transition, if they will use the word, then the Y always 0. Then D is also going to be correct. Then D is also going to be correct. Because you can feel here, always Y is going to be 0. But they have not mentioned always 0. They have mentioned the transit. They have changed to value 0, but they are not going to change. So this is wrong. How many of you understood this point? Write down yes or no. ये हो सकता है आपके लिए थोड़ा सा difficult question हो. Transit means change. Whenever the Rajeshwari, the transit is going to be happen, it means they are going to change. So transit means you can feel here. The transit is happening. This is called transit. Oh, this is called transit. Means change from 0 to 1. Zero to 1. Here no transit. Why? Because fixed at 0. No transit means change hona. So now everyone understood. And believe me, this question came into the gate 2024. And 99.99% student has done the mistake in this question. So now understood, this is a gate PYQ question actually. Let me write it. Gate 2024. So this is the question also came right into the, so you do not feel that this type of question never going to become right. Already asked into the exam. Understood or still having the doubt? Everyone, कहीं पर भी doubt हो आप पूछ सकते हो. If anybody having the doubt in any of the top. Let's move to the next part. That is called. Think one more time for this question, and then still if you guys having the doubt, we'll again, right, explain. Don't worry about that. Let's move into the OR gate. चलिए साहब OR gate discussion करते हैं. OR gate. If I will discuss the first point, that is called symbol. Symbol of the OR gate. So everyone try to understand. OR gate having the symbol like. So this is called A, this is called B. This is called A ORing B, or you can use the word A union B also. Either A ORing B or A union B, we can use the word, right? Okay. After the symbol, if I will discuss about the truth table. Truth table is called relation between inputs and outputs. So if I will make the truth table, it's looking like if I will use the word A ORing B, 0 dot ORing 0, 0, 0 ORing 1, 1, 1 ORing 0, 1, 1 ORing 1, 1. So OR is a logic, right? And what is the logic of the OR gate? If whenever the any input is high, the output is going to be high, irrespective of the other terminal. Or in other words, whenever all the input is low, then only the output is going to be low, is called OR logic. Now for the third one, enable, disabled, if I will explain. Now we know that a terminal which is not connected to the anything as consider as a floating terminal, straw or control input, anything we can connect, right? So everyone try to understand. A terminal which is not connected to anything, right? What the name of this terminal? Either you can use word floating terminal, straw or control input, all having the same meaning, right? So if I will discuss about this one. In the floating terminal, straw or control input, we are connecting 0 and we are connecting 1. And this is called A. This is called the output. Now everyone try to understand. If you write 0, 0 ORing 0, you will get 0. If you write 1, 1 ORing 0, you will get 1. So we are changing the input, yes. The output is going to be changed, yes. So we are changing the input, the output is going to be changed, means enabled or disabled. So if we are changing the input and output is also changed, means enabled condition, right? So we can say that AND gate is also called control 0 enabled. Because in the control terminal, if you use the 0, the circuit is going to be enabled. Circuit is not going to be disabled, right? Enabled. But in the AND gate, if I will connect 1 here, you will feel everyone. Now here, if 0 is there, 0 ORing 1, you will get 1. If I will use the word 1 ORing 1, 1. So whatever the input is there, the output is not going to be changed. So if we are, whether the circuit output will depend upon this value A? No, sir. The nature of A is going to be disabled, right? And that's why we can say that whenever in the OR gate, any terminal is 1, the other terminal does not make any difference. The circuit is going to be disabled actually. So the OR gate is also called controlled 1 disabled. Controlled 1 disabled. So control 0 enabled, control 1 डिसेबल कहेंगे। चलिए भाई साहब, इतनी चीजें क्लियर है, आगे बढ़ते हैं। Okay, now commutative and associative law, that is the fourth one if I will discuss about. Commutative law first. Commutative law means what? A ORing B is always equal to B ORing A. Sir, how we can say that? Look at the truth table. Sir, when we use the enable or disable, once we are not using here, when this will use into the some of the operations, right? Where I will say, okay, the OR logic is are there, or some variables are basically there, suppose A, B, C, D, some there. But we do not require those variables. So I will say, okay, just disable those variables. Now you will think how you are going to disable. By using OR gate and the other terminal, we can use one. So that variable is automatically going to be disabled. In the masking operation, we are going to utilize. Generally, in the processor, it is happening. Now, so you can follow the OR gate. यार एक तो सोने में कोई दिक्कत होगी गर्दन पे, ऐसे मुड़ ही नहीं रहा है. So if you'll interchange the value of A and B, it does not make any difference. Look at here, A and B is basically there. And if you'll interchange the value of A and B, the output is not going to be changed. And that's why we can say that it will follow the associative law, right? Sorry, commutative law. And now if I will discuss about the associative law, AND gate as well as the OR gate, both commutative and associative, both law, they are going to follow. So if I will ask about associative law, if I will discuss about the associative law, try to make it. Look at here. This is called A, this is called B, and this. First I'm associating with the two, A and B, and then we are associating with the C. Here, if you want to write, suppose first we are associating with the B, so it will become B ORing C. And now we are associating with the A, so it will become A ORing B ORing C. Whether it will make any difference? No, sir. Both are basically same. It does not make any difference. Both are basically same. So the AND gate as well as the OR gate both will follow the commutative as well as the associative law. Now you can make a one note. One node you can write. And what is the note? Look at here. Whenever any logic are designed by TTL, they will use the word TTL. Sure, look at here. Purnisha Paul. Okay, now, whenever any logics are designed by TTL, what is the full form of TTL? Transistor logic. Sometime they will use the word, right? TTL. Only they will use the word. You should know what should be the meaning of this transistor. They will never ask you in the detail because this is not in syllabus. But yes, the few questions asked where they use the word TTL. So whenever any logics are designed by the TTL, TTL means transistor logic. Whenever any logics are designed by the TTL, then floating terminal means a terminal which is connected to nothing, right? Then the floating terminal always acts as a high. Then the floating terminal always acts as a high. So I'm not getting what should be the meaning of this one. Everyone try to understand. Suppose if I will ask the question, suppose by the example, if I will say, okay, this is an AND gate, right? This is A, this is B, this is A, and this is B. And now I'm asking what should be the Y if the logic are designed by the TTL. Can anybody give an answer? Now they will ask if the logics are designed by the TTL, what should be the output? So we should know, okay, the word is TTL is used, means a terminal which is not connected to anything. By default, that terminal is treated as a 1. Are you getting my point? A terminal which is not connected to anything, But if the logic or anything is basically designed by the TTL, then a terminal which is not connected to anything will be considered as a 1 only. So if it is not connected to anything, we'll consider this one as a 1. So the output is called nothing, it is just a dot b dot 1, even though it is not connected to anything. So we can say that output will be a dot b only. Still you guys having the doubt? Let me give you the one more question, everyone. If I will say this is a logic which is connected to TTL, what should be the output Y? Can anybody give an answer? All of you please respond for this at least, right? सबको अपनी अपनी वाली की कसम है भैया, और जो वाली है उनको वाले की कसम है, जल्दी से आंसर बता दो. 1 और 0 ना, 0. अरे we'll get the answer 0. Shayan, I have given the answer कि whenever the any logic are designed by the TTL, तो floating जिस भी Shayan मेरे भाई, ऐसा अगर कभी भी तुमको कोई भी तुम रास्ते पे चल रहे हो, किसी ने तुमको चिल्ला के बोल दिया TTL, तो तुमको उससे लड़ना नहीं है. तुमको ये मान के चलना है कि जैसे वो TTL बोल रहा है, जो भी टर्मिनल खाली है उस पर 1 लगा देना है. तो मैंने आपसे पूछा कि ये क्वेश्चन, इसका आउटपुट क्या होगा? 2 टर्मिनल पे A और B दे रखा, तीसरे पे खाली, बट आपसे दे रखा ये TTL का बना है, तो ये खाली छूटा हुआ है, फ्लोटिंग है, ये किसकी तरह काम करेगा? ये बाय डिफॉल्ट 1 की तरह काम करेगा. TTL दिया हुआ इसलिए 1 की तरह काम करेगा, तो आंसर हो जाएगा A ORing B ORing 1, और 1 ORing anything will become 1, so answer is 1. बिल्कुल संदीप. So now onwards you have to remember the one word, the TTL बोले तो 1. Now just reverse of this, there will be the one logic is also there, and that is called ECL. ECL means emitter coupled logic. Emitter coupled logic, and then floating terminal always acts as a low. Whenever the any logic are designed by the TTL, the floating terminal always acts as a high. Whenever the any logic are designed by the ECL means what? Emitter coupled logic. Then floating terminal always consider as acts as a low. Sir, I'm not getting what should be the meaning of this. Meaning of this one is like this. Can anybody give an answer? What should be the output Y? Now everybody must respond for this, right? It's not complicated question I've asked, right? Very good. Why we are saying that it is 0? Because a terminal which is not connected to anything, but if it is designed by the ECL, we are considering as a 0. So this is called A dot B dot 0, and this is going to be 0. Right? So hope you guys understood how we are going, what should be the meaning of this, right? TTL and ECL. Understood everyone? Write down yes or no. Understood the meaning of TTL and ECL? Chaliye sahab, we know that what should be the meaning of TTL and ECL. Okay, one thing more I want to share. If I will ask the one question, everyone. If what is Y? Can you give me the answer of y? What should be the value of y? We know that AND means intersection and y means union. So now we have to perform the union, right? So the y is called nothing, it is just a ORing B, or this is called A union B. So A and B union we have to do 0, 1, 3, 6 and 7. All value you have to consider 0, 1, 3, 6, 7 is the correct answer of this question. Absolutely. So you guys are aware about this, right? Okay, very good. We'll introduce the delay also into the OR gate, but before going to that, let me discuss about the next one that is called NAND gate. After that, we'll come back again. We'll club together and we'll give the answer, right? So next, if I will discuss about the NAND gate first. First, if you will discuss about the symbol of the NAND gate. NAND gate is called nothing, it is just a reverse of the AND gate. What is M here? Okay, Samardeep, M, min term. I will discuss later on. This is summation M is called nothing, it is just a min term. These all are called min term, and this is called sum of products. SOP expression. Okay. Sum of min terms. NAND is called reverse of the AND gate, right? So we can say that this is called A, this is called B. So this one is called A dot B. In the bahar nikalte time, dekho, in the outside the bubble is there. So A dot B ka bar. Right? Okay, now. Because this is called AND N. So whatever the AND is there, we have to reverse it. Now question arises, everyone. Have you heard about the one theorem that is called De Morgan's law? Have you heard about the name, the one theorem that is called De Morgan's law? Or people who have heard the name, it's fine. Then De Morgan's law is called Todo or Jodo. Bilkul Abhishek. Break the line, change the sign. Sabka bar to chota chota bar. If A dot B bar is there, so break the line and change the sign. We can also write like B bar. This is called De Morgan's law. बिल्कुल शेख, सबका बार तो छोटा छोटा बार. अब बार के नाम पे भावुक नहीं होना है ना. सुबह सुबह का समय है, ज्यादा भावुक नहीं होना है. Okay. It means we can make the NAND gate by using the OR operation also, but not ORing of A and B, ORing of A bar and B bar. So the same thing we can design by the OR gate also. But ORing of A bar, ORing of B bar. So if you write it, look at here. If you write it, this is called A, this is called B. So here you are getting A bar. Here you are getting B bar. This is the OR operation, A bar ORing B bar. And the output, nothing is there. So directly we are taking A bar ORing B bar. And again, by the De Morgan's law, we can write like this. So everyone tried, lots of people are thinking this is an AND gate. Yes, this is an AND gate. But this is also an AND gate. Sometimes it is referred as bubbled OR gate. Sometimes it is referred as bubbled OR gate. But bubbled OR gate itself is called nothing, it is just a NAND. Meaning of this one is called NAND. So sometimes they will use this type of symbol, you can understand, okay, this is NAND gate is basically asked, right? Okay. Now, after the truth table, if we'll move into the next, the symbol, we know that. Now we are going to discuss about the truth table. And NAND gate is inverted form of what? AND gate. So whatever in the table in the AND gate is there, we have to reverse it. So we can feel reverse of the AND gate. In the AND gate, any input is low, the output is going to be low. It is reverse. So any input is low, the output is going to be high. Output is output is going to be low only when all the input is low. Then only the output is going to be. All the input is high, then only the output is going to be low. This is called nothing. It is just a NAND logic. Now, can you give me the answer for the enabled, disabled? Whether it is a 0 enabled or 1 enabled NAND gate. Anyone?
Sir, 1 enabled.
Very good. ओके, बहुत ही बढ़िया. देखो मैं भी बना देता हूँ. For enabled, disabled, right? So my dear friend, for the enabled, disabled, look at here. Here I am connecting 0 and here I am connecting 1. Now, if I will apply the 0, 0 dot, देखो 0, so you will get 1. If I will apply 1, so 1.0, again we are getting 1. So we are changing the input. Output is not going to be changed. So definitely it is a disabled. So we know that NAND gate is also called, just like a AND gate, NAND gate is also called control 0 disabled. Control 0 disabled. Now here you can feel. If I will apply the 0, you will get 1. But if I will apply the 1, 1.1, you will get 0. So we are changing the input, the output is going to be changed. So definitely it's enabled. But enabled like what? Inverter or buffer? Control 1 enabled. Look at here. If you'll apply the 0, you will get a 1. If you'll apply the 1, you will get 0. So it's enabled, but enabled like inverter. Whatever the value is there, reverse value will get. Reverse value you will get. Now, can anybody give an answer whether it will follow the commutative law? Whether it will follow the commutative law? Yes, sir. If I will interchange the value of A and B, the output table is not going to be changed. So for the fourth point, for the commutative law, I will discuss. Commutative law, if I will discuss, then definitely we can say that A dot B ka bar is always equal to B dot A ka whole bar. It will follow the commutative law. But if I will discuss about the associative law, can anybody give me the answer? If I will discuss about the associative law, whether it will follow the associative law? Look at here. This is called A dot B ka bar, and now it will become AB ka bar dot C ka whole bar. Now, if I will interchange the value first B and C and then with A, so it will become BC ka bar, and now A dot BC ke bar ka whole bar. Whether both are basically same? No, sir. Reverse. Opposite. Other value we are getting, not reverse actually. Other value we will get. So definitely it will not follow the associative law. The same thing has happened with the NOR gate also. AND gate, NAND gate as well as the NOR gate both will follow the commutative law, but does not follow the associative law. Can you make the symbol and all the things for the NOR gate? Anyone? Look at here. If I will discuss for the NOR gate, look at here. This is called A, this is called B. So here you are getting A, B, A ORing B. In the output it is bubbled. So A ORing B ka bar. Again, by the De Morgan's law, we can break the line and change the sign. So break the line, change the sign. By the De Morgan's law, we can write. So A ORing B ka whole bar itself is called A bar dot B bar. So we can make an alternate symbol also. Can anybody think what the alternate symbol? By the AND gate also we can make. But we have to do the ending of not A and B. We have to do the ending of A bar and B bar. So we can also say that look at here. This is called A, this is called B. So here we are getting A bar. Here we are getting B bar. So this is called A bar dot B bar. In the output as it is, it will be happened. And now by the De Morgan's law, again, we can write A ORing B ka whole bar. So both are basically same. But this is also referred as, yes, bubbled AND gate. Bubbled AND itself is called nothing, it is just a NOR. NOR is just a reverse of the OR gate. So now if I will make the truth table, whatever the OR gate truth table is there, we have to reverse it, right? So if I will make it, it must be looking like this. In the OR gate, whenever any input is high, the output is going to be high. It is a reverse. So whenever the any input is high, the output is going to be low, low, low. Output will be high only when all the input is low. That is called nothing, it is just a NOR logic. And if I will discuss the third one, that is enable disable. Enable disable. Everyone just make the enable disable. Okay. If you'll apply the 0, 0, NORing 0, you will get 1. And if you'll apply the 1, 1, you will get 0. So we'll change the input, output is going to be changed. But change like inverter. So this is called control 0 enabled. Like OR gate. OR gate is also control 0 enabled. But control 0 enabled like buffer OR gate, and NOR gate is just like inverter. Here if you apply the 0, right, again you will get 0. And if you'll apply the 1, again you are getting 0. So we'll change the input, output is not going to be changed. So definitely it is disabled. So control 1 disabled. All right. And for the commutative associative, if you want to discuss. Commutative law, if you want to discuss everyone how it is going to be happened. So we already know that A ORing B ka whole bar is always equal to B ORing A ka whole bar. Look at the truth table. By the truth table, we are able to understand. But if I will discuss about the associative law, NAND and NOR. Like this, right? And if you'll interchange the B, C, and this is called A, so it will become B, C ka ORing bar A. It is called A ORing B, C ka bar ka whole bar. And they are not going to follow, right? They are not going to follow. Right? If you understood this point, let's move into the next. Everyone understood this point? Write down yes or no. So it is not going to follow the associative law. So AND gate and OR gate both will follow the commutative law, but does not follow the associative law. So 2 points are important from here. First point is called NAND gate, NOR gate. Follows the commutative law but does not follow associative law. Follows commutative law but does not follow the commutative law but does not follow associative law. Follows the commutative law but does not follow the associative law. Second point. NAND gate and NOR gate are called universal logic. NAND / NOR are called universal logic. Now the question arises, sir, what should be the meaning of universal logic? If by the help of any logic you are able to design all the logics, then that logic is called universal logic. Okay, suppose this is a marker. By the help of this marker, if I were able to make all the markers, then this marker is called nothing, it is just a universal marker. Suppose by this remote, I'm able to make all the remote, then this remote is called universal remote. Suppose ये एक mobile है. Suppose by this mobile I'm able to make all the mobiles, then that mobile is also called universal mobile. Suppose by the circuit you are able to make all the circuit, then it is called universal circuit. Suppose by the one truth table you are able to make all the truth table, then it is called universal truth table. Like that. by the NAND and NOR, you are able to make all the logic gates. That's why it is called nothing. It is just a universal logic gate. Now, two questions I am giving you, right, as a quiz in very simple manner. Whether in front of you, have you appeared the quiz?
Yes, sir.
आ गया आप लोगों के पास? I have tried first time, right? Even in the GFG, Kicksburg is the first time this quiz happened. Everybody responded. If you have responded, do let me know, right? I will end the quiz. Right? I'm just giving you for the 2 minutes for this particular question, right? So 49 seconds हुए हैं. Sir, for poll, क्या बोल रहे हो बेटा? Sandeep sir, for the poll questions, use Kahoot app. ये क्या है बेटा? ये तो मैंने कभी नहीं चेक किया है. Kahoot, let me check. Okay, got the point. So I'm just still 74% people responded for that, right? पता नहीं क्यों. सबके नाम भी दिख जाएंगे. People who has not responded there. अच्छा, मैं तो भूल ही गया. कुछ लोग तो सिर्फ क्लास देखते हैं. They are not coming for the interaction. Okay. Now everyone try to understand. In this question, you can feel कि sir first question we know that NAND gate is universal logic, right? ये तो सबको पता है sir. Now what about in the second question? Sir, first two options are, we know that first one is called AND gate, second one is called NOR gate. But what about the third and fourth? Third and fourth is neither NAND or NOR gate. So how can you say that this is also you have made the universal logic? ये कहीं गलती तो नहीं हुई है? No, it's not like that. Okay. और भी कुछ है? अच्छा, डाउनलोड द रिजल्ट भी होता है. ओहो, ये अच्छा, ये सब तो मुझे पता ही नहीं था. Okay. Now everyone.
Sir, please mention your Telegram channel name.
Digital Logic, Chandan sir. या digital Chandan sir by Chandan sir Gate search कर लेना. Anybody please share into the group. Now everyone try to understand how we can say that the universal logic, why NAND and NOR. Apart from this, everyone try first. Before going to that, let me give you, if any logics are basically there, right? And with the help of this logic, if you are able to make the NAND gate any A dot B ka bar or A or in B ka bar, anything, if you are able to make it, then this is also called universal. We know that this is called universal, but by the any of the things you are able to design this, then it is also will become universal. Sir, how? That portion we are going to cover tomorrow. तो ये हम कल डिस्कशन करेंगे. Okay everyone. अरे बोल दो यार.
Sir, can you please
Yes, sir.
show the third and the fourth options of the second question?
That's why I've given. I've just discussed those questions tomorrow. यही तो सस्पेंस छोड़ा है मैंने.
No, sir, just the options so that we can think.
All the option, because with the a dot b bar. लो यार बता ही देता हूँ पहले, नहीं तो तुम सो भी नहीं पाओगे पूरे दिन. Look at here, how we can say that is a universal logic. Everyone try to understand. First, let me discuss about the a dot b ka bar. How it is looking like? It must be looking like this, isn't it? Huh? It must be looking like this, so that it is called a. B, it will become a dot b bar. Right? Okay, now if I will discuss about this one, so forget about the a and b, focus on this particular symbol. Now everyone try to understand. If I will use 1 here and here a, what is the output you will get? Can anybody give an answer? What is the output you are getting? Sagar only responded. Other people are not able to respond. Abhishek, how 1 you will get into the output? अरे इसका आउटपुट तो बता दो यार, कम से कम इतना तो बता सकते हो. Suppose in the gate 2 marks question came from this, right? What is the output? A bar, of course. Sir, here we are getting 1. Here we are getting a bar. So 1 dot a bar, and output a bar you will get, right? A bar we are getting. Now, I'm connecting to this A and here a bar, and this is called B. One more I'm using. Now everyone, can anybody give an answer? What should be the output for this? What should be the output of this? So we will get, this is called a bar, this is called b bar, a bar dot b bar. And can I write a bar dot b bar as a or in b ka whole bar? So what you made from this? What you made from this? Some NOR gate. So definitely by this also you are able to make the NOR gate. And that's why it has become universal logic. I've given the idea na? किसी भी चीज से, not only for a dot b bar, by the a bar b also, by the any of the expression, if you are able to make these two type of expression, that will become, this will become also, will become universal. Now look at the next one. Suppose if I will ask a or in b bar, so what should be the meaning of this? This is called like this, isn't it? This is like this. One variable is as it is, second variable must be the complement. And to complement that second variable, we must require the bubble. Now look at here. Now everyone try to understand. If I will apply 0 here and here a, can anybody give an answer? What should be the output you will get? What should be the output you will get? Zero. इसमें तो मेरे, suppose 2 marks question came into the gate examination, still people are basically doing some of the people are doing the wrong answer, right? This is 0. This is called a bar. 0 ORing a bar. 0 ORing a bar is called a bar. So in the output you will get a bar only. Why you people initially writing 0? गलती कर दोगे बेटा गेट में. एंड गेट में ध्यान रखना, एक गलती, ये एक गलती नहीं होती है, 365 दिन होता है वो. आपकी पूरी मेहनत पे पानी फेर देता है. सो टू बी अ वेरी वेरी सीरियस. We are not forming the both need the bubble, then directly by the one only it will be happen. Sandeep, If both I will make the bubble, then no need to discuss. Already we know that this is called NAND gate only. तो एक ही NAND gate की तरह होगा. If both need to be bubbled, no? Yes. So here we can see that now if I will use B. So now can anybody give an answer? What should be the output you will get? What should be the output you will get? Yes, true, Sandeep. Sir, we'll get A bar or in B bar. And by the De Morgan's law, we can write A dot B ka bar. So by this, you are able to make what? NAND gate. And that's why we can say that this is also called universal logic. So everyone try to understand. NAND gate and NOR gate is universal logic. Everybody knows about this. But in the gate exam, they will not ask the question which is basically known to the everyone. Some of the things which is known to the rare person, or some of the things which require IQ level to solve those questions. Only that type of question they will ask in the exam. But believe me, in the digital logic, whatever the question they will ask, everything from our notes. So don't worry. Right? Okay. So everyone try to understand. They will ask about the universal logic. अगर वो universal logic पूछ रहा है, then you can feel both are basically same. They will give you like this, then also it's fine. If they will ask like this, then also it's fine. A bar dot B, then also it's fine. A B bar, then also it's fine. A bar plus B is also universal logic. A plus B bar is also universal logic. Apart from this, if they will ask about the mux, this is also called universal logic. If they will give you the decoder plus OR logic, that is also called universal. Because if they will give you the decoder and OR, by the help of these two things, you are able to make all the logic gates for it. 9, 10. So later on, right, you can feel, and this is also called, in the discrete mathematics, you will understand, this is also called functionally complete. Right? Later on we'll discuss. But at this particular moment, okay, guys does not have any idea about mux and decoder at this particular moment. Try to remember it. Whenever this topic will come, I will cover this portion also, right? Don't worry. I will prove it. So hope you guys understood up to this portion. So let's give you some question. NAND or NOR we have covered now. Okay. Good morning, Mugesh, Harshit, Lohitha, Rohan, Chandan, Mithun, Sheikh, everyone. Rohini, Shushma, Harshit. Okay, Divant. So I'm giving you just, this is not a three, you can say that option. This is a 3 question I have given. 1, 2, 3. You have to solve this question corresponding to this, right? Okay, one thing more I want to tell you. Everyone try to understand. Whenever the NOT gate is there, means you have to complement the value. So for the 3 variable AB, 3 variable total 0 to 7 value is there. Right? Complement means what? Whatever the value is there, reverse value you have to write here. Like that you have to do. तो एक बार solve करेगा तीनों question. Okay, now everyone try to understand. Sir, A, if I will give you like this, 0, 1, A I am giving you. I will apply to this. B, I will apply to this. C, I am just applying here, right? So first in these 2 things, we have to write the common. So here we are getting the common part. And means intersection, that is the common. So 1 and 3 you will get here. Because only 1 and 3 is common in these 2 things, right? Okay. And now in these 2 things, union we have to perform. So if we'll do the union, it's the meaning of union means what? ORing we have to, right? ORing means union we have to perform in these 2 things. So 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, 5, 6, 7. 5, 6, 7. Now, everyone try to understand this NOT gate, this NAND gate we have to perform like AND gate and that NOT gate. That's the meaning of this. Right? NOT gate and NAND gate means what? AND gate and then NOT gate. That's the meaning of this. So here we are getting 1 and 3. And this portion we are getting 0, 1, 2, 3, 5, 6, 7. So what is common? 1 and 3 is common. So here we are getting 1 and 3. And NOT gate means the complement of this value. So apart from NOT 1 and 3, all value we have to choose. 0, 1 is not there, 2, 3 is not there. So 4, 5, 6, 7. This is the answer you will get. How many of you are getting the same answer? Everyone write down yes or no. कितने आप में से हैं जिनको सेम आंसर मिल रहा है भाई बता दो जल्दी से. For all, right? Okay, so all you are getting. Okay, now that's great. So 4 is not there. Oh, it's not like that. 4 is not there. Right, 1 and 3. Apart from this one value from 0 to 7, all the value will come here. It does not mean that 4 is there or not. Nagesh, are you getting my point? Because set for the 3 variable, the set is from 0 to 7. So we have chosen some of the value in A, we have chosen some of the value in B, we have chosen some of the value in C, like that, right? So 4 will be also will come, right? Okay. Now for this question. Now for the second question, everyone. OR means union and then reverse of that, right? So first, if I will discuss about what should be the meaning of A union B. This one. So A union B is called like all value we have to write 0, 1, 2, 3, 6, 7, 2, 3, 6, 7. And then for this we have to use the complement value. So A union B ka complement if you want to find out. This is called apart from this value. So 3, 4 and 5 you will get. So here we are getting 4 and 5. Hope you guys understood. This is called A union B ka complement. So first we have done A union B, and then complement means apart from this value you have to choose. Now B and C intersection we have to write. So common is 2 and 6. So here we are getting 0.6. These things union we have to perform. So this is called 2, 4, 5 and 6. And this is called C is as it is this. So we have to write the C is called 0, 2, 5, 6, 7. Now we have to write the common things between these two values we have to choose. So common means what? 2, 5 and 6. This is the answer you will get. How many of you are getting the same answer for this question? Very good. Other people. Very good. Excellent. Okay, now let's move into the next, that is question number 3. हमको प्यास भी लग रही है. Can you give me 1 minute for this? If you have solved this question, just do it. Otherwise, just give me 1 minute. Now, have you solved this question? Have you done for this? Everyone, look at here. First, complement of A value we have to write here. So what should be the complement of A? 0, 1 नहीं है, 2, 3 नहीं है, 4, 5 and 6. Now, common between B intersection. So 1 is 2 and 6. So here we are, complement of 2 and 6. Okay. So A bar intersection B is called 2 and 6. Because we already know that A bar 2, 4, 5, 6. So if I will take the intersection between B value, you will get like this. So A bar intersection B ka whole bar, that is output of the NAND gate. You will get the complement of the all values. So complement of this value is called 0, 1, 2 is not there, 3, 4, 5, and 7. So here we know that what value will get. 0, 1, 3, 4, 5, and 7. Now, union we have to perform for the B and C. So if you'll do the union of B and C, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, कहाँ गया भाई? 0, 1, 2, 3, 5, 6, 7. 5, 6, 7. Yes, 0 is the correct answer. Well, 5 is the correct answer. Null. So what value we can write? Everyone try to understand. Now, ORing, first, if you want to discuss, suppose I'm writing this is called P and this is called Q. So P ORing Q, if you P union Q, if you want to write, that is all value. 0, 1, 2, 3, 4, 5, 6. But Y is called P in union. P union Q ka bar, and this is called 0. Now this is 0. This is not like if you write like this, means 0 value you are choosing. But if you write like this, means answer is 0. Null answer is there. Understood? So this is your answer. In the option, if they will give you like this, one of the option is like this. They will ask, this is answer? No, this is not an answer. Simple 0 is the answer for this, right? Sorry. Now, hope you guys understood up to this portion कि हमने अभी तक क्या पढ़ा है question. And now let's time to revise all the concept. How many of you have gone through this? इसलिए मैं कल की PPT लेके आया हूँ. You can feel. Sir, AND is called nothing, it is just an intersection, means the common part. OR is called nothing, it is just a union. We have discussed some graphical technique, how we are going to do it, right? Okay. So we have discussed if A and B is there, how we are going to sketch the graph, how the intersection is going to be happen. 1 means high voltage, 0 means low voltage. So we'll do like intersection only we are doing, right? After that, if the delay is there, how we are going to solve the questions, right? We have discussed those things also. NOT gate is basically there and the delay is not there. If the delay is introduced, then how we are going to sketch it. So some delay related problem we have done into the yesterday class. So yesterday class is not the theoretical. Mainly the yesterday class is related to numerical. In the yesterday, we have discussed the mainly OR gate, NAND gate and NOR gate. OR gate is nothing, it is just a, you can say that OR gate means the union, right? Whenever the any input is high, the output is going to be high irrespective of the other terminal. Enable, disabled, the OR is called control 0, enabled, control 1 in disabled, right? So itself is says O. O means 0. 0 means what? Enabled. So control 0 enabled, control 1 disabled. It will follow the commutative as well as the associative law. Then we have started whenever the any logics are designed by the TTL, the floating terminal always acts as a high. Whenever the any logic are designed by the ECL, ECL means emitter coupled logic, then the floating terminal acts as a low. After that, यूनियन ये तो हमने ये क्या कर दिया था भाई. So for the union we have discussed the question, right? Nothing more than that. Then NAND gate is just a reverse of AND gate. So either we can use the NAND gate or we can use the symbol like bubbled OR gate. Bubbled OR gate itself is called NAND gate. Then truth table is called NAND is just a reverse of the AND. So AND is called whenever the any input is 0, the output is going to be 0. Here if any input is 0, the output is going to be 1, irrespective of the other terminal. In other words, whenever all the input is high, then only the output is going to be low. Just like a AND gate, it is also control 0 disabled, control 1 enabled. But enabled like inverter. It will follow the commutative but does not follow the associative law. Follow the commutative law but does not follow the associative. Either we can use, or it is called just the reverse of the NOR gate. So either we can use the word or we can use the bubbled AND. Bubbled AND itself is called NOR gate, right? Or is a logic in which whenever the any input is high, the output is going to be low, irrespective of the other terminal. Or in other words, whenever all the input is low, then only the output is going to be high. OR is control 0 enabled. So NOR is also control 0 enabled. And control 1 disabled. It will follow the commutative but does not follow the associative law. NAND and NOR are all called universal logic. So now I have discussed something yesterday. It's not only A dot B bar or A ORing B bar is called universal logic, right? Whenever any logic gate is basically there, if I am able to convert that logic gate into the form of A dot B bar or A ORing B ka whole bar, then that expression is also called a universal expression. Like we have taken A dot B bar. A dot B bar, how it is looking like? So A dot B bar is basically looking like this. A and B bar, so B we are inverting it. And then AND gate is there, A dot B bar. Now the question arises, everyone. A dot B bar is there. Now the question arises, he said, okay, it means, look at here, put this circuit only. This is called like this. So one terminal I am connected to 1 and the another terminal we are connected to A. So output will be A bar. Again, we are taking the same thing we are using. So if I will use the this type of, you can say that circuit, we are able to make the NOR gate. In the similar manner, if I will use this type of circuit, with the help of this, I am able to make the NAND gate. So definitely by this, we are able to make the NAND gate. So this is also called universal logic, isn't it? So I have mentioned it's not only these 4 things are called universal. These 4 things are basically aware about all of you, right? A bar dot B is also called universal logic. A dot B bar is also called universal logic. A bar plus B is also called universal logic. A plus B bar is also called universal logic. Multiplexer is also called universal logic. Decoder plus OR logic are also called universal logic, because I will discuss this thing into the combinational circuit, right? Already we have discussed this part here. Now everyone, so this is a yesterday class, right? Okay, now let me discuss about how or why we can say that NAND and NOR are universal logic. So everyone try to understand. At this particular moment, we are starting the XOR gate, right? After the XOR gate, again I will take the session, right? Next class of NAND gate and NOR gate. Because by the NAND gate and NOR gate, I am able to design all the logic gates. So by the NAND gate and NOR gate, we will make the XOR gate also. But how will we make the XOR gate? So first, let's understand the XOR gate, and then we are going to discuss about the NAND gate and NOR gate again. Okay. And XOR and XNOR is very, very important for the gate point of view. So now onwards, whatever I'm just teaching you, try to understand that is very, very important for gate point of view. Okay. So let me discuss about the first XOR. This is also called exclusive OR gate, right? So either exclusive OR gate or XOR gate, both are basically the same. First, I will discuss about the symbol. So XOR gate is basically looking like this is called A, this is called B. So this will become nothing, it is just A XOR B. Now everyone try to understand. This expression of the XOR gate, we can write into the 2 way. Whenever any expression are there, we can represent that expression into the 2 way, right? Into the SOP or into the POS. Both will represent the same thing, right? So I can use SOP and POS. So if I will use this one into the SOP form, sum of product, it is looking like A bar B plus AB bar. And if I will use it into the POS form, that is product of sum. This is called A bar plus B bar dot A plus B. So everyone try to understand. Both are not different. Both are basically the same, right? Both are basically same. This will also represent the XOR gate, this is also will represent the XOR gate, but in some different manner. Right? Representation is something else. Otherwise, both will represent the same logic, right? Okay. XOR gate. How we are going to remember it? Everyone try to understand. One theorem will come in Boolean algebra, and then theorem is called transpose theorem. So whenever the first and first are basically complement of each other, then you can write A bar and A is there. So if the first is complement of each other, then we can write first with the last and last with the first. Transpose we can do. So here you can feel A bar B, A B bar. Again, you are getting this. First and first are complement, then only we are able to do it. So A bar plus A bar B plus A B bar. So again, we are getting like this. This is a trick to remember, right? Okay. Now after that symbol, if I want to write truth table, truth table is called nothing, it is just a relation between inputs and outputs are called truth table, right? So relation between inputs and outputs are called truth table. The meaning of this one is called A and B. So total 4 combination will be there 0, 0, 0, 1, 1, 0 and 1, 1. And if you want to write the expression of A XOR B, how it is going to be happen? Everyone. So we can put into this particular expression, right? A bar B plus AB, either in the SOP or POS, whatever the form you are using, right? Okay. So A bar B plus AB bar. A is 0 for the first. A is 0, so A bar is called 1. Dot B is called 0. Plus A is as it is, B bar is there. So 0 ka bar, that is 1. So 0 or in 0, so it will become 0. So you can write this is called 0. Like that, you have to make all the things. Suppose for the second one, if you want to write. So 0 ka complement A bar 1 dot B as it is 1 plus A as it is B ka complement. So 1 or in 0, you will get 1. Like that, you have to make. Here also you will get 0, here 1, and here you will get 0. Right? So if you'll observe it now, you will get what you will get. If you want to observe this truth table, a very simple we can say that, sir, if A and B both are basically A and B both are basically same, then the output is going to be 0. And then A XOR B is going to be 0. And if both are basically complement of each other, then this is output is going to be 1. A XOR B is going to be 1. If both are basically same, the XORing will be 0. If both are basically complement, the XORing will be 1. That is the meaning of this. Everyone understood? So that I can extend this value to like this. So we can say that if I will ask A XOR A, can anybody give an answer? What should be the value you will get? If I will write A XOR A XOR A, this is called nothing, it is just a 0. But if I will ask what should be the value of A XOR A bar, if both are complement of this, you will get the value
1.
True. Now you can understand the one value, guys, right? If one come inside, another should go outside. Okay. If one come inside, another should go outside. So if A XOR A is called 0, and if I will ask A XOR 0, what should be the value of this?
A.
A XOR A is called 0, A XOR 0 is called nothing, it is just A. If A XOR A bar is called 1, if one come inside, another should go outside. So A XOR A bar is called 1, so A XOR 1 is called nothing, it is just
A bar.
A bar, pretty simple. And lots of question we can expect from this particular concept also, right? Suppose I'm giving you the one example, and that example is called, suppose I'm asking the one question. And if I'm asking if A XOR या X XOR Y equal to Z. Suppose if I'm writing X XOR Y equal to Z, then can anybody give me an answer? Then what is the value of X XOR Z? What should be the value of X XOR Z? So it's nothing, it is just a Y. If one come inside, another should go outside. So it is Y. If I will write, what should be the Y XOR Z? X. What should be the value of X XOR Y XOR Z? If all come inside,
Zero.
what should be the outside? Zero. That's the meaning of this, right? Hope you guys understood how we are going to do it, right? Okay, if you understood this point, let me give you the one thing more, right? अब एक ही समझिएगा. Fourth. Look at the table, right? If you observe the table now, one thing more we can say that ki output is going to be 1 high for the even number of 1 or for the odd number of 1. Can anybody give me the answer? If the input, if odd number of 1s are basically present, then only the output is going to be 1, or even number of 1s are present, then only the output is going to be odd. If you clearly observe that, sir, if even number of 1 is there, right, 1s are basically there, the output will be 0. Output will be 0. Output will present only when the odd number of 1s are basically present. So we can make a statement in very simple manner, right? That is fourth and fifth point. Maybe right, I'm writing here. In the XOR gate, output will be high in the XOR gate, output will be high when odd numbers of ones, odd number of ones are present in the input. Whenever the odd number of ones are basically present in the input, then only it is called nothing. It is just the output is going to be high. And one thing more you can understand. Okay, that's why this is also called number of 1 in the communication itself is called parity. So output is going to be detected only when the odd parities are basically there. So XOR gate is also called odd parity detector. Let me write here. So it is also called odd parity detector. Number of 1 itself is called parity, right? In the communication world, we are going to discuss, you will learn this thing into the computer network also, right? Number of 1. So here we can say that that's why it is also called odd parity detector, because output is going to be detected only when the odd number of 1s are there. And number of 1s itself is called parity. That's why we are writing odd parity detector. Okay. Now, if I will discuss about the 6th point next. Suppose for the enable disabled condition I'm just talking about, right? Everyone try to understand. I will discuss about the enable disabled point, right? So can anybody give an answer if this point I'm just connecting with the 0 and this point I'm connecting with the 1, right? Okay. This point is connected to 0 and the next point is basically connected to 1. Okay, one thing more, everyone try to understand. For the other batch student whose classes is going to be overlapped with the Sakshi ma'am class of the mathematics, so don't worry about that. That is going to be happen for the 4 or 5 class only. And the 4 and 5 class, I will take a class a little bit smaller. I will increase the duration after that, right? Okay. So don't get panic. But I know that whatever, मैं तो हर क्लास में बोलता हूँ पैनिक मत होना, फिर भी आप लोग हो ही जाते हो, मेल कर ही देते. Suppose A is there, and now if you want to find the output, so if it is 0, so 0 XOR 0, you will get 0. And if it is a 1, 1 XOR 0, you will get 1. So we are changing the input, the output is also going to be changed. So definitely it is enabled. Now for this, if you want to write 0 XOR 1, so you will get 1. And now if I'll write 1 XOR 1, you will get 0. So in the both case, the enabled is there. But enabled like what? There the 0 you will give, and in the output also you are getting 0. If you provide the 1, you are getting the 1. So it is a enabled, but enabled like buffer. It is enabled, but enabled like buffer. Here it is 0, so we are getting 1. Here the 1, so we are getting 0. So it is also enabled, but enabled like what? For the 0, we are getting 1. For the 1, we are getting 0. So definitely it is enabled like inverter. Right, inverter. Now everyone just give me the answer one. Sir, why you are writing like this? Even though we know that here the A is there and 0 is there. So if you write A XOR 0, so you will get A only. So whatever the input, you will get into the output. That's why it is called buffer. And here we can say that A XOR 1. Sorry. If you write A XOR 1, definitely the complement value you will get. So whatever the value you will connect here, the complement will come into the output. So definitely it is called nothing, it is just a inverter. Now everyone just give me the one answer of this question. Right. Give me one more. Okay. Suppose I'm giving you the one question. Can anybody give me the answer? It is a astable multivibrator or bistable multivibrator? This is a astable multivibrator or bistable, right? इसको बताओ एक बार. Everyone please respond and give me the answer of this question. Sir, this XOR gate is working like inverter or buffer? This is working like buffer. Because 0 is there, so buffer. So whatever the value is here, the same value you will get. So we can say that this is a shorted, does not make any difference. Only how many NOT gate are basically there in the loop? Only 1 and 2. This is a buffer one. And whenever the two NOT gates are, means even number of NOT gates are basically connected in the loop, the circuit will be known as bistable multivibrator. So definitely it's a bistable multivibrator. But if I will ask the question, instead of 0, if I will connect 1, now if I will ask, what should be the output? Whether it is astable or bistable. Now we can say that this is a astable multivibrator. How we can say that this is a astable multivibrator? Because so this is also working like an inverter. So odd number of node gate because it is an inverter whenever the control input is 1. Yes. So my dear friend, we can say that suppose this is called X. So if X is 0, it will become bistable, and for X equal to 1, it will become astable multivibrator. Okay. And one thing more, whenever A XOR 1 is there, you will get A bar. So if any variable is going to be complement, means this is a ones complement. So later on in the number system, I want to use the ones complement of the system. Directly we can use this circuitry also. Whatever the variable we have to complement it, we'll use this XOR gate. One terminal we can keep as a 1, and whatever the value we have to complement, that bits we can apply here. So automatic complemented value you will get. Now the people will think, sir, why you are using the XOR gate? You can use the NOT gate also. Yes, we are going to NOT gate also, but sometime we can use the variable itself. Do not require a complement. Sometime we require the complement. So if you use the NOT gate, every time you have to remove it. Suppose I'm using the NOT gate, but sometime in the circuitry, complex circuitry, somewhere we do not require to complement the value. So what we have to do now, we have to just take the NOT gate outside, right? Because if the NOT gate is there, we have to do like, they will complement it. But suppose if I will use the XOR gate, and whenever the no complement is basically required, I will generally put 0 here. So by applying the only 1 at 0, we do not require to take the or changes into the hardware. Only by the applying the bits we are able to control it. So if you'll apply the 0, they will not going to complement it. If you'll apply the 1, they will complement it. So without changing the hardware, only by the controlling terminal, we are able to control the entire operations. Are you getting my point, everyone? Now, for the 7th point, if I will look at, everyone try to understand for the 7th point. If I will ask, what should be the value of A XOR A? Can anybody give an answer?
0.
What should be 0, sir? It's very, sir, you have already discussed this is 0. Okay. If I will ask, what should be the value of A XOR A? XOR A. A XOR A XOR A.
A.
A only. Okay. Now, if I will ask A XOR A XOR A XOR A, what should be the value you will get?
So 0.
Right? 0.
0.
Again, we are getting 0. So everyone, hope you guys understood the trick, right? The meaning of this one is called if A XOR A XOR A, and I see lots of XORing is there. So 2 output you will get. Either you will get the output 0 or you will get output A. It's totally depend upon the number of A actually. For the even, this one you will get for even number of A. And A you will get for odd number of A. For even number of A and for odd number of A, right? Now, suppose I'm asking one question, everyone. This is called X and this is called, suppose this is X1. Now I will ask what should be the value you will get for the Y. Use the option also. X B X bar C0 D1 sir. Oh. Everyone try to understand. Yeah, it's a very simple question, right? How? Sir, X, you will get here the X XOR X. X XOR X is called what? Same, so 0. Now 0, so here you are getting 0. 0 XOR X. So here you are getting 0 XOR X. This is called X. Again, X XOR, this is called X. So again, we are getting 0. So now you can feel, everyone try to understand. Odd number of XORs output will be 0. And even this is not like that. This is a something else. A XOR A XOR A, we are doing like this. This is something else, right? Here I have taken x XOR x, so will 0. 0 XOR x, again x. X XOR x, 0. Next one 0 XOR x, so output will be x. So you can feel always odd number of XORs output will be 0 and even number of XORs output will be x. So they have asked 201. 201 is odd or even? So definitely odd. So output will be 0. So the answer will be C. Very simple. Only Indrajit has given the correct answer of this question. Understood, everyone? Everyone write down yes or no. Understood, because all of you have given the wrong answer, most of the person. So now understood this point. If you have understood, let me give you one more question, right? If you have understood this question, let me give you the one more question, like this is called x and this is called 1. Now, can anybody give an answer of this question? Again, 4 options are basically there. AX, BX bar, C0 and D1. If you want to solve it, it's again very simple. Sir, X XOR 1. This is called, everywhere we are getting 1 here. So this is called X XOR 1. So you will get complement. And XOR X bar XOR 1. So you will get X. If you do the XORing with the 1, you will get the complement value. X bar XOR 1. So bar ka bar, you will cancel down. So you will get X. Again, X XOR 1. So definitely 1's output X bar, 3 output X bar, 201 output X bar. If they will give you 5033, then also the output will be X bar. So the correct answer of this question is X bar only. Still only 10 or 15 people has given the answer out of 50. Now, suppose I'm just making the question a little bit complex, right? Can anybody give an answer of this question? First, this is X, right? So both are basically X, right? Other terminal is always X, isn't it? Now,
Okay, sir.
X XOR X, right? For this output, X and X both are basically X. So X XOR X is 0. So here you are getting 0. Now this 0 is XORed with the X. So 0 is XOR X, again you are getting X. So here we are getting X. Now this X is XORed with the X. So again we are getting 0. 0 is XOR X, X. Fourth is called X. Like that it will go. Understood?
Okay, sir.
Now people can think, sir, number to diya hi nahi. Does not make any difference. X XOR X, X. X XOR X, X. X XOR X, X. Whatever the value, this is called X. So answer will be A only. Now suppose if I'm asking one more question, everyone. What is the output Y? Can anybody give an answer of this question? To solve it, what should be the value you will get? A XOR B. Here, what is the value you will get? A XOR B XOR B. Right. What should be the value you will get here? A XOR B XOR B XOR A. This is the answer you will get, isn't it? This is the value you will get now. Now, always try to understand the XOR gate as well as the XNOR gate. Both will follow the commutative as well as the associative law. So I can remove the bracket also, does not make any difference. A XOR B, XOR B, XOR A. Now can anybody give an answer? A XOR B XOR B is called what? Sir, B XOR B is called 0. So we are getting 0 XOR A. Now, what should be the value of A XOR 0? Sir, A XOR 0 itself is called A. So we are getting A. A XOR A. So again we are getting 0. So answer is 0. कोई ज़्यादा complicated question नहीं था. It's very simple question, right? Most of the people has given the very good, right, correct answer. Most of them, almost everybody has given the correct answer. Now, I will discuss the more things also regarding to the XOR, but before going to that, let me discuss the one thing. Let me discuss the one thing, right? सीधा आते हैं पॉइंट नंबर कितने हो गए थे 6 7 so let me discuss point number 8. XOR gate follows commutative as well as associative. XOR gate follows the commutative as well as associative law. As this has happened with the XNOR gate also, means A XOR B is always equal to B XOR A. This is called commutative law. And A XOR B XOR C. Any two things we can associate does not make any difference. This is equal to of A XOR B XOR C. So this will follow the commutative law and as well as the associative law, both will follow. Now, can you make the table for the 3-input XOR gate? Can you make the table of 3-input XOR gate? How many of you are able to make it? How the output is going to be? Yes, for the odd number of, yes, correct. We have to count for the odd number of 1, we have to put the 1. So odd number of 1, irrespective of the position, only you have to observe whether the odd number of 1s are basically there in the input or not, right? So yes, this is 1, 2, this is a 1, even number of 1, so 0, odd number of 1, so 1, even number of 0, even number of 0, odd number of 1. Now everyone try to understand. In the later on, I will discuss about the mean terms also, right? So, but at this particular moment in the decimal, this is corresponding to 0, this is corresponding to 1, this is 2, this is 3, 4, 5, 6, and 7. And if you'll observe, where you will get the output, 1 you will get, 2 you will get, 4 you will get, and 7 you will get. So now onwards, one thing more you can understand. A XOR B XOR C equal to 1, 2, 4, 7. In the mean terms, 1, 2, 4, 7s are basically present, right? I will discuss later on also for this, but why I'm writing it? Because XOR gate will come lots of place into the digital logic. And XOR gate is already a minimized expression. So whenever the A XOR B XOR C will ask, you have to remember 1, 2, 4, 7. Or whenever the 1, 2, 4, 7 is there, you can remember, okay, this is corresponding to 3-input XOR gate. And we are not able to minimize it. That's the meaning of it. Everyone write on yes or no, please. Right. If you understood this point, it's very simple. It's not that much of complicated or things, right? Okay. Apart from the XOR gate, I will discuss about the XNOR gate also, right? But as already I have discussed, key for the 2 or 3 class, might be 3 class more remaining. I will take a little bit slower, right? I will leave the session within the 1.5 hour, right? After that, we'll accelerate it. We'll cover those half an hour also, right? Later on. After that, we are going to discuss about the XNOR gate also, right? So hope you guys received the DPP. And one thing more, everyone try to understand. DP means daily practice problem, right? But we are not giving you the DPP. I'm just giving you the practice sheet. So this is a practice sheet actually, right? Sandeep, PYQ भी हो जाएंगे, don't worry, right? You are able to solve it. I will give you the PYQ also, don't worry. Topic भाई, हाँ वो हो जाएगा पेन पेपर से, don't worry. चलिए, next we are going to discuss. Already we have discussed about the XOR gate. What we have learned the tomorrow, yesterday class. I just enrolled yesterday. Only was the lecture 1 and lecture 2. So will be able to follow up this session, or should I finish the record? Then you can finish the previous lecture also, but you are able to understand the today's lecture also, right? So don't worry about that. Okay. You can watch, right? But try to cover the previous lecture also, right? Of course, for the initial 10 minutes, you are not able to understand because I'm going to summarize the things, what we have learned into the yesterday class, right? Previous lecture. So everyone, what we have learned, the first we have discussed yesterday, we have started the XOR gate, right? NAND gate and NOR gate, both we have covered, and the XOR gate. NAND gate is also called bubbled OR gate. NAND gate is called bubbled OR gate. NAND is a logic in which whenever the any input is low, the output is going to be high, irrespective of the other. Or in other word, whenever all the input is high, then only the output is going to be low. It's called a NAND logic. NAND is just like a AND gate, control 0 disabled and control 1 enabled, but enabled like inverter. NAND gate follows the commutative law but does not follow the associative law. NOR gate means whenever the any NOR gate is also called bubbled AND gate. NOR gate means whenever the any logic is 1, the output is going to be 0 irrespective of the other terminal. Or in other words, whenever all the input is low, then only the output is going to be high. NOR gate is just like a OR gate, control 1 disabled and control 0 enabled, but enabled like inverter. Then we have discussed after the NAND gate, NOR gate. NAND and NOR both are called universal logic. I have discussed A bar dot B is also universal logic. A dot B bar is also universal logic. A bar plus B is also universal logic. A plus B bar is also universal logic. Sometimes universal logic is also called functionally complete. Right? In the discrete mathematics you will learn. And if you are not going to learn, I will teach you also, don't worry. वहां नहीं सीखोगे तो मैं बता दूं. If we have understood this point, let's move into the next. Then we have started the XOR gate. In the XOR gate is also called exclusive OR gate, right? In the XOR gate, what we have discussed, the first, the truth table. First, the symbol. Symbol you guys are aware. We have written the expression the two way, one in the SOP form and the second one is called in the POS form. In the SOP form, A XOR B is called A bar B plus AB bar. In the POS form, you can write A bar plus B bar dot A plus B. After that, in the truth table, for the 0 0 you will get 0. For the 1 1 also you will get 0. For the 0 1 and 1 0 you are getting output 1. And from here we have learned the one thing. In the XOR gate, whenever A and B both are basically the same, the output is going to be 0. And when both are complement of each other, the output is going to be 1. Right? XOR gate. And there we can see that A XOR A bole to 0, A XOR A bar bole to 1. If one come inside, another should go outside. So A XOR A bole to 0. So A XOR 0 bole to A. A XOR A bar bole to 1. So A XOR 1 bole to A bar. In the XOR gate, the output is going to be 1 when the odd number of ones are basically connected in the input irrespective of the terminals. कौन से terminal पे connected does not make any difference. Total number of ones should be odd. And that's why it is also called, can anybody give me the answer? Odd parity detector or even parity detector? Or we can say that for the XOR gate. Odd parity. Yes, absolutely correct. Now, after that we have started कि sir in the XOR gate ये तीन चार चीज हो गया, odd parity detector हो गया. Then XOR gate for the both 0 and 1 both are basically enabled. For the 0 it is enabled like a buffer. For the 1 it is enabled like inverter. Then we have discussed in the XOR gate A XOR A XOR A XOR A lots of time if you'll do. This is also called you will two output you will get either 0 or A. For the even number of A you will get the output 0. For the odd number of A you will get the output A. XOR gate will follow the commutative as well as the associative, both it will follow. After that we have discussed कि A XOR B XOR C बोले तो can anybody give an answer? That is a 1247 1247. You should remember these points, right? And XOR is already a minimized expression. Now we are going to discuss about the XNOR gate. Okay. Exclusive NOR gate. For the XNOR gate, always you have to remember one thing. एक चीज बहुत अच्छे तरीके से XNOR याद रखना. XNOR की जो पर्सनैलिटी है ना, आपने अपरिचित पिक्चर देखी है? How many of you have seen the अपरिचित? जो बता देता हूँ. हाँ, psychopath, yes. Multiple personality, yes. So this one also having the multiple personality. क्लियर एसी के जस्ट बगल में सो गया, कोल्ड सा हो गया, ऐसा लग रहा है मुझे, फील हो रहा है. नाउ दिस वन हैविंग द टू पर्सनैलिटी. XNOR gate. What is the personality? Now you are dealing with XNOR itself is called the reverse of the XOR or complement of the XOR. But already I have given this one having the two personality. One personality is called कि if you have an even number of input or even number of variable, then XNOR is a complement of XOR. But whenever you have an odd number of personality, then XNOR and XOR both are basically the same. Then both are same. तो XNOR कुछ होगा ही नहीं. XNOR अपने आप में XOR हो जाएगा. Are you getting my point? XNOR is the reverse of XOR gate. Is happened only when the even number of inputs are basically there. For the odd number of input, XNOR and XOR both are basically same. Suppose we are forming like, चलो अभी बताऊंगा मैं ना. For the right, I will explain it later on. Don't worry. First, let me discuss about the truth table. The first symbol. How many inputs are there for this? Even or odd? How many variables are there? Even or odd variable or odd variable? Even variable. So definitely we can say that this is a reverse of XNOR gate. And XNOR symbol is looking like this. This is a complement of XOR gate. Again, if you want to write it in the two way you can write. Into the SOP also you can write, into the POS also we can write. If you want to write the XNOR gate into the SOP form, we can say that this is called A bar, B bar plus AB. A bar, B bar plus AB. And if you want to write into the POS form, we can say that this is A bar plus B dot A plus B bar. Already in the previous class, yesterday I have given the one idea. Ki sir, the POS will be converted into the SOP by transpose. So first and first are the basically if the complement of each other, then we can write first with the last and last with the first. So A bar, B bar plus AB. Again, you will get the same. This method you can remember for the understanding, right? Now, this is got simple. Now, if you understood this point, now we can say that this is the truth table, right? So everyone try to understand for the truth table what we can say that. Okay. Symbol is there and out truth table. Truth table is called nothing, it is just a relation between inputs and outputs, right? It is just a reverse of XOR gate, right? So this is A, this is B is there. So 4 combination will be there. 0, 0, 0, 1, 1, 0, and 1, 1. Now, if you want to write A, XNOR B, so this is just a reverse. So whatever the XOR gate truth table is there, we can make a reverse of it, right? Yes, absolutely correct, Sandeep. And now from here, we can make a statement third. Okay, both are basically same. Then A, XNOR B is called 1. And if both are basically complement of each other, then we can say that A XNOR B is called nothing, it is just a 0. And now from here, we can make a statement, that is the fourth statement, everyone. If I will write A XNOR A, you will give the answer 1. And if I will ask A XNOR A bar, the answer will be 0. And again, here also you can remember the one thing. If one come inside, another should go outside. So if one come inside means A XNOR 1, if I will ask, the answer will be A. If I will ask what should be the A XNOR 0, the answer will be A bar. That's the point you can understand, right? Okay. Fifth. If I will ask for the enabling disabling condition, right? Like if I will make the XNOR gate like this. Now everyone try to understand same operation as XOR, maybe same operation. Look at here. If this is, I'm writing this 0 and this is called 1. And here if I'm writing A. So for if you want to write the output, everyone try to understand what the value. If the 0 is there, 0 XNOR 0, you will get 1. And if I will write for the 1, 1 XNOR 0, you will get 0. It means yes, it is enabled, but it's not enabled like buffer or inverter. How it is going to be enabled, right? So enabled like for the 0, we are getting 1. For the 1, you are getting 0. So yes, it is enabled, but enabled like inverter. But in the XOR gate for the 0, it is enabled like buffer. Inverter. No. 0 XNOR 1 is called nothing, it is just a 0. We can. And if you write the 1, 1 XNOR 1 is called 1. So again, it is enabled, but enabled like what? How it is going to be enabled? For the 0, we are getting 0. For the 1, we are getting 1. So definitely it is enabled like buffer. So it is enabled like buffer. Hope you guys understood this point, everyone. It is enabled like buffer. Now everyone try to understand. We can also directly say that, right? It's not complicated. So this is called A XNOR 0. And A XNOR 0 itself is called A bar. Because A XNOR A bar is called 0, so A XNOR 0 is called A bar. If you'll do the XNORing with the 0, you will get the complement of variable. And if you'll do the XNORing with the 1, you will get the same variable. So here you will get A XNOR 1. You will get the same variable. Because A XNOR A is called 1. And A XNOR A bar is called 0. So one come inside, another should go outside. Like that you have to remember. Isn't it, everyone? Very good. बहुत ही बढ़िया, अद्भुत. Now, if you understood this point, let's move into the next. In the XNOR, if you'll feel, if both inputs are basically 0, same, so the output is going to be 1. So this is corresponding to equal condition is going to be detected, isn't it? If A and B both are basically same, then only the output is going to be high. So whenever you want to find out whether two things are basically equal or not, we should always use the XNOR gate. If you want to find out whether the two things are basically equal or not, we can use the XNOR gate to find out it. And that's why XNOR gate is also called equivalence logic, equal detector, right? Like that. So XNOR is also called equal detector or equivalence logic. All right. And whenever anything is equal, that is a coincidence only. Anything is basically equal happened in, that is a coincidence, isn't it, everyone? तो उसको हम coincidence ही बोलते हैं. So we can say that this is also, because suppose I have wear the black t-shirt. Maybe some of the people, you guys also have wear the black t-shirt. So it's not that we have discussed into the telephonic conversation कि मैं भी black पहनूंगा, तुम भी black पहनना, same, मजा आएगा, same pinch, yeah. It's not like that, right? I have just, because this is a dress code actually. You have just like that, right? So it's a coincidence. That's why anything is going to be same. This is just a coincidence, right? So it is also called coincidence logic. XNOR gate is also called coincidence logic. Divyansh, how equal detector? Everyone try to. When the output you will get, when A and B both are basically equal. Are you getting my point, Divyansh? For the two input. Okay, sometime they will ask which logic is anti-coincidence logic. Can anybody give an answer? Yes. Can anybody give an answer? Which one is anti-coincidence logic? If XNOR gate is called coincidence logic, which one is anti-coincidence logic?
XOR.
XOR gate, true. Give me 1 minute. Anti-coincidence, right? Yes, XOR gate. Now, if you understood this point, let's move into the next. That is 7th point for this. And that 7th point is 7 point, if I will write. You can write a statement, XNOR gate follows the commutative as well as associative law. Just like XOR gate. follows commutative as well as associative. What they are going to follow, right? Means A XNOR B is always equal to B XNOR A. Right? Okay. A XNOR B is always, it means you can say that here. A XNOR B is always equal to B XNOR A. Both are basically equal. That is called commutative law. And A XNOR B, XNOR C is always equal to A XNOR B XNOR C. And one thing, the beauty of this one, everyone try to understand. How many variable we have used? How many variable we have used? 3. If the 3 variables are basically there, then it is a XNOR gate or XOR gate. If the 3 variables are basically, odd number of variables are basically there, this is a XNOR gate XOR. Yes, this is a XOR. This will become XOR gate. This is equal to XOR gate. I will prove it also, don't worry. Right, I will prove it. But at this particular moment, you can make. Right, okay. I will make it also, don't worry. Now, if I will ask the one question, can anybody give an answer? If I will ask A XNOR A, what should be the value you will get for the A XNOR A?
1.
And if I will ask A XNOR A, what is the value you will get? अच्छा जी, 0.
A.
Always it follow the associative law. So A XNOR A, if you write, you can write like this also. A XNOR A is called 1. And 1 XNOR A is called A. So you will get A answer. Right? So A XNOR A is called G1. If I will ask A XNOR A, that is called A. And always we know that for the even odd number of inputs, they are behaving like a XOR gate only. So A XOR A is called nothing, it is just a 0. And 0 XOR A is also called A. So same you will get, right? And now if I will ask again A XNOR A, XNOR A, XNOR A. So what should be the value you will get? Can anybody give an answer for this? Everyone please respond for yes. 1, absolutely. Mithun, it's not A, it's 1. Right? Because A XNOR A is called 0. A XNOR A is, sorry, 1. A XNOR A is called 1. A XNOR A is called 1. So 1 XNOR 1 is called nothing, it is just a 1. So hope you guys understood the meaning of this. So we can write if A XNOR A, XNOR A, XNOR से बर्थडे A है, you will get the 2 values only. Either you will get 1 or you will get A. For even number of A, you will get 1, and for odd number of A, you will get A. Now, okay, before that, let me prove it also here. मैं इसको भी यहीं पे prove कर देता हूँ so that you will get the clarity. देखो भाई साहब, XOR for the odd number of A, the output will be, wait beta, wait. For the XOR gate for odd number of A, for odd number of A, the output will be A only for the XOR gate वंश. कैसी बातें कर रहे हो, जो पढ़ा दिए. अच्छा, ये तो कल की क्लास में पढ़ा दिया था ना. XOR A is also called A only. Look at the notes, right? Zero, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. क्या हो रहा भाई? If I will ask A, XNOR B, XNOR C, A XNOR B, XNOR C, if I will write like this. दोनों का XNORing है. XNOR C, what should be the meaning of this? He said, first we'll do the XNORing with the A and B, and then whatever the result we'll get, we'll XNOR with the C. That's the meaning of this, right? So now everyone try to, and for the XNOR gate, if the both variable or inputs are basically same, the output is going to be 1, and for the complement, the output is going to, or for the reverse or complement, the output is going to be 0. So A XNOR A is called 1, and that 1 XNOR 0 is called 0. For 0 XNOR 0 is called 1, and that 1 is XNORed with the 1, you will get 1. For 0 XNOR 1, you will get 0, and that 0 is XNORed with the 0, again you will get 1. 0 XNOR 1, you will get 0, and that 0 is XNORed with the 1, you will get 0. 1 XNOR 0, 0, and that 0 is XNORed with the 0, you will get 1. Like that you have to form it, right? So again, you are getting, everyone try to understand, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. You will get output is at 1, 2, 4, at 7. Have you remembered? The same thing you are getting into the XOR gate also. A XOR B XOR C. And same thing you will get. Same thing you will get. And that's why I can say that this A XNOR B XNOR C is always equal to A XOR B. XNOR is never going to be XNOR whenever the odd variables are basically there. It is going to do with complement of the XOR gate only when for the even number of variables, right? So we can say that, everyone. So I can make a note, right? Everyone try to understand. That is important. Everyone try to understand. And what is that note? He said XNOR gate is complement of XOR gate when XNOR gate is complement of XOR gate when even number for even number of variables, right? XNOR gate and XOR gate are same for odd number of variables. or odd number of variables, right? That point is very, very important. You can remember, right? If you understood this point, let me discuss the one thing more, right? Everyone write down yes or no. Up to this portion, everything is clear to you? Now, if you understood this point, one thing more I want to share, alternate symbol. Everyone try to understand for the alternate symbol. One thing you can understand. Yes, sir. One is called AND gate, right? Or first, if you want to discuss about the NOT gate, so either you can make like this is also fine. You can make like this, it is also fine. You will make like this is also fine. All are the basically the NOT gate, inverter, negation, complement logic, anything you can use the word. Second, if you want to discuss about the AND gate, everyone try to understand how the AND gate is looking like. AND gate is looking like this, right? Now, AND gate we can also make the alternate symbol by using bubbled NOR gate. Either you can use AND gate or you can use bubbled NOR gate. Both are basically same because everyone try to understand here. This is called A, this is called B. So here you are getting A dot B. Here it is A, it is B. So here we are getting A bar, here B bar. This is A bar ORing B bar. In the output it is bubbled. So A bar ORing B bar ka whole bar. By the De Morgan's law, A bar ka bar dot B bar ka bar. And bar ka bar is called what? Again the same variable A dot B. So this is looking like bubbled NOR gate, but bubbled NOR gate itself is called nothing, it is just AND gate. I have explained this thing earlier, everyone. हमने पढ़ लिया क्या ये? If I have explained this one, then we'll move into the next. I didn't have any idea. मुझे ऐसा लगता है मैंने NAND और NOR का बता दिया था, इसका नहीं बताया था.
No, sir.
NAND or NOR we have discussed, right? So we are discussing all the things into the some, you can say that the proper manner. Now if I will discuss about the OR gate, alternate symbol of OR gate. देखो भाई साहब, OR gate is also represented as bubbled NAND gate. So if I will make bubbled NAND gate, both are same. So look at here, AND gate is called bubbled NOR gate, OR gate is called bubbled NAND gate. You can also feel like it is A, it is B, so definitely it's A or B. Here we can say that A or B. So here we are getting A bar. This is called B bar. This is A bar dot B bar. In the output it is bubbled, so A bar dot B bar ka whole bar. And now it is called A or B. Right? Now, fourth one we have already discussed. NAND gate already we have discussed. NAND gate is called bubbled OR. NAND gate, we know that if it is a NAND gate, it is called bubbled OR gate, right? bubbled OR gate. NOR gate, if I will ask, then we already know that this is called bubbled AND gate. So one thing more you can feel. If here it is a bubble, then outside for the AND and OR you have to make. If into the output, input is always bubbled for the everywhere, right? Input is always bubbled, right? But in the output, if this side is not a bubble, then here we have to make the bubble. If this side does not have any bubble, then next side we have to make the bubble. But in the output it is a bubble, so here we do not require. The output is a bubble, so here we cannot require. For the remember, you can think like this, right? And now for the sixth point, if I will discuss for the XOR gate, everyone. If you want to discuss, everyone try to understand for the how the XOR gate is looking like. We know that this is called XOR gate, right? But XOR gate we can make by the one terminal of changing the XNOR gate also. This is XNOR gate. Only one terminal we can change, either A and B, anything. The XNOR gate itself is converted into the XOR gate. If you break the one leg of the XNOR gate, it will be converted into the XOR gate. If you break the one leg of the XOR gate, it will be converted into the XNOR gate. So XNOR and XOR gate both are basically converted to each other. If you will convert into, sir, we know that for the even number of inputs or even number of variables, they are complement of each other. भाई साहब रुको, वो उठ गई, चुप चुप, अच्छा गोती, चलो 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 भाई 2 मिनट का टाइम है इसको, हाँ एक यहीं बैठो, हाँ. So what we can understand, everyone try to understand how we can say that everything try to understand, right? Suppose I am writing this is called A, this is called B, so this will become A XOR B. How the XOR gate symbol is basically, or how the XOR gate is basically looking like, sir, A bar B plus A B bar, है ना कुहू? ओए तू भी सीख ले बेटा डिजिटल लॉजिक, ओए ओ प्ले ग्रुप, इधर देख, इधर इधर इधर. Now if I will make, here we can say that if A and B is there, this is a XNORing, but this is a XNORing of what? A and B, not A and B XNORing. It is a XNOR B, A bar XNOR B, sorry. And how the XNOR gate is looking like? Junior gate is present, yes. समझ में आ रहा है? ठीक. A bar XNOR B, A bar XNOR B. Now how the XNOR gate we can open? First का bar dot second का bar plus first dot second. कुछ समझ में नहीं आ रहा है उसको, इतना गंदा पढ़ा रहा हूं मैं. फर्स्ट का बार डॉट सेकंड का बार फिर बार प्लस फर्स्ट एंड सेकंड डॉट एज इट इज, so it will become A B bar plus A bar B, and definitely this is called nothing, it is just a XOR gate. So XNOR की एक टांग तोड़ी तो XOR बन गया. So everyone try to understand what we can say that from here. And one thing more we can understand, if you will write this is a XNOR gate, suppose next if you want to write for the seventh, if I will write seventh XNOR gate, sir, how XNOR gate is looking like? So how the XNOR gate we can make? by breaking the one leg of XOR gate. Any one leg. Both are basically same. How we can say that? Everyone try to understand. This is called A, this is called B. This is called A XNOR B. How the XNOR gate we can open? First, second, first dot second. This is a XOR. XOR of what? A bar B. A bar XOR B. Now how the XOR gate symbol is looking like? सुन ले. Oh. XOR gate का symbol कैसे खुलता है? First का bar dot second as it is plus first as it is second का bar. बोलो. हाँ ठीक है. देखो. बोलो first का bar. देख रहे हो? सुनाई दे रहा है आपको? तो देखो फर्स्ट का बार, भाई ये आगे ना निकल जाए आप लोगों से, आप लोग ध्यान से सुनो. फर्स्ट का बार डॉट सेकेंड एज इट इज प्लस फर्स्ट एज इट इज सेकेंड का बार. सो दिस इज कॉल्ड ए बी प्लस ए बार बी बार एंड डेफिनेटली दिस इज ए एक्स नॉर बी. हाँ पढ़ रही है, अभी इसने बताया भी था. तो बेटा एक्स सुनो, एक्स नॉर की एक टांग तोड़ेंगे तो क्या बनेगा? बोलो एक्सॉर. एक्सॉर. और एक्सॉर की एक टांग तोड़ेंगे तो क्या बनेगा? एक्सनॉर. एक्सनॉर. बोलो एनाकुहू. एनाकुहू. हाँ भाई इसको भी पूरा आ रहा है थोड़ा थोड़ा, ये मुझे लग रहा है आगे निकल जाएंगे आपसे. क्या चलो, तो इसको मैं थोड़ा सा एक्सटेंड करता हूं. आई एम जस्ट एक्सटेंडिंग इट राइट फ्रॉम द व्हाट शुड बी द पॉइंट नंबर 6 एंड पॉइंट नंबर 7 is sir A XOR B is a complement of XNOR gate. Everybody knows about that. XOR and XNOR for the even number of variable, XOR and XNOR both are basically complement of each other. Right? अरे मैंने नहीं उठाया, खुद ही उठ गई. XOR A XOR B is always a complement of XNOR gate. Now complement of XNOR gate, so how it will be looking like? Sir, okay, now if you'll make it will be happen with the one terminal of XNOR also, either A or B. ये सब बराबर ही. So एक बार होना, चाहे बड़ा बार हो चाहे छोटा बार हो, XNOR will be converted into the XOR. And if the people will think sir कि मैंने दोनों को ही टांग तोड़ दिया, तो if I will make the complement of the both terminal A and B both, then XOR itself will become XOR. So everyone try to understand. For the odd times bar, XNOR will be converted into the XOR. But if even times bar are basically there, then XOR itself is called XOR. That is the most important. Acha. Now, suppose if I will write A XNOR B, this is a complement of XOR gate. And you can also make it A bar XOR B itself is called XNOR gate. A XOR B bar. And if I will do the both terminal, then XNOR itself will become XNOR. So meaning of this one is, if I am writing like this one, both are basically same. If both terminal are bubbled, then XNOR itself is called XNOR, right? Does not make any difference. Only the difference is going to be happened when odd number of complements are basically there. Then only it is going to be happen. देखो इधर भी 1 2 3 odd, 1 2 even, so even like that. Now if you have understood this point, let's move into the next, right? यहाँ तक चीजें समझ में आ गई? No. if I will ask the question A XOR A plus B, can anybody give an answer of this question? Sir, please explain A XOR B is equal to A complement XOR B complement. A XOR A complement XOR. Okay. Both are, John already have given the idea. ये तो दोनों same ही होंगे ना. Why should you are basically talking about to prove it? Now you guys are able to prove it by yourself only. This is the meaning, right? What you are talking about. So A XOR B, so we can say that A bar B plus A B bar. Now this is called A, this is called B. So here it is become A bar XOR B bar. Now A bar XOR first ka bar, whenever the XOR symbol is used between these two terms, any of the terms. First complement, second as it is, plus first as it is, second complement. So first complement, second as it is, plus first as it is, second complement. So this will become A B bar plus A bar B. So definitely this is called A XOR B only. Right, okay. Okay. Now, same thing you can write here also. It is called A, this is called B. So this is called A XNOR B. So this is called A bar B bar plus AB. Here we can, खाली एक टांग तोड़ोगे तो XNOR XOR बनेगा, XOR XNOR बनेगा. A and B. So it will become A bar XNOR B bar. How the XNOR symbol we can use? The first ka bar dot second ka bar plus first dot second. So first ka bar dot second ka bar plus first dot second. So we can write. So one doubt, just like XOR and XNOR, do NAND and XNAND, XAND and XNAND. अरे नहीं यार, ये तो सिर्फ बना दिया गया, ये भी exclusive है, that's why EX, exclusive. Writing we are like that X. X सिर्फ तीन ही जगह लगेगा भाई, एक AND, एक लगेगा OR में, एक लगेगा आपके पास NOR में, XOR and XNOR. और एक लगता है अपनी जिंदगी में अगर सही से पढ़ाई नहीं करते हैं. If you will guys are not going to study, then X will come in your life. Not come, that word only come in your life. She or he will not come into your life. Only that word will come in your life. Okay. चलिए भाई साहब आगे बढ़े. Everyone. बहुत ही बढ़िया. That is the special logic gate. Everyone try to understand. Sir, voice is low. Okay, Dishan. Actually, three things you can feel, right? There are three types. You can classify the logic gates into the three parts. The first part is called, that is called basic logic gate, in which the AND gate, OR gate, and NOT gate will come. This is the basic building blocks of the any logics. Whenever you want to design anything, by this basic building block, you are able to design it. The second one is called universal logic, by which you are able to design all the things. That is called NAND and NOR. And exclusive OR and exclusive NOR gates are basically there. That is the special logic gates, right? Hope you guys understood this point. If you have understood this point, I have just given the question. Try to solve it. Dishan, now fine? Boys? Everyone? गलत कर रहे हो. Some of the people may think, okay, sir, this is called A XOR A plus A XOR B. So A XOR A is called 0 plus this is A XOR B. So 0 XOR, this is called A XOR. XOR gate does not follow the associative law of our OR gate. You can like this associate whenever it is a or is there or XOR gate XOR is there. XOR वाला सीख ले, बहुत इंपॉर्टेंट क्वेश्चन है. देखो सबने गलत किया कू, तुम भी गलत कर दोगे नहीं तो सुनो. Now, so how we can do, everyone try to understand how we can. तो ज्यादा हो गया इसका, चलो 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 चलो. Now, so how we can say that? Ki sir, whenever the XOR and other variables is there, you can feel between these two things we have to write. This is called A XOR. We can write X. X is called A plus B. Right? Because we can say that XOR does not follow associative law of our OR gate. Our XOR gate does not follow the associative law of our OR gate. So we have to use between these two things, XOR symbol is used, so we can write. Now, how we are going to open it? First ka complement dot second plus first as it is, second ka complement. Now you can use whatever the value is given. A bar, X is called A plus B. A, X is called A plus B. So this is called A bar dot A plus A bar dot B plus A bar dot B bar. So A bar dot A is called 0. This is called A bar plus B, and this will become 0. So answer is called A bar plus B, A bar B. This is the answer you will get. Everyone understood, right? Or yes or no? अरे कोई बोल दो यार. Everyone. That's great. So this is XOR. One question as a homework I am giving you, everyone. Already I've given the 2 or 3 class will be smaller duration, then we'll extend it, right? In the Saturday, Friday we'll discuss. If you guys are basically comfortable, we'll take this session into the Saturday extra session for that compensation, right? क्यों extra ले रहे? Because in this batch, the one of the batch is also merged, which is one already 7:30 the one class for the 2 or 3 days we have to class. Then we'll accelerate it, we'll cover it, don't worry about it. One homework question I'm giving you. A XOR B XOR AB. If like that type of things are basically there na, for the XOR gate, we can take the common also for this. Right? But try to solve it. What should be the value? You will take this question and you will take this question also. These 2 questions I am giving you as homework. At least you can try. And tomorrow onwards, we are going to discuss about the question only. And one class I will take that is not into the small portion, into the comprehensive. Maybe that class is going to be happen for the 2.5 hours. For the minimum number of NAND gate and NOR gate, how we are going to find out. So logic gate mein minimum number of NAND and NOR, and the question based on the logic gate and the homework what we have given, the practice sheet solution. After that, we'll start the minimization, Boolean algebra and K-map, right? First, let me give you the brief idea of what we have learned, right? We have discovered the XOR gate as well as the XNOR gate also. In the XOR gate, what we have covered, A XOR A, bole to 0, and A XOR A bar bole to 1. And if one come inside, another should go outside. In the A XOR B is called A bar B plus A B bar in the SOP form. In the POS form, A bar plus B bar dot A plus B. Sandeep, a very good morning, beta. After that, we have discussed in the XOR gate, ki sir, in the XOR gate, whenever the odd number of ones are basically connected in the input, then output is going to be high. Otherwise, the output is going to be low. XOR gate is also in the both for the 0 and 1, both are basically enabled. Or for the 0, it is enabled like buffer, and for the 1, it is enabled like inverter. A XOR A so many times, there will be the 2 value you will get, either 0 or A. 0 for the even number of A, and A for the odd number of A. That's what we have covered. Apart from this, we have also discussed the XOR follows the commutative as well as the associative law. And A XOR B XOR C bole to 1, 2, 4, 7. After that, we have started the XNOR gate. XNOR gate is called just reverse of XOR gate, but it is happened only when the even number of variables are there. XOR gate, XNOR gate is reverse of XOR gate only for the even number of variable. For the odd number of variable, XNOR and XOR both are basically same. So we can say that A XNOR B is called a complement of the XOR gate. And again, we can write into the two-way. This expression we can write into the two-way. One in the SOP form and the second one is in the POS form. In the SOP form, we can write A bar B bar plus AB. In the POS form, we can say that A bar plus B dot A plus B bar. How we can correlate these two things? First and first position is the complement of each other. Then first you can write with the last and last you can write with the first. So A bar B bar plus AB, you will get it. XOR is just a complement of something XNOR gate, so we can say that 0, 0, 0, 1, 1, 0, 1, 1. For both the same, the output is 1. If the complement of each other, the output is going to be 0. Reverse, we have written whatever we have applied into the XOR gate. So if A and B both are basically same, the output is going to be 1. If both are basically complement of each other, the output is going to be 0. And that's why we can say that A XNOR A bole to 1, A XNOR A bar bole to 0. So one come inside, another should go outside. So A XNOR A bole to 1, so A XNOR 1 bole to A. A XNOR A bar bole to 0, so A XNOR 0 bole to A bar. Like that. Then we have discussed in the both also. XNOR gate also, for the both for the 0 and for the 1, it is enabled. But for the 0, it is enabled like inverter. For the 1, it is enabled like a buffer. In the XOR gate, for the 0 buffer, for the 1 inverter. For the XNOR gate, for the 0 inverter, 1 buffer. XNOR gate will provide you the output 1 whenever the both terminals are basically same. And same means what? Equal condition. So we are going to utilize the XNOR gate to find out whether the two things are equal or not. And that's why we can say that XNOR gate also, we can say that the equal detector, equivalence logic, and coincidence logic. XOR gate is coincidence logic. So XOR gate is anti-coincidence logic. It will also follow the commutative as well as the associative law, means A XNOR B is always equal to B XNOR A. And here the most important thing, A XNOR B XNOR C, means it is looking like this. It is equal to this. Already yesterday also we have made this statement कि one bubble will change the nature. One bubble will change the nature, na? Here how many bubbles are basically? 1 and 2. So this is going to be cancelled out. So this is going to be XOR gate, isn't it? Everyone write down yes or no, yaar? Okay. Then we have discussed A XNOR A is called 1. A XNOR A is called A. How we can say that? Because if odd number of variables are basically there, then it is a XOR only. In the XOR also, you can feel A XOR A is called 1 only. But otherwise, if it will follow the commutative law, associative law, you can think like this: A XNOR A, same. So 1 XNOR A, 1 XNOR A again A. So you will get it. And A XNOR A, lots of time, this is the output is called nothing digestive. Right? Okay. Okay. Now, so A XNOR A, lots of time will again give you the 1 or A. 1 for the even number of A and A for the odd number of A. That's the meaning of this. Now we already know that this is a very, very important slide, guys. What we have discussed, XNOR gate is the complement of XOR gate only when the even number of variables are there. And for the odd number of variable, XNOR gate and XOR gate both are basically same. So XNOR gate, no more XNOR gate when the odd number of variables are there. It is a XOR gate. Then we have discussed the alternate symbol. For the AND gate, alternate symbol is bubbled NOR. For the OR gate, bubbled NAND. For the NAND gate, bubbled OR. For the NOR gate, bubbled AND. And for the XOR gate, we know that if any of the one terminal we can bubble, then XNOR gate will convert into the XOR gate. XOR gate will be converted into the XNOR gate. एक टांग तोड़ोगे XOR gate का तो बनेगा XNOR gate, और एक टांग तोड़ोगे XNOR gate का तो बनेगा XOR gate, like that. Right? So we have discussed. और किसी ने बोला दोनों टांगे तोड़ दिया तो XOR itself called XOR. No complement is going to happen. So XNOR itself is called XNOR. XOR itself is called XOR. A bar XOR B bar itself is called A XOR B. If A bar XOR B is there, then only it will become XNOR. Same thing, A bar XNOR B bar. If both are basically bar, XNOR itself is called XNOR. If any one variable is complement, then only, or odd number of complements are basically there, then only the logics are converted, right? Okay. Then we have done some questions based on this. I have given the some homework question. Have you solved this question, everyone? Solve कर लिया था क्या? Done? AB, yes, correct. Okay. So I'm just giving you everyone try to understand. First, let me solve this question. If I will solve this question now, how we are going to get it? Everyone, this is called A XOR B XOR A. Whenever this type of symbol are basically used, any one thing you can complement, no issues for that. But whenever this type of symbols are basically used between the two, you can say that the variable, we can open it as a first ka complement dot second as it is plus second ka complement first as it is. Like that you have to write. So if you want to solve it, we can write first ka complement, first is called A XOR B. Second as it is. Plus first as it is. And the complement. Okay. Now, can anybody give an answer? A XOR B ka whole bar, whether it is a XOR gate or XNOR gate. Can anybody give an answer with it, whether it is a XOR gate or XNOR gate? Sir, of course, it is a XNOR gate, right? Why lots less people responding? This is a XNOR gate. Okay. Now, can I use what should be the equation for the XNOR gate? Yes, sir. XNOR gate is called A bar, B bar plus AB. What is the A XOR B? A XOR B is called A bar B plus A B bar. Can I use the De Morgan's law over here? Yes, sir. We can write A bar plus B bar. Here I'm using the De Morgan's law. A bar plus B. Now multiply all the things, right? If you multiply it, you will get A bar B bar dot AB plus AB dot AB plus A bar B dot A bar B dot B bar A B bar dot A bar A B bar dot B bar. We have multiplied all the things, right? We have multiplied all the things. First, this one we have multiplied with this, then this one we have multiplied with this, then A bar multiplied with these two things, then B bar multiplied by these two things. You will get like that. Now, everyone try to understand. A bar dot A, this is going to be 0. A bar. B bar dot B, this is going to be 0. A dot A bar, this is going to be 0. Right? So what value you will get? Sir, I will get like everyone. AB dot AB, you will get AB only. A bar B dot A bar, you will get A bar B only. A B bar dot B bar. B bar dot B bar itself is called B bar, so you will get B bar. Okay. So this value you will get. Now, one thing more we can do. In the first and the last, can I take the A common in these two things? We can write ना ऐसा लिख देता हूँ A B plus first इसको लिख देता हूँ A B bar plus A bar B. Does not make any difference. Yes, correct Tulika. Now I will take the A common. If I will take A common, it will become B bar plus B and it will become A bar B. So answer is called A plus A bar B. Now maybe you will think this is answer because I have not discussed the Boolean algebra till now. But at this particular moment, I am just using it. Later on, I will explain the Boolean algebra also, where you will get to know all the things, right? So, koi baat nahi. So Abhishek, very good. Now what we can do? Everyone try to understand. Now there will be the one theorem, and that is called distribution theorem. Okay, sir, we can distribute the A with the A bar and A with the B. And that will come under the Boolean algebra. So don't worry about that. People who are not able to do it, forget about that. At this moment, you can understand like this. Okay, we are using the distribution theorem. I can write the word also. In the Boolean algebra, lots of place we are going to utilize. I will discuss this theorem also. A plus A bar is called 1. So answer you will get A plus B. Answer of this one is called A plus B. One question, Divyan sir, I got A XOR B as my answer. I took B common. No issues. If you will take B common, then also you will get the same answer. Look at here. In these two things, I am taking B common. So it will become A plus A bar. Plus this is called AB bar. Now it will become B plus A B bar. Now B we can use as a distribution theorem. We can distribute the B with A. We can distribute the B with B bar. So here it will become B plus A dot B plus B bar. B plus B bar is again 1. So answer is called A plus B or B plus A. Anything you can write. Now I have solved this question also. Everyone try to understand. अब देखो, same thing I will solve into some quick manner. How? A XOR B XOR AB है मान लीजिए. So this thing is applicable only when the same types of symbols are basically there, and only into the XOR it is applicable. In the XNOR we cannot take the common, right? So in the XOR only we can do what? I will take in these two things B common. So it will become A XOR. Here I will take B common. So it will become 1 XOR. Now it will become A XOR B. And if I will take 1 XOR A, can anybody give an answer? What should be the value you will get? 1 XOR A? A bar. So you will get A bar. Right. Now only in these two things you can apply the distribution theorem. क्या कहते हैं? XOR gate operation, right? Otherwise we can do also, right? Here also we can apply. Everyone. But what we can say that if you'll apply it first ka bar, second as it is, plus first as it is, second ka bar, bar B ka bar. So what value you will get here? Here we are getting A bar B. So it will become A bar B plus. Here you will write this is called A. If you use the De Morgan's law, this is called A bar ka bar plus B bar. So this is called A bar B plus this is called A dot, this will become A plus B bar. Now everyone try to understand. Now if you multiply it, it will become A bar B plus this will become one absorption law is also there, because if you write these things na, then the answer of this one is called A only. Look at here. इसका आंसर आपको A ही मिलेगा. चलो मैं सॉल्व ही कर लेता हूँ. A dot A plus A dot A plus A B bar. Can I take A common in these two things? First, yes, sir. So if I will take common, here it will become A bar B. If I will take A common, so it will become 1 plus B bar. 1 plus B bar itself is called 1, so answer will be A bar B plus A. Again, we can use distribution theorem. A bar plus A or A plus B. So answer will be again A plus B. So this one also we can write. So now as a theorem you can understand. वंश तुमको बहुत बुरा लगा, मुझे लग रहा है सर्किट नहीं बताया. अरे नोड गेट लुक एट एक सर्किट बता देता हूँ. अदरवाइज वंश विल थिंक लाइक कि शायद आता नहीं होगा सर को, इसलिए बता नहीं रही. अभी रुको बता देता हूँ नोड गेट का. एवरीवन अंडरस्टूड? So here we can make a statement. You can think like the logic. What should be the meaning of this? If A XOR B XOR AB is there, means whatever is between the XORing we are writing, if in the product terms same thing is basically mentioned, then we can write like A plus B. Or it will be converted into the ORing. And already the second part I have given the answer A XOR B XOR A plus B. What should be the answer for this? Can anybody give an answer? What should be the answer for this? How we can say that Divyansh AB? Anu is writing AB. Why you are saying the answer is AB? Why you are saying that the answer is AB? What should be the rule for it? Yes, Anuj. If one come inside, another should go outside. We have taken this one, so this will go outside. So this is called AB. Very simple. Right? That's why we are getting. So you can understand these two things also, right? In very simple manner. Now, एक वंश के लिए मैं बता देता हूँ कि कैसे चेंज होता है. Look at here, everyone. Suppose I am making NOT gate because one want to know how the 0 is basically converted into the 1 and 1 is converted into the 0. So I can take the transistor. This is called NPN transistor. This is a symbol of NPN transistor, right? Simple by the RTL I'm forming it, right? I'm writing this is called VCC, this is called high, and this is the input, and I'm taking the output from here. Now everyone try to understand how it is going to be converted. Everyone try to understand. This is called transistor. In the transistor, 3 terminals are basically there. One is called base, this is called collector, and this is called emitter. Now at this particular moment, you can understand the one thing only. मैं ज़्यादा detail में नहीं जाऊँगा इसके भी, right? Only 2 things you can understand. In the transistor will work in the 4 mode. That is called active region, reverse active region, cutoff, or saturation. This is the 4 mode of the operation of the transistor. But in our digital logic, generally we are going to utilize the transistor either into, because as a switch we have to use. So we are going to utilize as a cutoff or saturation. Cutoff means short circuit. If anybody will ask what should be the meaning of cutoff, so cutoff means you can think like cutoff. Khatam. There's no more present. That is called cutoff. And if I will ask about the saturation, then you can feel this is a saturation. Short we can write. How the transistor is going to be saturated? It's depend upon what should be the input is basically connected for the transistor. If I will connect to the 0, then transistor is going to be cut off. And if we are connecting the 1, then transistor is going to be saturated. Saturation actually. So मैं एक table बना लेता हूँ छोटा सा, so that you will get it. This is a condition of transistor, and this is your output Y, right? Okay, now if I will connect 0 here, can anybody give an answer? Transistor will go into the cutoff or saturation? Already I have discussed. For the 0 means it is going to be cutoff, and the 1 means it is going to be saturation. So cutoff or saturation? Everybody please respond. Cutoff or saturation? For the 0 it's cutoff, for the 1 it is saturation. So for the 0 the transistor is going to be cut off. Cutoff means open circuit or short circuit? So of course open circuit. Open circuit. So this is open circuit. From where you will get the output? Sir, I'm getting the output. I'm just here, right, to get the output. So in the output, what you will get? VCC you will get, right? And VCC means what? Voltage. That is a high voltage, extremely high voltage. We are saying that this is VCC. So we are getting the VCC only. Output you will get VCC. VCC itself is meaning high, 1. Now, though VCC itself is called nothing, it is just a high. Now if I will apply the 1 instead of 0, if I will apply 1, now the transistor will go into the cutoff or saturation. Cutoff or saturation? So of course the transistor will go into the saturation. Saturation means open circuit or short circuit? So of course short circuit. So I'll just do the short. Now, where you will get output? So now you can feel this VCC is going to be drop out with this resistor. So entire output you will get from here. Because this is 0, low voltage, ground. So directly the ground is connected to the input. You can feel there will be no other resistance or anything is there to obstacle, right? Directly you will get like this. See the short ho gaya aapka. So you will get ground, that is called low. That is 0. So we are applying the input, so you can think like this, right? Actually 0 or 1 is nothing. It is just a voltage level you will get, right? We are representing the voltage level into the binary, that is 0 or 1. But in the actual situation, there will be no 0 or 1. Whenever you want to transmit the data, we are not able to send the 0 or we are not able to send the 1. That 0 or 1 itself is called nothing, it is just a voltage level. So in the circuitry, if you want to represent that the binary is there, no, that's the voltage level is there. Binary voltage level is there. That is called two levels only, right? So you can understand like here you can feel. If I will apply the 0, you will get 1. If you'll apply the 1, you will get 0. That's why we can say that this is nothing, it is just an inverter. So if you'll zoom NOT gate now, so if you'll zoom the NOT gate, inside the NOT gate, you will feel the circuit is like this, right? Everyone understood? Vansh, okay? Like that also for the other circuit also I can make, but it's not in your syllabus. Okay. Now everyone, let's move into the next. Let me discuss some question, but question we'll discuss tomorrow. So that question I will come with the typed format. Okay, have you solved all the DPP? Everyone? क्या आपने DPP solve कर लिए? Everyone? How many of you have solved the DPP? Not all. Okay. So in the weekend, maybe I will take, no sir, some questions are remaining. Okay. So try to complete. Doubts are there? No issues on. I will complete it only 20. Okay. So I will take the one session on, I think, on weekend. Either I will take the live or I will provide you into the recorded format, right? Okay. In your batch also the one section came, right, already came, where you will get the DPP. Practice problem, I think. The name of that is practice problem. Have you seen that in the chapter? बता दो यार. So now already the tech team is basically working on it, one by one, subject by subject. So the DPP also, a practice sheet you will get as a, you can say that in the chapter wise, in the chapter section also. जिसको नहीं हुआ वो हो रहा होगा, don't worry, right? Soon you will get it. So today I'm discussing about the NAND as a universal logic. First, let me discuss about the NAND as a universal logic. Already I've given the idea, NAND is called nothing, it is just a universal logic. So now the question arises, sir, if it is a universal logic, so I am able to design all the logic gates by the NAND gate? Yes. Sir, how? Let me design it. So every logic we are going to design by the NAND gate. So first, let me discuss with the NOT gate first. How we are going to design by the NOT gate, right? How we are going to design by the NAND gate. This is a NOT gate. So if you'll apply the A, definitely the output is going to be A bar. Now my question is, how many NAND gate are basically required to design NOT gate? How many? Sir, कैसी बहकी बहके क्वेश्चन पूछते हो? One only. Still very less people responding. To design a NOT gate, one NAND gate are basically required. To design the AND gate, how many NAND gate are required? Look at here. For the AND gate, if you want to discuss. And again, if you complement it, you will get like this. Now, if I will ask the question, We have discussed NOT gate, we have discussed AND gate, we have discussed OR gate. Now my question is, how many NAND gate are basically required to design XOR gate? How many for XOR gate? So you can feel we are not discussing about the, you can say that this is not a serial number, this is answer. For NOT gate, 1 NAND gate is required. For the AND gate, 2 NAND gate are basically required. For the OR gate, 3 NAND gate are basically required. For the XOR gate, 4 NAND gate are basically required, like that. How? So everyone try to understand. Like this. 4, right? Or you have to design it, because XOR gate only you are able to make whenever you are able to design it by your own hand. There will be no shortcut for the XOR gate, so you can remember it. A and B, and this is called, everyone, this is called AB bar. This is called A. So here you are getting A dot AB bar ka whole bar. By the De Morgan's law, break it. A bar plus AB. Now by the distribution theorem, you can write A bar plus A plus A bar plus B. So in the terminal, we are getting A bar plus B. In the similar manner, you will get here A plus B bar. And this one, you will get nothing. It is just a XOR. Right? So the 4. So whether it is important to remember it? Yes. Okay. Now my question is, can anybody give an answer? For the NOT gate 1, for the AND gate 2, for the OR gate 3, for the XOR gate 4. So how many NAND gate are basically required for the XNOR gate? Can anybody give an answer? For the XNOR gate. कशिश बहुत ही बढ़िया, वंश, जॉन, दीप, बहुत ही शानदार अद्भुत प्रदर्शन रहा है आपका. Fifth is called, I think it is just a XOR gate. Fifth is called, I think it is just a XNOR gate. Right, for the XNOR gate, if you want to just make the XOR gate and just use the one NOT gate in front of the XOR gate. So I will make the first XOR gate. It's looking like this. So here we can say that nothing, it is just a XOR B. Now if you'll complement it, you will get XNOR gate. So now I will complement it. So you will get A XOR B ka bar, and this is your A XNOR. Now can anybody give an answer? How many NAND gate are basically required to design NOR gate? How many NAND gate are basically required to design NOR gate? Everybody. Look at here. In front of the OR gate, if you use the one NOT gate, you will get the NOR gate. So answer is 4. You can design it. And you can design all the logic gate by the NOR gate also. Just prove the NOR as a universal logic. All the logic gate also you are able to design with the NOR gate. So you can use the NOR as a universal logic. nor as a universal logic, right? Reverse of that, yes. So you can make it all the logic gate. What answer you will get, I will show you into the form of table, right? What the answer you will get, I will show you into the form of table. First I am writing NOT gate, then AND gate, OR gate, XOR gate, XNOR gate, NAND gate, and NOR gate, right? Now everyone try to understand NOT gate, AND gate, OR gate, XOR gate, XNOR gate, NAND gate, and NOR gate. Now, if I will solve it, everyone try to understand how we are going to do it for this. If I will make by the NAND gate, already we know the answer. 1, 2, 3, 4, 5. How many NAND gate are required to design NAND gate? Only one. And how many NAND gate are required to design NOR gate? Already we know that. Same thing if I will use the NOR gate. If you want to design. First for the NOT gate, only one NOR gate is basically required. Otherwise, बाकी के दो चीजों को shuffle कर देना. These two things we have to interchange. You will get the answer. Shuffle these two things, right? So here you will get 3. This will become 2. This will become 5. This is called 4. And this is called 4. This is called 1. This is the answer you will get. So how many NOR gate are basically required to design AND gate? 3. So just like how you are designed NAND gate now, in the same structure if you make, you will get AND gate into by the NOR if you make, you will get AND gate. How many NOR gate are basically required to design OR gate? 2. How many NOR gate are required to design XOR gate? 5. So like XOR, right? Like this, if you make by the NOR, if I will replace the NAND gate with the NOR gate in this structure, the answer you will get the XOR gate, XNOR gate. So reverse of XNOR gate, you will get XOR gate. So if I will replace this circuit with the XOR gate, with the NOR gate, are you getting my point? Then this is not a XNOR, this is XOR gate actually. You will get. अरे समझ में आ रहा है ना कुलना कि मैं क्या बोलना चाह रहा हूँ कि कुलना के जो XOR की तरह है, if you will replace the circuit of XOR gate of the NAND gate with the NOR gate, you will get the answer of XNOR gate actually. Everyone write down yes or no. That's the answer is 4 and 5. 5 for the XOR gate 5, XNOR gate for the 4. So hope you guys understood this point. Now to the class. Okay, only the one lecture is remaining till Friday. Okay, that's great. So just tomorrow only it is going to be. Okay, that's great. So everyone, let's move into the next. But the next part is called, because after that we have to discuss how we are going to find out the minimum number of NAND gate and NOR gate. And for those class, at least it will take 2.5 hours. So I'm not going to start those class. Tomorrow will complete, but some question I am just giving you, right? कुछ questions मैं आप लोगों को जरूर करा देता हूँ. Question भी कल ही करवाना था, but और चलो एक part तो करवा ही देता हूँ at least. How we are going to find the minimum number of NAND gate, right, or NOR gate? So make a heading. How to find out the minimum number of NAND gate and NOR gate? Just make the heading. Finding the minimum number of NAND gate and NOR gate. from the last, I think 3 to 4 years, from this particular topic, they never asked the question. So in GATE 2026, this is the most probable topic you can see. From there, we can expect the question, whether into the direct form or indirect form from this topic. Finding the minimum number of NAND/NOR gate. Everyone try to understand. I'm just forming some cases so that you can understand in very smooth manner. Let me discuss the first case, case 1. Let me discuss the case 1, right? What should be the meaning of case 1? Everyone try to understand. Case 1 is called when all the variables are basically given with the dot product. Like if the variable is basically given like dot A, dot B bar, C, D bar, dot like this. So there will be the no plus sign. Only every variable is given with the product terms only. So I can write when all variables are with dot sign only. All variable are basically given with the dot sign, right? Then how we are going to find out? So everyone try to understand. So पर उससे पहले इस केस से भी पहले if I will ask the question 1, find the minimum number of so that I can correlate with the first case, right? Find the minimum number of 2 input find the minimum number of 2 input NAND gate required find the minimum number of 2 input NAND gate required to implement the function given below. And the function is called and I'm giving you the options also A 0 B1 C2 D7. Can anybody give an answer for this question? Find the minimum number of 2 input NAND gate required to implement the function for this, right? Everyone please respond for it. So if I will minimize this expression, I will take the A common. So I will take the A common. So it will become 1 plus B bar plus BC. And if you understood, already I have discussed, 1 ORing anything will become, we already know that, 1 ORing anything will give you 1. 1 ORing anything will give you 1. So F is called nothing, it is just A. Now to implement A, how many NAND gate are required? And that is also in the question that talked about the minimum. So what minimum means, suppose A, B, C, this is called nothing, it is just an input. And this is called your output. Output is represented as a F, right? So now in the input, if you have A, why should we use the NAND gate? Just take the wire and take into the output, you will get A. So how many required? Sir, 0. Right? No required, only the one variable you will get. By the wire only you will take into the output. So no need. The minimum they are talking. No? So the correct answer of this question is nothing, it is just a 0. Now, hope you guys understood. Now, if I'm asking the one more question, find the minimum number of 2 input NAND gate required to implement the function, and the function is f equal to a bar dot bc. Now, can anybody give an answer? How many NAND gate are basically required to implement this function? Let me give you the options also. Everyone just give an answer of this question. Now, sir, why you have given the answer? Still, you have not discussed any approach how we are going to solve it. Directly, you have to ask the question. It's not good, na? First, you have to tell how we are going to solve it. Then only we are able to solve it, isn't it? ये तो मजे ले रहे हो आप. No, forget about the NAND gate. Sir, I do not have any idea about the NAND gate, how we are going to make the NAND gate. But yes, if you will ask how we are going to implement this function by using AOI, means AND or inverter, by the logic gates, basic logic gates, we are able to do it. How? Look at here. Two input only they are talking about. That's why we are using up to 2 input. Like this, we can say that. We are not able to make the 3 input here. Right? We can make like this. Now, everyone try to understand. This is called A. This is called B. This is called C. How many are basically required so that the output is called nothing. It is just A bar B C. Now, I do not have an idea about how many minimum number of NAND gates are basically required to this particular function. But yes, we know that. By this, you will get the A bar B C. Now, the question arises, how many NAND gate are required to design NOT gate? How many NAND gate are required to design AND gate? 2. How many NAND gate are required to design this AND gate? 2. So answer will be 1 plus 2 plus 2. So answer will be 5. 5 is the correct answer. Already you guys have given the correct answer for this. Now maybe everyone, maybe some of the people will think, sir, I will make with the A bar B with the AND gate, and then also one NOT gate and 2 AND gate is basically required. Whatever the combination you will take, you will give the 5 answer only. Whatever the combination you will take, always 2 AND gate and 1 NOT gate is basically required to implement this function. Isn't it, everyone? Write down yes or no. So if you understood it now, so I'm just giving you, either you can make like this and then you can implement it, taken as input. No. In this, complement is not available, Chiranjeev. If the complement is available, then only the 4 is the correct answer. Function, मैं लिख देता हूँ. If the complement is not available, if complement variable not available. Okay. हाँ दिव्यांश, NOR gate is ठीक. Okay. Now, I will discuss those points also. Don't worry. I will take this question again, right? But at this particular moment, whenever the finding number, sir, I do not have any time how we are going to solve it. But when A dot B bar dot C dot D bar like this function is given, how we are like this? देखो ये भी तो ऐसे ही दे रखा है. A bar dot B dot C. So all the variables are basically given with a dot only. Then directly also you can use the formula. What should be the formula directly you can use? Here we can say that suppose n we are writing as a number of variable, total number of variable. N is called nothing, it is just a total number of variables. And K is called total number of complement variable. total number of complement variable. For example, suppose the function is given a bar bc. So all variable is basically given with the dot, yes. Total number of variable is called 3. So n is called 3. And k is called how many variable are basically in the complement 1. So k is called 1, n is called 3 for this expression. Then directly we can use the formula. What is the formula, everyone? Minimum number of 2 input NAND. And here I am writing minimum number of 2 input NOR. If the complement is not happening, right? So we can say that for the 2 input NAND gate, the formula is 2n minus 2 plus k. And for the minimum number of 2 input NOR gate, the formula is 3n minus 3 minus k. So we can use when the 2 input NAND gate, they are talking about if all variables are basically given with the dot, the answer formula will be 2n minus 2 plus k you can use. If minimum number of 2 input NOR gate, they will ask, the formula is 3n minus 3 minus k. How this formula is going to be derived also we can think on it. But before going to that, let me give you that question, right? हमने क्या question पूछा था? If f equal to a bar bc. So how many variables are basically there? For 3. How many variables are in the complement form it is given? And whether this is a part of case NAND or NOR gate is 2 input gate. Rohini, at this particular moment, I am discussing about the 2 input. Even in your exam also, they will ask about the 2 inputs only. But if they will ask about the 3 input, 4 input, I will discuss those things also later on, right? Because in the standard form, they will talk about the 2 inputs only. So if they are talking about, if I will talk about the minimum number of 2 input NAND gate, minimum or NAND gate, if I am talking about, how many inputs NAND gate? 2 input NAND gate. The formula is 2n minus 2 plus k we can use. So 2 into 3 minus 2 plus 1. 6 minus 2 plus 1. 4 plus 1. So answer is called nothing, it is just a 5. Already we have discussed the answer is 5. For NOR, if we are talking about 2 inputs NOR gate, formula is 3n minus 3 minus k. So 3 into 3 minus 3 minus 1, k is called 9 minus 3 minus 1. So 9 minus 3, that is called 6, 6 minus 1. So for the NOR gate also the 5 required. So people who has given the answer 7, Divyansh, not 7, the answer is called 5 only. So for this a bar dot bc, NAND gate is also 5, or NOR gates are basically also 5 are basically required. Understood? Understood? Now by the formula, how I will derive it also, don't worry. मैं derive भी करवाऊंगा इस सब चीजें. But for the uses of formula, I am giving you one more question, right? If I am giving you a bar dot b dot c bar dot d, you have to find out how many 2 input NAND gate, how many 2 input NOR gate are basically required for it. You can consider this question as a homework, right? Okay. You can solve it. Consider it as a homework. This is my Telegram channel link, right? QR code. So if you want to join, because if you want to interact with me, right, you can ask the digital logic question. You can ask right into this channel, and this is the main channel, right? Okay. चलिए भाई साहब start करते हैं. Okay. So what we have discussed, we have already discussed about how we are going to find out the minimum number, or first case we have discussed, right? So now we are going to discuss in very much of detail regarding to the minimum, finding the minimum number of NAND gate as well as the NOR gate, right? So today class, what we have learned is, sir, we have discussed about the case 1. We have discussed about the case 1. And case 1 is called what? Ki sir, if all the products are basically given, already we have discussed ki sir, this is called if A bar dot B dot C dot D bar dot, like. So all the variables are basically given with the dot product only. If all the variables are basically given with the dot product only, Harshit, right? Then how we are going to do it? So then we have to remember the one thing. N is called total number of variables. Then it is called total number of variables. K is called total number of complement variable. Total number of complement variable. And here we have discussed ki if you want to find out the minimum number of 2 input NAND gate or NOR gate, so it must be looking like this, right? That is for the number of NAND gate, 2 input NAND gate, where the complements are basically not available, right? Then it is answer. Or if you want to write NOR gate, 2 input only, right? Then 3n minus 3 minus. That is the formula you have to remember, right? Isn't it, everyone? This, if you have understood this point, let's move into the right. Okay, now. So everyone, what the question I have given, right? Suppose they have asked the one question, okay, find the minimum number of 2 input and NAND gate required to implement the function given below, and that is f is called. Yesterday we have discussed A bar dot B dot C. Then we have discussed ki sir, if you want to make it, like design it, it must be looking like this. This is called A, this is called B, this is called C. And here we are getting nothing, it is just A bar B C. Now the question arises, the problem whether they have asked about the AOI and or inverter, or they are asking about the NAND gate. In the problem, what they actually asking? In the problem, they are basically asking about the minimum number of NAND gate. They never asking about the AOI. So we know that how we are going to make the NAND gate by the AND gate, everyone. If you want to make the NAND from the end, we have to use the bubble in front of the AND gate, isn't it? भाई end को अगर बनाओगे, this is, if this type of hardware is there, then only the answer is A bar B C. But if you require NAND gate, we have to make like this. If you'll make like this is going to be happen like this. because you can feel na? Here you are getting A bar. This is called BC. So here you are getting A bar dot BC ka bar. You will get like this. Right? But we do not require this bar. So whether, sir, I want to cancel it bar also. And cancel is basically happening by the NOT gate, right? So I can use the one NOT gate here. Now, this bar is cancelled out. Everyone understood? This is bubbled, this bubble is cancelled. Oh. This is bubble is cancelled out by this. So in the circuit, there will be no changes happening. Isn't it, everyone? We have changed one bubble. But to compensate that bubble, we have used the NOT gate. So in the circuit, overall, the equation is same. We are not able to change it. Everyone write down yes or no, please. अरे बोल दो यार. Everyone. कि yes, sir, if we are making the bubble, it is not going to be changed right now. In the similar manner, if I will make this bubble, then equation is going to be happen. This is called A bar. This will become B bar ka C. And this will become A bar dot B C ka bar. This is the output you will get. We do not require, because if we have changed the bubble, we should require the cancelled out also. If we are changing into the any equation, that must be cancelled out. So this bubble is cancelled out by one NOT gate. This is a NOT gate by NAND gate. Now, we have changed it, this is cancelled it. We have changed it, this is cancelled it. And now, so actual answer of the minimum number of 2 input NAND gate to implement this particular function is like, if you want to make it, you will get the answer. This is the answer, right? So 1, 2, 3, 4, 5. So answer is called 5. Now the same problem, if I will talk about how we are going to design, how many are basically NOR. So by the formula also we have done like this. And by the designing, I'm discussing about this, right? In the same problem, if I will talk about, suppose I'm asking about how many NOR gate are basically required to design it. We know the formula. Yes, sir, if all the variables are basically given with the dot product, how we are going to solve it, we know that. But if you want to make it, sir, I do not have any idea about the NOR gate, but yes, if you'll ask about the AOI, we know that how we are going to make it. Like this. Now the question arises, everyone try to understand. Your question is not complete, right? How we are going to make the NOR gate, everyone? If the AND gate is there, what we have learned from the previous concept, sir, if the circuit is basically there and any AND gate is there and we want to make the NAND gate from the AND gate, we have to make the bubble in front of the AND gate. And if we are making the bubble in front of the AND gate, we must cancel that bubble by using the NOT gate. So we have cancelled it. We have cancelled it. So this is the answer. Same thing. In the problem, minimum number of NOR gates are asked. I'm talking right now, I'm talking about the 2 input NOR gate only, and when the complements are basically not available. How we are going to make the AND gate, NOR gate by using AND gate? We already know that bubbled and बोले तो NOR gate. Go to the alternate symbol. In the class, I have discussed about the alternate symbol of the NAND gate as well as the NOR gate. Every logic gate we have discussed, but at this particular moment, if I will talk about the NAND gate and NOR gate alternate symbol, then we can say that bubbled and बोले तो NOR gate, unbubbled or बोले तो NAND gate. That's the meaning of this. So if this is the AND gate and we want to make it in the NOR gate, so we should make the bubble be right as an input of this AND gate. And if we are changing, we are using the bubble, we must cancel out the bubble. So everyone try to understand. Here we can say that we have to make like this. First, we have to make like this. So we want to make it so cancelled out. But by NOR, so we have to cancel it by using NOR. So this bubble is cancelled by the NOT gate. This is a NOT gate by using NOR gate. Now here also the one, but here do not require one NOT gate, because NOT gate is already available. So we can say that I am just forming this NOT gate in the form of bubble. जो NOT gate यहाँ था उसको चिपका के यहाँ लगाया. Either you can make here or you can stuck as a bubble. It does not make any difference, right? So it's fine. Right? Okay. Same thing we can apply here also. Yeah. So this is 1, 2, 3, 4, 5. So answer is called 5. Right? How? By the AND gate, we are making the bubble into the input so that it will become NOR gate. So the overall equation is basically looking like this is the answer you will get, right? This is the answer you will get. Hope you guys understood how we are going to do it, right? Still problem, no issues. I've given some other questions also yesterday, right? What question I have given? Sir, yesterday I have asked the question regarding to this, right? Suppose I have asked the question like this. Output equal to A bar dot B C bar dot D. यही था क्या question? This one is the homework question yesterday. This is the question how we are going to make it by using NAND as well as by using NOR. First, I'm talking about by using NAND gate. Then same thing I will talk about the NOR gate also, right? So everyone, first, if I will use the formula, then we know that total number of variable n is called nothing, it is just a 4. Total number of complement variable is called 2, right? And if I will ask about the minimum number of NAND gate, 2 input NAND gate when the complement is not available. The formula is 2n minus 2 plus k. That is the formula. So if you want to write it directly, we can write 2 into 4 minus 2 plus 2. So answer is called 8 minus 2, 6, 6 plus 2, that is called 8. 8 is the answer you will get. So we are getting the answer, right? But how we are going to implement it? For those things, let me make by using AOI. This is called A bar B C bar D This is called A, this is called B, this is called C, this is called D. Now, maybe the people will think, आप में से कुछ लोग ऐसे भी सोच सकते हैं कि सर मैं A bar C bar को साथ में लिख सकता हूँ, A bar C bar then AND gate, BD then AND gate and then with the AND gate. That also fine. Whatever the combination you will choose, everything you will get the same answer. Now everyone, just discussion, right? Everyone try to understand. In the problem, what they are talked about. In the problem, they talked about the minimum number of NAND gate. So from the AND gate, how we are going to make the NAND gate? We can make the bubble into the output or into the input. Can anybody give an answer? If AND gate is there and you want to make it as a NAND gate, then bubble we can make as a input or output. Samyak, not input, to the output. If you'll make into the input, it means you are making the NOR gate. Right? But here the NAND gate I'm talking about. So this one we can write. And now for the every bubble we have to cancel it also. So we are cancelling out. So NAND से ही बनाना है इसलिए मैं cancel कर रहा हूँ NOR gate. Here we can make. So we can cancel it out. Here we can make. So we can cancel it out. This one by using one node. This one node के लिए तो एक होता है, directly we can write. So how many are the correct answer, everyone? 1, 2, 3, 4, 5, 6, 7, 8. Answer is 8 also. Here also you will get. You can make it now. Answer is 8. Understood, everyone? What we have done, everyone, in this problem? So first we have designed by the basic logic gate, that is AND or inverter. We have designed it. This node, this and this AND. अब ऐसा बना होगा, then only you will get A bar B C bar. But in the problem they are talking about the NAND gate. So now we have made the NAND from the AND gate. How we are making it? By using the bubble into the output. So I've used the bubble so that it will become NAND. Now for the every bubble we must cancel out. So this is for the cancelling out. So that in the expression there will be no change. अगर आप ये लगा दोगे और ये नहीं लगाओगे, you will get like this output. So for the every bubble we can cancel out. For this we are cancelling out. For this we are cancelling out. This is for the NOR gate, one NAND gate is required. For the NOR gate, one NAND gate is required. So answer is 8 only. Now Divyansh understood? Now, if you have understood, I have talked about, instead of NAND, if I'm talking about the NOR gate. What should be the formula for this? Three n minus 3 minus k. So here the formula is called 3n minus 3 minus k. N is called 4, so 3 into 4 minus 3 minus k. How many variables are applicable into the complement? 2. 12, 12 minus 3 minus 2. So 12 9 में से 2 गया तो 700. You will get the answer 7. So by the formula also you will get the answer, right? And now by the approach, if you want to design the hardware, how we are going to do? Now we have to make the NOR gate by using AND gate. How we are able to make the NOR gate by using AND gate? Can anybody give an answer? Whether I can use the bubble into the input side or output side. Sir, from AND to NAND output side. From AND to NOR input side. And every bubble must be cancelled out. If NOT gate is there, attach the NOT gate. If NOT gate is not there, then cancel out. Then make the NOT gate. Like that, to cancelling out. Now everyone try to understand. Here, so to cancel, we are forming like this. Here, to cancel, we are forming like this. इसको cancel इसने किया, इसको cancel इसने किया. Now this is a NOR gate, this is a NOR gate, this is a NOR. Now, for one NOT gate already there. एक तो था ही. So we are making it. Second we are making, so we can cancel out also. एक node gate था ही, one node gate is already there, so we are attaching it. Second node gate is not there, so we can make the. So everyone try to understand. Because for this bubble, make and cancel out. So why should cancel out if already available? So we are not making it. Already available, we are using it. We are using it. This one we have made, so we have cancelled out. This one we have made, we have cancelled out. This one we have used only. So this is a one time only we have used. Already into the circuit available, right? So answer is 1. This is also NOR gate. So 1, 2, 3, 4, 5, 6, 7, 7. So answer is 7. Understood, everyone? Now, if I have understood, I'm just giving you the few questions also. Just try to solve this one. चलिए भाई साहब, ये सारी चीजें आपने कर ली तो देखो. First, let me solve this question, right? I will make it, everyone, by the formula first. Formula everybody knows about that. Whether this is a case 1 or case 2, so definitely is a case 1. Why we can say that this is a case 1? Because all the variables are basically given with the dot product only, right? So we can say that this is called A bar. B bar. This is a AND gate. C bar. D. This is a AND gate. Like that. This is going to be A bar, B bar, C bar, and D. One thing more here, if you want to write, total number of variables is basically given total for, yes, 4. Complement variable is basically given 3. So if I will discuss about the NAND gate, minimum number of a NAND gate for this particular problem, if I will talk about how many NAND gate are basically there to implement it, so we can say that the formula will be 2n minus 2 plus 8. So if you write it, 8 minus 2, 6, 6 plus 3, so 9 is the answer. Right? Isn't it, everyone? 4 दूनी 8, 8 में से 2 गए 6, 6 plus 3. Yes, 9 is the answer. For this one, if you want to make it, everyone, how it is going to be happen? Sir, by the end, if you make the NAND, we have to make the bubble and we have to cancel out. Cancel out. We can make it, we can cancel out. We can make it, we can cancel out. And the output, there will be the NOT gate is there, I can use as a bubble. यहाँ पर कहीं नोट होता तो हम उसको बबल की तरह यूज कर लेते, बट नोट देयर, दैट्स व्हाई वी हैव मेड द बबल and we have cancelled out. We have made the bubble, we have cancelled out. Whenever in the input we can make the bubble, then NOT gate is there. We can utilize the NOT gate. Do not require to cancel it. There are available already. We can utilize the bubble, right? So answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. So answer is 9 only. How many of you are getting the same hardware? Everyone write down yes or no. How many of you are getting the same hardware? बहुत ही बढ़िया, बहुत ही शानदार, लाजवाब, excellent. By the NOR, if you want to implement it, everyone, how we are going to do it? By the NOR, if you want to implement it, look at here. If we'll use the formula for the NOR, we know that the formula is 3n minus 3 minus k. And we can use this formula because this is the part of case 1, right? That's why we are using this formula. So n is called 4, so 12 minus 3 minus 3. 9, 9 minus 3, so answer is 6. 6 is the answer you will get. Now how? So everyone try to understand. If I will make it, Now everyone, we have to make it the NOR gate by using AND gate. So from the AND gate, if you make, we have to make the bubble into the input and we have to cancel it out. So if it is not available. So here I can make a not available, so we can cancel out. Here we can make not available, so cancel out. Here we can make but already available. Look at here. Here the available, so I'm directly using it. Here already available, so I'm not placing here. I'm just placing inside this. Does not make any difference. Here also, so I can use it. Only here it is not available, so I can use it, so cancel out. So answer is 1, 2. This is also NOR gate, right? Bubble and itself is called NOR. So 1, 2, 3, 4, 5, 6. So answer is called 6. Understood the hardware? How many of you are getting the same answer? In the question, if I've talked about, find the minimum number of 2 input NAND gates are required to implement the function given below. A bar, B bar, C. How we are going to do it, everyone? So look at here. Look at here. This is called A, this is called B, this is called C. So definitely we are getting A bar, B bar, C. Now, by the NAND we have to do it. So make it and cancel it. Make it and cancel it only. So how many? 1, 2, 3, 4, 5, 6. 6 is answer. Now I'm clear about NOR gate. Okay, Mukesh, that's great. That's great. Now, if you use the formula N, we already know that 3. K is already, we know that no, 2. So for the NAND gate, if I will talk about 2n minus 2 plus K. So 6 minus 2, 4. 4 plus 2. So from here also you are getting the same answer. Sometime if they will ask about the hardware, then you have to remember like this. If they will talk about the numbers, you can remember the formula. By the formula also you will get the answer, right? Isn't it? Now, same thing by the NOR gate if we will talk about, you know that n equal to, for the NOR gate if you want to write, formula is 3n minus 3 minus. This formula is applicable only when all the variables are basically given with the dot product only. Then only we can use this formula. So n is called 3, 9 minus 3 minus 2. 6 में से 2 गया, so answer will be nothing, it is just a 4. 4 is the answer. How? Let me design it. Right now, if I will do it, everyone try to understand how. For this particular problem, if you want to write A bar, B bar, everyone. So for we are making the NOR gate. So for the NOR gate, input bubble is there. Now, if there is any node gate is there, you can use it, but no node gate. So we can make the bubble, we can cancel out. We can make the bubble, we can cancel out. Sometime if the variable allowed, if they will say, then do not require to make the bubble bar. Either you can make the bar or you can make node gate. Does not make it anything. One you can do. अगर complement available है तो. And for these two things, we can utilize directly. So 1 NOR gate, 2, 3, 4. Answer is 4 only. Answer is 4 only, right? Okay, great. Now I'm giving you one question as a homework, everyone. That is the homework question I'm giving you. A bar, B, C bar, D, E. NAND gate also you have to find and NOR gate also. And not only the answer, we require the formula also for this, right? So you can take as your homework. How many of you are able to do it? This is the homework question, right? कितने आप में से जो कर सकते हैं इस homework को? Very good. That's great. That's great. So now we are moving into the next same problem. If I'm talking about the now case 2, let me discuss the case 2. Case 2. What is the case 1? If all the variables are basically given with the dot product. So now I'm forming the case 2. If all the variables are basically given with the plus sign only, there will be no dot product. Like this. A bar plus B plus C bar plus D plus like only plus. So let me write all the variables. There will be no dot sign, only the plus sign is there, right? Then how we are going to solve it? Then you have to remember again, the n is called total number of variable. Total number of variables. K is called total number of complement variable. N is called total number of variables. K is called total number of complement variable. And then whatever the formula you have learned, just interchange the formula for the NAND and NOR. Just interchange the formula. For the NAND formula, answer will be 3n minus 3 minus K. And for the NOR gate formula, 2n minus 2 plus K. So we have just interchanged the formula. Whatever the formula is there for the dot product only. Here we have interchanged the value. That's it. We have done. How we are going to utilize? So everyone, let me give you the one question. By the help of the question, we are going to understand it, right? Okay. Suppose I'm taking the one example, and that example is, suppose I'm giving you f equal to a plus b plus c. And now I'm talking about how many NAND gate and NOR gate are basically required to implement it. First NAND gate and then NOR gate. Now look at here. In this case, we can say that n value is called what? Whether it is a case 2 or not case 1, everyone. Whether it is a case 1 or case 2, so definitely it is a case 2. Why we can say that the case 2? Because all the variables are basically given with the plus sign. There will be no dot product is there. That's why we can say that it is a case 2. So n equal to 3, and how many variables are basically given in the complement? So 0. So for the formula for the NAND gate, here the formula is 3n minus 3 minus K. 9 minus 3 minus 0. So answer we are getting 6. How? So let me design it. Answer you will get 6. So let me design it. So this is called A plus B plus C. This is the answer you will get, right? Now everyone, answer नहीं. अब यहाँ से बनाएंगे. Now everyone, just give me the answer. We want to make NAND gate by using OR gate now. So how we can say that, how we are going to make the NAND gate by using OR gate? We can make the bubble into the input or bubble into the output. Archita, very good. Input, yes. Because bubbled or bole to NAND gate. And whatever the input is there, if there will be the no node gate is present, we have to cancel it also. So we are forming it and then we are cancelling it. We are forming it and then we have cancelled it. So this one is cancelled by this one is cancelled by this. We are forming it and node gate, NAND gate se banana hai. So we are cancelling it. So how many is the answer? 1, 2, 3, 4, 5, 6. 6 is the answer. Magesh, are you getting my point? Everyone. Instead of NAND, if I will talk about the NOR gate, can anybody give an answer? What should be the answer you will get for this? For the NOR gate, what should be the answer for this? Four, very good. Look at here. For the NOR gate, if it is a case 2, so formula is 2n minus 2. Do not confuse with the formula, right? So 6 minus 2, that is called 4 plus 0. So answer is 4. How 4? Everyone try to understand. Right? Input out NOR. So we can make into the output and we can cancel that out also. So we are making it and cancelling it by the NOR gate. We are making it because for the OR, from the OR, if you make the NOR, we have to make the output into the bubbled into the output. And we can cancel it. So 1, 2, 3, 4. So answer is 4. Yes. One more question I'm asking. A bar plus B plus C. For this one, NAND and NOR both you have to write. A bar plus B bar plus C. NAND and NOR, to input also, by the formula and without the formula also. Everyone just solve this 4 question. Not 4, 5 question. And the all question you have to solve by the NAND as well as by the NOR. By the hardware, I'm not interested into the numbers now. I'm interested into the hardware. Right? Just solve it. 5 question I'm giving you. 1 minute for the NAND, 1 minute for the NOR. So I'm just giving you 10 minutes for that. Same ही मिला होगा यही. The same you will get, right? Now same thing if you want to design by the NOR gate. Fine. Maybe some of the people can think, sir, I have just taken A bar B and then with the C. Does not make any difference. You will get the same answer. Look at here. If you are making like this, that's also it's fine. One, two, three, four, five. Answer 5 is there. Right. By the formula, if you want to write for the NOR gate, if all the variables are given with the plus sign, 2n minus 2 plus k. 6 minus 2 plus 1. 4 plus 1. 5 is the answer. So you are getting the same, right? Now if you are moving into the next. बहुत ही बढ़िया. Now A bar, B bar, C bar you can do. I'm just making A bar, B bar, C, D. Fourth time just for. मैं कोई भी एक दोनों में से कोई एक करवाना चाहता हूँ. Which one I will solve? Let me solve this one, right? Last one. Now for the NAND effect, if you talk about in this particular problem, we'll solve like NAND. So here and to cancel out, we'll make like this. Here to cancel out, we'll make like this. Here to cancel out, we'll make like this. One node is already there, so directly we can connect. One node gate is directly there, so we can connect. And for this, we can make like this. So how many are the basically correct answer for NAND? 1, 2, 3, 4, 5, 6, 7. 7 is the answer. And by the formula also you can solve, right? For the NAND, N is called 4, K is called 2. So for the NAND, if you want to write, because all variables are basically given with the dot product, that's why we can write 3n minus 3 minus k. So 12 minus 3 minus 2. So you get 12 minus 5. You will get the 7 is the answer for this. Same thing if you write for the NOR gate. Instead of NAND, if you design the NOR gate. How we are going to make the NOR by using OR gate? We can make the bubble into the output. So output cancelled out. In the output, cancelled out. In the output, cancelled out. So one NOR gate for this NOT gate, one NOR gate for this NOT gate. So 1, 2, 3, 4, 5, 6, 7, 8. So answer is 8. And now answer is 8. And if you want to, this answer is 8. Apart from this, if you make the next one, that is called, by the formula, if you want to write, 2n minus 2 plus k. 8 minus 2 plus 2. So 8 is the answer. So now how many of you having the command over the case 1 and case 2? Everyone write down yes or no? How many of you having the command for the case 1 as well as for the case 2? Yes, sir. Now if the question will come, I will definitely able to design the hardware. जिसको पहले दिक्कत हो रही थी कि भाई साहब क्या ही बताएं सर. Okay. Yes, sir. Because of the diagram, I am able to visualize. Okay, that's great, Sandeep. So rest question I've given as a homework, right? You have to solve it. टांग तोड़ने में एक्सपर्ट बन गए हो. वो तो XOR और XNOR. अभी तो बबल लगा के भी टांग, बबल लगाना मतलब टांग तोड़ना, बहुत ही बढ़िया. Now I will move. Case 3. Now in the case 3, this is a very important. Everyone try to understand. This is a very important case. If I'm asking the question like F equal to AB plus CD, can anybody give an answer whether it is a SOP form or POS form? SOP, sum of product form, right? I will discuss just after this. I'm just going to start the Boolean algebra only. Boolean algebra में बहुत सारे मैं type form में लेके आऊँगा, right? So that quickly we are going to cover, right? Okay. हालांकि मेरे को तो ऐसे बोर्ड पे लिखने में ही मजा आता है, right? Okay. Now AB plus CD, right? So if you'll observe, this is a SOP expression, right? SOP means what? Sum of product. Sum of product. I will discuss the Sandeep in the 3 input also, don't worry. That is our case 5. 5 or 6, right? Don't worry. AB plus CD, right? If it is given, how we are going to form it, right? So why I'm just forming this case now? Even in the gate exam, if they will ask the question regarding to the minimum number of NAND gate or NOR gate, believe me, every question what they will ask now, you guys are already have done into the classroom those questions. तो आपको ऐसा लगेगा only you can correlate with, oh, this is the case 4 they are talking about. Oh, this is the case 2 they are talking about. Like that you can understand. So SOP form, and now they are talking about the minimum number of a NAND gate for this. They will talk about the minimum number of a NAND gate for this, right? How we are going to do it? So now we do not have any idea about, sir, because this is neither case 1 nor case 2. Why? Because in this function, the plus sign is also there and dot sign is also there, isn't it? Both are basically there. You can observe dot is also there, plus is there. Because for the case 1 only, the dot product must be there. For the case 2, only plus sign is there. Here the dot and plus, both sign is basically given. So this is a neither case 1 nor case 2. So how we are going to make it? Still, if you want to make it, I can make in such a way. Because whenever any expression is No. This is called AB plus CD. This is the function is given. If you want to implement it by using AOI, can anybody give me the answer? What should be the meaning of AOI? AND gate, OR gate, and inverter. AND gate, OR gate, and inverter. Okay. Now, always you can remember the one thing, my dear friend. Okay, whenever your expression is SOP expression, whenever the expression is SOP expression, the implementation will be always AND OR implementation. This is called AND OR implementation. Why we can say that? Sum of products. We have to do the sum, but first we have to do the product. So product is done by the AND gate. So in the sum of product, always the first level is for AND gate and the second level is OR gate. So SOP expression will be always implemented by using AND OR implementation. But in the problem, they are talking about the NAND gate. How we are going to write the NAND gate? Everyone try to understand. Just look at here. If you want to make it, sir, make the NAND gate. And now we can cancel it also by here. If you'll do it here, we can make the bubble, both are basically cancelled out. If we are changing anything, we have to interchange. We have to cancel it also. NAND. So यहाँ बना रहा हूँ. So for cancel out, one bubble is required. So I am forming this bubble here. So how many NAND gate are basically required to implement it? One NAND gate, two NAND gate, and this is bubble door. Bubble door itself is called NAND gate. So how many are basically required to implement this particular function? Answer is 3. Because AND OR implementation itself is called NAND and NAND implementation. This is called NAND and NAND implementation. So now onwards, you can remember, everyone try to understand. Now onwards, you can remember if this type of expression is given. Always you will get AB plus CD. AND OR implementation is always called NAND and NAND implementation. Are you getting my point, everyone? AB plus CD, that is the meaning of this. Always you can understand. Now, suppose I'm asking the one question, everyone. Suppose someone will ask you the question like, if they will ask about what should be the value of Y, can anybody give an answer? What is Y? This question, first everyone try to understand. If I will write this is called A and this is called B, so here the answer will be nothing, it is just a AB plus ST. Have you understood this point? Look at here. This is a NAND and NAND implementation. And NAND NAND itself is called AND OR. So we can feel this is a ending, this is a ending, and this is OR. Everyone, hope you guys understood. Now we have to find out the value of A only. A value and B value. So B is called R. B value already we know that R. Now we can find out the value of A. A is called, look at here, this is called PQ ka bar, and A is called PQ ka bar plus R. PQ ka bar plus R. So A is called R. So everyone just give me the answer. Y is called, so Y is called AB, AB plus ST. So now A is called nothing, it is just a PQ ka bar, R. B is called R plus ST. That is the answer. You can solve it also for this. इसको आप लिख सकते हो, R से multiply कर सकते हो. So you will get PQ का bar dot R plus R dot R, you will get R plus ST. Now we can take the R common from these first two terms. So it will become PQ ka bar plus 1 plus ST. 1 ORing anything will become 1. So answer will be R plus ST. The answer will be R plus ST, yes. Everybody has given the correct answer for this question. R plus ST is the correct answer of this question. Always you have to remember when PQ or AB plus CD type is the answer is given, always NAND implementation is called AND OR implementation. That's the meaning of this. Okay, if I will ask the one question, everyone. How many NAND gate are basically required to design F equal to A plus B? How many NAND gate are required to design A plus B? How many? Already we have discussed this is the OR gate. To implement the OR gate, how many NAND gate are basically required? Already we have discussed now to design OR gate, three NAND gate are basically required to implement it, right? But you can think one more way, right? आप इसको कुछ अलग तरीके से भी सोच सकते हो. कैसे? Sir, already I have given the answer. AB plus CD type function is given. The answer will be 3 only. AB plus CD type answer will be 3. So we can write AB plus CD. So A dot A, B dot B. And that's why we can make, everyone just look at here. A dot A, so both are basically A. B dot B, फिर both are basically B. So this is called A, this is called B. So we can say that A dot A plus B dot B. So this is A ORing B. If no, the answer will be 3, right? If I will ask the one more question. How many NAND gate are required to input? NAND gate are basically required to implement this function. Can anybody give an answer? How many 2 input NAND gate are basically required to implement this function? How many 2 input NAND gate are basically required to implement this function? Three, again we can write, sir, we can think like AB plus CD, the answer will be 3. A dot A or BC. So we can say that A dot A so this is called A plus BC. Answer will be 3 only. John Doe, it's not 4, it's 3. Okay. अगर 4 बोल ही गया राजेश्वरी सर, we do not have formula for, no. Rajeshwari, we cannot use the formula. Even though I'm just explaining the concept, that's why I have given the idea also. In the case 1 or the case 2 also, how we are going to design the hardware. Formula is the secondary for me, right? Here there will be no formula, isn't it? देखो मैं कोई फॉर्मूला यूज नहीं करवाता हूं, तब भी some of the people will think ये तो रटने के लिए बोल देते हैं. Suppose I'm asking the question. Now, can anybody give an answer? How many NAND gate are basically required? 2 input NAND gates are basically required to implement this function. A B bar plus CD. So A B bar is there, so we can write A. Right, B bar. So how we will get the B bar? Sir, for the B bar also, you can feel everyone try to understand if A. This is called A. This is a B bar. This is C. This is D. So we can say that this is a B bar plus CD. But how you will get the B bar from the B? So like this we'll get. So answer will be 4 only. Hope you guys understood, right? Okay. Hope you guys understood. Now, if I will ask the one more question. How many to input NAND gate are basically required to implement this function? AB plus CD plus E. Why other people are not responding? Sir, you can think like A plus BCD as a X. So this is the expression will become X plus E. So we can also write like X dot X. This is a OR gate only. E dot E. So actually for this, if you want to write X dot X, E dot E. Now you have to make, this is called X, this is called E. So now you can make the X is only. X is called nothing, it is just a AB plus CD. This X is called AB plus CD. So for the AB plus CD, again, the three are basically required. So I can make it AB plus CD. This is the answer. Answer will be 6. Everyone understood? सर प्रॉब्लम वो डायरेक्ट कॉम्प्लीमेंट इनपुट में होता है. प्रॉब्लम वो डायरेक्ट इनपुट कॉम्प्लीमेंट में. इफ द कॉम्प्लीमेंट ऑफ द इनपुट्स आर अवेलेबल, देन if the complements are basically available, then it's fine for you, right? Directly आप complement use कर सकते हो, no issues for that, right? Because here the E bar is required, so these two things we can skip out. I will discuss, don't worry, मैं वो सब भी बता दूंगा, don't worry. तो मैंने बताया ना, पहले मेरे हिसाब से सीखो चीजों को. First you can learn from my point of view. Automatically that point also you are going to cover, right? Automatically you can think. Now, if you understood it, let's move into the one more question. Suppose मैं आपसे एक और question दे दूं. And if I will ask the question, Can anybody give an answer? How many NAND gate are required to implement this function? AB plus CD plus EF. Again, the 6. Right? This is going to be like happen like this. Answer will be 6 only. Okay. अगर मैं एक क्वेश्चन और आपसे पूछता हूं, instead of this, if I will ask the one question. But I am talking about 2-input NOR gate. Are you able to solve it? If I will, instead of NAND gate, I am talking about the NOR gate in this problem. Are you able to do it? How, everyone? I am just making it by using AOI. And now they are talking about the NOR gate. So how we are going to make the NOR gate? By using OR gate. Cancelled out. Here how we are going to make it? One, two, three, 4, 5, 6, 7, 8. Answer is 8. Understood, everyone? And what is the right note? Whenever in the problem, minimum number of the minimum number of whenever in the problem the minimum number of NAND gates are asked, then write the function in SOP form. Then only into the SOP you will get the you can say that the minimum numbers, right? Then always first you have to write in the SOP form, then write the function in SOP form, then write the function in SOP form and implement it by using AOI. AOI means what? AND OR inverter, right? Already I've given the idea. So whenever in the problem NAND gate are asked, write the function in SOP form and implement it by using AOI. If you will implement it by using AOI, means always you will get the 2-level AND OR implementation, right? So implement it by using AOI, which is and or implementation, which is a and or implementation. Which is a and or implementation, and this is exactly equal to, and this is exactly equal to NAND implementation. This is exactly equal to NAND implementation. So what actually I have implementation? So what I have made this statement? The statement is very simple, and that statement is that whenever in the problem the minimum number of NAND gates are asked, always you have to write the function in SOP form, and you have to implement it by using AOI. If you'll implement it by using basic gate, you will get always and or implementation, and or implementation is similar to the NAND implementation. That's the meaning of this. So by the case 3 only, you can remember the one thing: whenever the AB plus CD type function is given, the answer will be 3 only. AB plus CD type means answer is 3. That's the meaning of this. AB plus CD, answer is 3, right? Okay. AB plus CD, the answer is 3. Okay, now, if you understood this point, let's move into the next. We'll solve the questions, right? Don't worry. Now, अगर मैं अगले part पे चलता हूँ, if I will discuss about the case 4. And case 4 is given when the function is basically given like a plus b dot c plus d. Can anybody give an answer whether this function is SOP form or POS form? ये function SOP में है POS में? POS means what? Product of sum. Everyone, one thing more you can understand. In the problem I have talked about in the previous case, sum of product SOP corresponding to minimum number of NAND. Then POS corresponding to minimum number of what? Can anybody give an answer? Right? Anyone? Yes, by the NOR gate. So whenever in the problem the minimum number of NOR gates are asked, right? Always you have to remember the function must be written. Function must be written in POS form. Then only you will get the minimum answer, right? Now I want to implement it. So how we are going to implement, sir? Now everyone try to understand, right? So always whenever the POS function is there, you can observe this POS function will be always OR and implementation. This is always OR and implementation. SOP will be always AND OR implementation. POS will be always OR and implementation. But in the problem, they are talking about the NOR gate. So how we can write the NOR gate? For the NOR gate, we can make the bubble. So to cancel out, we are making the bubble. Here we can make the bubble. To cancel out, here also we are making it. If the two bubble, right, in the conjugative, they are going to be cancelled out. Does not make any difference, right? So this is NOR, and this is bubbled and this is bubbled, cancelled out. This is bubbled, cancelled out. So in the overall expression, you are getting A plus B, C plus D with the dot product. So now everyone try to understand OR and implementation. Can I write it is NOR, it is NOR, it is also NOR? Because Bubbled AND itself is called NOR gate. So OR AND implementation itself is called NOR implementation. Our answer will be what? Answer will be 3. And here we can make a beautiful expression, right, discussion. And that note is similar to this note. You can write into the note. Whenever in the problem the minimum number of, instead of NAND gate, if the minimum number of NOR gates are asked, then write the function in POS form and implement it by using AOI, which is not AND OR, which is OR AND implementation. Which is OR AND implementation, and this OR AND implementation itself is called NOR implementation. That's the meaning of this. So everyone, what I'm just clubbing these two statements. Whenever in the problem, the minimum number of NAND gates are asked, write the function in SOP form, implement it by using AOI, which is a 2-level AND OR implementation. AND OR implementation always equal to NAND AND implementation. Whenever in the problem the minimum number of NOR gates are asked, write the function in POS form, implement it by using AOI, which is always a 2-level OR AND implementation. 2-level OR AND implementation is exactly equal to NOR implementation. That's the meaning of this. Everyone understood this point? Write down yes or no. Everyone. Always try to understand whenever the XOR type of expressions are basically there. Whenever in the problem XOR type of expressions are basically there, always you can follow when A bar B plus AB bar or A bar plus B bar dot A plus B. Both corresponding to what? A XOR B. But this is in POS form and this is in SOP form. That's the meaning of this. Right? But both corresponding to XOR gate. Achha, case 5. Okay, sorry. When this type of expression is given, always you have to remember the answer will be 4 only. इसको XOR को एक स्पेशल केस मान के याद रखिएगा. You can remember it by the special case, right? So we already know that here you are getting A bar plus B. In this point, you will get A plus B bar. So this is called A bar plus B dot A plus B bar ka whole bar. This is a XNOR gate expression actually. So XNOR ka bar, XOR gate only. Otherwise, you can break it also. A bar plus B ka whole bar plus by the De Morgan's law, I'm breaking it. So dot will become plus, plus will become dot, right? Again, we are breaking it, so it will become AB bar plus. Break the line, change the sign, so it will become A XOR. So whenever the XOR type of expression is given, the answer will be always 4, you can understand, right? Okay. Let me give you the one more question, everyone. If you understood this point, let me give you the one question, and that question is, can you correlate it? He said this is an expression corresponding to XOR gate. Similar type of XOR gate. If either the Y and Z is there, here also YZ, this is the XOR gate expression. Only the variable is going to be changed. So here some different variable, look here. This is also same variable is there into the complement. That's why we are taking the same variable. If different variable is there, you can use the different variable, right? So look at here. This is also the similar type of expression is there, right? Look at here. I'm writing this is W, this is X, this is Y, this is Z. Now everyone, just look at here. What should be the value you are getting? Here we are getting W dot XY ka bar dot Z dot WX bar ka whole bar. Now by the De Morgan's law, we'll break it. W dot bar plus Z WX ka bar. Because if we break it, this bar and this bar is cancelled out. Now WX bar I'm taking common, so it will become Y plus Z. Here you can write W bar plus X bar, Y plus Z. This is answer. So how many are basically required? The answer is 4. So answer of this problem is nothing. It is just a 4. Hope you guys understood. Everyone write down yes or no. Understood this point? Now, let me write the case 6. Right, with the multiple inputs. और इसको कुछ नहीं, इसको miscellaneous नाम दे दो. Miscellaneous, right? ये क्या लिख दिया मैंने? Miscellaneous की जगह लिख दो कुछ मत डालो, बस समझ लो. Right, everyone. You can use miscellaneous, anything you can write. Suppose I'm writing the function is called AB C plus DE, and I'm talking about how many minimum number of NAND gate are basically required to implement this function, and the input is not mentioned. Any of the input is basically available, right? So if you want to solve it, I can make it like A, B, C like this, D, E is like this, and with this OR gate. So rule is the rule. Whatever we have learned, that is the most important rule. Now we are going to apply this rule into the everywhere, right? So if you want to solve it now, the answer is called what? A, B, C plus D. And now if they were talk about the NAND gate, we can say that this is a NAND gate, so we can make it. This is a NAND gate, so we can make it. So one 3-input NAND gate is required. If the 2 input is there, how we are going to do it? We know that. We can also split into the 2 parts. But here we can say that this 1, 2, 3, so answer is 3. Right? If inputs are basically not mentioned, if more than 2 inputs are allowed, if I will write more than 2 inputs are allowed, if more than 2 inputs are basically allowed, then we can say that. Now everyone, suppose in the similar manner, if A, B, C is basically given D, 2 input NAND gate they are talking about, 2 input NAND gate. How we are going to do it? If the 2-input NAND gate is there, right? Like that you can form. Now everyone try to understand. ये दो part तो मुझे पता चली गया. This is a NAND, मतलब 1, 2, 3 NAND is basically required for this. Because AND/OR implementation itself is called NAND implementation. Only we can focus on this particular part. How many NAND gate are required to design AND gate? Can anybody give an answer? How many NAND gate are basically required to design AND gate? So actually you can think like this is a NAND, this is a NAND, this is a NAND, this is a NAND, like this. So this is a 3 NAND gate, right? Here you will get 3. But for this one and 1 is basically required to cancel. So answer will be what? 2 for this. So 3 plus 2, answer will be 5. Hope you guys understood how we are going to solve this, right? Isn't it? आपको split करना पड़ेगा. Whatever we have learned, the concept, you are going to split it, right? Into that way. Understood everyone? Write down yes or no. Now. So now I think you guys are able to think how we are going to correlate whatever we know that, right? जो हमें पता है उस पर कैसे correlate करके हमको आंसर निकालना है. That's the most important. Now, let me give you the one more thing, right? Suppose if I will ask the question like, and now I'm talking about, can you find out how many NAND gate are basically required to implement this function? Everyone. Now you can feel everyone. Now we can say that this is the answer you will get, isn't it? This is the answer you will get, right? Now the question arises, sir, how we are going to find out? Look at here. इसने एक problem खराब कर दी. Otherwise, it will become very simple for you, right? So do one thing. Here we can make the NAND. So here it is. So this is a cancelled out. Here we are making. So we cannot put, if you put this from here, again here is required. So better you can cancel out. एक बना के cancel out कर दो. So your answer will be, this is already the NAND. So answer is 1, 2, 3, 4, 5. 5 is the answer. 5 is the answer. Now, suppose same question if they will ask and they will say, complement is available and complement variable is available. So now can anybody give an answer? How many answers are basically, what should be the answer? If the complement is available, what should be the answer for this question? Yes, do not require this. You can, instead of this, you can use a bar. So answer is 1, 2, 3, 4, 4. Hope you guys understood how we are going to correlate it. Everyone. Now hope you guys understood how we are going to correlate it, isn't it, everyone? Right, okay, now. So this is the some of the things we have discussed, right, in the today's class. I will discuss the remaining questions based on this also. Maybe Saturday or Sunday I will take the class. There I will discuss all the things. Okay. So guys, we have discussed the 5 cases here. Let me give you the brief idea what we have learned till now into the 5 cases. एक बार समझिएगा क्या हमने डिस्कशन किया. This is topic. This is a very important slide for you guys. Okay. This one we have discussed the first case. In the case, whenever all the variables are basically given with the dot product, whenever all the variables are basically given with the dot product and complements are not available, only 2 input logic gates they are talking about, then minimum number of NAND gate is called 2n minus 2 plus k, and minimum number of NOR gate is 3n minus 3 minus k. Then we have discussed how we are going to implement the hardware on the hardware. So AND gate is there and you are making the NAND gate. So we are making the bubble into the output and we are cancelling out also, right? We are going to cancelling out. So we have done like this. But whenever the AND gate is there and we want to form the NOR gate, we have to make a bubble into the input and we have to cancel it out also, right? Like that we have done some questions on it. Right? अब ये सब तो question था. After that, we have discussed the case 2. Whenever all the variables are basically given with the plus sign only, there will be the no dot sign. If then total number of variable is called n, and total number of complement variables are called nothing, it is just a k. Then we can flip the formula. What the formula? If NAND is there, whatever the formula earlier for the NAND, we can use into the NOR. For the NOR, we can use into the NAND. So for the finding the 2 input NAND gate, the formula is 3n minus 3 minus k. And to finding the minimum number of NOR gate, the formula is 2n minus 2 plus k. Again, of course, the plus sign is there, so OR are basically there, right? So for the OR, if you are making the NOR, we can make the bubble into the output and we'll cancel it out. So from the OR gate, if you'll use the NAND gate, we'll make the input bubbled into the input and we'll cancel it out, right? And we have done so many questions based on this, right? After that, we have formed the case 3. When AB plus CD type function is given, right? Whenever AB plus CD type function is given, the answer will be 3. Because AND OR implementation, and AND OR implementation itself is called NAND AND implementation. We have made the one statement. Whenever in the problem, the minimum number of NAND gates are asked. Whenever in the problem, the minimum number of NAND gates are asked, write the function in SOP form implemented by using AOI, which is nothing, it is just a 2-level AND OR implementation, and 2-level AND OR implementation exactly equal to NAND and NAND implementation. That's point we have discussed. We have done some question based on this, right? Always you can remember NAND and NAND and OR. Same. You can make this is AND, this is AND, and this is OR. Like that you can see. We have done so many questions based on this. Then we have discussed next part, that is case 4. Whenever A plus B dot C plus D type of function is given, and they are talking about the NOR gate, that is the products of sum, right? So whenever in the problem, the POS is basically given, or whenever in the problem, the minimum number of NOR gates are asked, write the function in POS form implemented by using AOI, which is always a 2-level OR AND implementation. OR AND is exactly equal to NOR NOR. So AND OR, NAND NAND, OR AND, NOR NOR, like that. And then 5th case we have discussed, whenever the XOR gate type of expression is given, how we are going to implement it, like 4 answers is there. And then we have discussed the 6th, that is when 3 inputs are basically there, how we are going to do it. If the complement variable is there, how we are going. Now you can feel only input bubbled are basically there. Now we can remove it and you can make the bar on the variable. You will get the answer. Like that. So hope you guys understood, right, up to this portion. Everything is cleared.